Hello and welcome to Devfest Norway. It's really great to be here and to have you all here, and it's been a really fun planning and organizing it all for you. So we're organizing this as a cross GDG event across like different GDG groups around in Norway. And here are the organizers of this event for this year. So I would like to pull one of you on stage and just like say a few words. Where are you from, and which GDG do you represent? And go ahead. So I think the first on the screen is Øyvind, so you get to start.
Yeah. Hi, I'm Evan. I'm organizing for GGG Bergen. Yeah.
And then point at someone. Tanas, you're second. Go.
Anas, yeah.
Yeah. Hi, Tanas from GDG Norway, Oslo. I am also an ambassador for Women Take Makers.
Hello everyone, I'm Vaibhav. I'm from the sunny south, the southern Riviera of Norway. I welcome you all to the Devfest, and I hope it'll be a fun day for all of us.
I'm Leonard from GDG Oslo.
And I'm Rustam from GDG Cloud Oslo, and well, a little bit GDG Oslo as well. Thank you all for being here. It's really fun to see you all joining us today. And all the videos and all the talks will be recorded and they will be published online on our YouTube channel as well. So you will get the chance to watch them later as well. So the plan is that we have 14 sessions, and we try to separate them by topic. So there will be a first half dedicated to mobile, web, Android, and Flutter, and things like that. And the second half of the talks will be more related towards cloud, DevOps, and machine learning, and this kind of topics. So I think it's time to, without any further ado, I think it's time to bring in our first speaker, and that is Julien. Hello. Glad to have you here. It's really great to thank you for joining us. You have a very interesting and very special topic. So it's a kind of it's not a web, it's not cloud, like I said at the beginning, but it is at least as important, I think, for all of us, and that's climate, right?
Right. Yeah, that's what we're going to do for 10 minutes.
So I think I will leave the stage for you in a second. So you'll do your presentation, so you have a lightning talk, and then I'll keep an eye on the questions. So feel free to ask any questions in the chat, write them down, and so feel free to ask any questions, anything, and I'll ask Julian afterwards at the end. So I'll be disappearing from the screen. Take it away.
Yeah. Thank you very much. Can you just confirm that you see my screen properly? I guess you do. Okay, I'll just start then. Thanks. Yeah, it's an honor to be able to start the conference. Thank you very much. And it's nice to actually be on the other side of StreamYard for once, not be the host, but actually be an attendee. It's quite relaxing. I'm going to be talking not so long, so grab on your chair. There's going to be a lot of words being said. We're going to talk a little bit about climate change and what we can do as developers, but also human beings. Very quickly, my name is Julien, and I'm officially a developer advocate at Adyen, though this has nothing to do with it today. I've just been recently named Kotlin Google Developer Expert, and you can find me on social at jlangrand. Before we start, a few things. I'm not a climate scientist, so take everything I say with a grain of salt. And we can talk about disaster a lot, but I've really tried to make this talk something positive. So the point is not to point fingers, and we're going to try to look at the situation in a positive manner as much as we can. We're going to look at how to tackle the climate challenge with tech, but we're going to also look at how we can do that further as humans, and that's what maybe is more interesting even. So before we dive further, even though that's everybody should be aware of it, but few words of introduction. If you look at, I was born in 1987. About half of the total global emissions have been emitted since I was born, and we're talking about global warming, but keep in mind that's a very bad term. Like global warming sounds not so bad, but what's actually happening is it actually really disturbs what we call jet streams that are really good, like strong wind currents that are really good at containing seasons and containing the cold in the right places, containing the warm in the right places. That's what we call seasons, But as that weakens due to climate change, we see that cold areas become warmer sometimes, and the other way around, and that's how you end up with the vines, for example, in France, burgeoning in January, and then a wave of cold coming up that kills everything. So there is this tweet that really made me think hard, and I don't know what's the name of the user actually. I couldn't find it back, but he was saying climate change is basically watching disaster happen on other people's cameras until you're the one filming the disaster. And to me, that's really what it sounds like. Global warming is really, hitting at random places until you're the one in the middle of the problem. And we can see that Earth is really, really complex in ways we can't even imagine. So, for example, the global warming actually has effect on the GPS system. Earth is spinning faster, and that creates problems with the GPS. Like, I don't know if you were aware of that, but to me, that's mind-boggling. And it also has a latency. It's such a complex system that even if we were stopping all emissions today, the Earth would stop warming in about 10 years. So you really have to take that into account. So let's get to it. Let's look into the tech angle of things. I'm going to take a couple of examples. I don't have much time. Most of the things we hear about recycling, we hear about reusing. The very first word usually when we say is reduce. So the main point is, okay, how can you reduce what you're doing? Can you use less things? And the first example I take is, those 5 nines that we're all very fond of. It's really been a chase, to actually have as much availability as possible. Sometimes it's nice to stop and to wonder, okay, do I actually need those 5 nines? Like, am I that critical? Can I maybe go down on Saturday when everybody's off to bed? Because that will reduce the amount of systems I need, the amount of redundancy, and my footprint will be much lower. Another typical example that I really like to take is, do we need a web framework? Like, if you're Facebook, you probably need a web framework. You have hundreds of people, if not thousands, working on the same thing. If you're building a small website, then maybe lit HTML is enough. Maybe web components is enough. Maybe the platform is enough. And then all of a sudden, you're already making a big impact. Technology matters. I'm not going to spend much time on it, but depending on what you're doing, your impact really, really changes. And one other thing that I really like to do is, like, before even doing something, sometimes it's nice to stop and to wonder whether we should be doing it. So this is an example of Nike that has like smart shoes that lace themselves, and people weren't able to lace their shoes because there was a bug in the system. Like, sometimes it's nice to wonder, okay, do I actually need that thing? If we take a step back, if we look at the last 10 years, the average web page size has raised by 1,000%. That's typically what we call the Jevons paradox. Like, the more power we have in front of us, the more power we're going to use. And that's really, I think, a key point of reflection, because if we look at it, in the Netherlands, the average lifespan of a phone is 2.5 years. And some studies are even talking about 15 to 18 months. But when you buy a phone, you've already used 80% of its carbon footprint, because 80% of the carbon footprint of a phone is during production. At the moment you buy it, you've already expensed 80% of your footprint for that phone. So another way to say that is, when you buy a phone, you're going to use, at the moment you buy it, it's the same amount of energy that you just bought, that using it for an entire decade. And, website page directly has an impact on that, because the reason people change phone, number one, is apps being sluggish. So let's wait a second. I can't see you, it's online, but take a second and look around you and see how many of you have a phone that's like younger than 2.5 years, because we're talking about other people, we're talking about our users. It starts with us, right? If we're trying to teach someone a lesson, then it's better to practice what we're preaching. So, my phone is older than 2.5 years, but my laptop is pretty new. And that's where it starts, So that's what I've been doing for the couple of past years. I've been looking to my carbon footprint, and that was me in 2018. My carbon footprint was 17.5, about, it's always estimations, compared to an average of 10.8 for the typical Dutch person and 5.1 for the global. And as a word of reminder, the goal for 2030, which is like in 8 years now, it's 3 tons per year on a global scale. So that's kind of a huge leap we have to do. But if we look closer, we see that half of that for me is travel. And another third of that is, food and energy. So tech represents only a fifth of my emissions, whereas less than a ton for the stuff that I buy for my Apple, for my phone, for this kind of stuff. Over half of me is traveling. And if I go way back and go back to San Francisco, it's basically my yearly, allocation in 2030. So that's kind of we really have to take a step back and think about. So what I've done is basically looking at, okay, what's hardest for me to change? What's the easiest for me to change? And what's the impact that I can make? So I started looking at, okay, easy things I can change that have the most impact. 3 years forward, if we look at it, I'm at estimated again 6.2. You can see that the stuff I buy hasn't changed much, but I've really reduced my travel. COVID helping, of course, but we've decided to kind of stop using the air travel as much as we can. And we've also changed a few other things. Some things are not perfect. We get better every day, but I'm a very big techie fan, so I have a whole lot of tech stuff in my house. So it's not about being perfect, but it's about moving forward every day. One of the things we've entreprised this year is to actually grow our own food. So we have a garden, and I've brought my 2 daughters, and we've been growing our own food and stopped eating meat pretty much. And that really helped, going down further while keeping the stuff and keeping buying things. Another step is, you can't compress everything. You still will have a footprint. You kind of have to warm yourself up. So for things that we cannot compensate, we can't reuse, we can always compensate. There are multiple ways. I'm using ecology here, but there are other ways to compensate your footprint. Some additional thoughts. And that's always interesting to take a step back and think about it. Globally, the richest 10% are those with incomes above 35,000 euros a year. So at a global scale, if you're making over 35,000 bucks a year, you're part of the richest 10% of the world, right? And my question is, if we are not the ones that have to change first, we're 10 most wealthy percent, who is going to change if we don't do that, right? And conversely, I've always heard, especially in the Netherlands, we're a small country, quite wealthy small country, we're just 1%, and that's the same for Norway actually, we're just 1% of emissions, we don't really matter. Well, yes, except the richest 10% I've just talked about. It's not 1-to-1 relation, but the richest 10% of the global population is over half the global emissions. So we kind of are the problem. Things that I hear a lot, I do my bit, I'm helping, but huge corporations, they destroy everything. That is true. However, especially us, again, the wealthiest 10%, we buy that product, we work there, we vote, so we do have a power to change. We can stop buying things that we don't believe in. And even if we're working today in an environment where we don't feel, we can't get rid. I work at IDN, I work at a fintech. In fintech, there are things we can do to help companies adapt and change and reduce their footprint as well. And a lot of players in the field are doing great things. Some final things, really quickly. I do want you to always look at your facts. I don't know if you've seen this, that was in the Times and everything, Netflix watching an hour of Netflix is the same as eating McDonald's for a year and things like that. Always kind of check your facts. It's been fact checked and they were taking the whole chain into account, which, it's like if you count not only the burger, but also the machine that has been producing the burger and everything around it. Using Netflix is actually quite small if you think about it today. If you're interested in purely engineering topics, Asim Hussain is a sustainability developer at Microsoft. He has been doing principles.green, which is a website that has a lot of insights on how you can make your apps greener. So that's a good resource. But last but not least, coming back to prioritize, I would recommend just look at your current lifestyle and see, okay, what can you do easily to really reduce? Because you can have a huge amount of gains by doing actually very little today. Last but not least, no dooming. I know sometimes it feels like we're just screwed. I've read this morning that there is a huge heat wave in South America, and it's the best time to be alive. In most of the world, babies don't die anymore. Don't lose hope. We can change that, and we have the powers to change that together. So it's really not too late. We just need to act now. And coming back to the end, think about reducing. If you want the first and what's easy, reduce. Thank you very much.
Thank you very much for this really, really interesting and inspiring talk. I really hope that people will get some inspiration from that and try to do a tiny little kind of, even the smallest drop into the sea, kind of into the ocean. That probably will be still a contribution. So I think it's a very good idea. I was about to ask you, like, what would be the top 2-3 things to do for everyone, but you just answered it at the end. So it's
well, it's funny because we're developers. We want to fix things with tools, right? You want to make the biggest difference tomorrow. That's easy. Stop eating meat. Stop taking the plane. Don't go to a conference in San Francisco. Go to a conference in Berlin or in Sweden for you guys. That you're gonna make a huge impact from one day to the next, instead of trying to change other people's behavior.
That's true. I mean, it's like the change is better to start with yourself, right? So that's I think try to map the things that are the most having the biggest footprint, and then kind of try to do something about it.
Measuring is a very good point. Like if you start measuring, then you'll see it yourself. Yeah,
exactly. So let me do a quick check if there are any questions. I don't see any questions. There's a lot of hellos and waving and stuff, but there is no questions. So I think everything was crystal clear, and thank you very, very much for joining us. And it's been a great pleasure. And
thank you for receiving me.
See you again.
I'll stay around. I've seen some Kotlin and some WebAssembly showing up in the timeline.
There will be a lot of front-end stuff in the first half. So, yeah.
All right. Thanks a lot. See you next time.
Thank you. Bye-bye. Hello, Goethe. You are next in the lineup. It's great to have you with us, and it's really, really nice that you've joined us today and this year as well. You've been with us last year as well, if I remember that correctly.
Yeah, that's correct.
So that is great. I think I will leave the stage very, very soon to you to introduce both yourself and your topic. You'll be talking about JavaScript and ECMAScript. I see from the schedule, and I'm looking forward to hearing about that. And if anyone, it's going to be a lightning talk. So if you have any questions, please do write them in the chat on the YouTube stream. And I will be joining back in again when you're done, and then we can discuss those questions. All right, the stage is yours. Take it away.
Yeah, thank you. So I'm going to talk about what's new in JavaScript. And I was also here last year talking about new features in JavaScript. So this will kind of be a continuing of that, but now focusing on the features that was released in 2021. And my name is Goethe Olsen. I'm a full stack developer working here in Norway for Capra. You can find out more about me at my homepage or on Twitter. Before I jump into the features of this year, I would want to talk briefly about how JavaScript is edition to make some clarifications. It was created in 1995, and 2 years later, it was standardized by the ECMAScript organization. So when you talk about ECMAScript, it's standardization, while JavaScript is the implementation, but we're talking about the same programming language here. And they've come up with additions after the years, and because it could be hard to say ECMAScript edition 3, can be long, then we can shorten it to ES3. And then 4 was abandoned, and then ES6 was released in 2015, and then they changed from doing feature-driven releases once they have enough feature that was ready to be added to date-driven releases. So every June each year, a new edition will come, and the features that are ready will be added. And if a feature is not ready yet, it will have to wait until next year. And now you have come up with edition each year, and as you can see, it means hard to follow the numbers, edition numbers with ES 7, 8, 9, 10, 11, 12. So the official shorthand name is now ES and the year. So today I'm going to talk about ES 2021, which is actually the same as ES 12. So I hope that clarified something. And features that are still under work are being referred to as ES Next. So the first feature I'm going to talk about is numeric separators. And here I have a number, and it's kind of hard to see what number it actually is. Is it like a million or 10 millions or a billion? Not quite sure. But let's create a new variable here called easy to read, because now we can add underscores to the numbers, and which makes it a lot more readable. See that this was actually a billion. And if I console log this value, you could see that it's treated as it would have been without underscores. So the underscores are just for being easier for you to see in the editor. And if I compare those two variables here, you would see that they are actually the same, just how we write it a new way. And next is replace all. So here I have the use case where I have a string with apples, and I would like to change every apple into an orange. Previously, we have the replace method, but the problem with replace method, it only takes the first occurrence of the apple and changes it into an orange. But if we would like to take everyone, we could have previously used regex for it with a global flag, and that works. But if you would like to work with strings, we now have the replace all method. To run this, you would see that every apple has turned into an orange. So that works fine. Next feature is promise any when we're dealing with asynchronous code. And here I have some boilerplate code just to show that we have one promise that's resolved successfully after 2 seconds, one promise that resolves successfully after half a second, which return fast, then one promise that immediately is being rejected. And here I have an array with everyone. And the use case here is that we would like to get the first successfully promised as a result and continue the program. We could do this with race, but that only works for happy path scenarios. If the first promise actually fails, this would throw an error, as you see here. But if you use promise.any instead, it would take the first promise that is actually successful and return it. So if I run this code, after half a second, we should see fast here. So there it is. And this promise.any, it would only throw an error if every promise in the array has failed. Next feature is logical assignment. So we have the logical operator for and, or for nullish operator. But you can now use them in the assignment. So if I say x, I have the variable x, which equals to 0. And if I want to use a logical assignment, I use the and equals and say, for example, 100. And we would only do the assignment to the variable x if it's now truthy, which 0 is not. So it would remain 0, as you can see here. But if it would be a truthy value, for example, 1, it would result in being reassigned to 100. And it's the same for falsy values. We can say or equals 100. And falsy values are, for example, not only the Boolean value false, but also null, undefined, an empty string, the number 0, not a number. Some examples here. And 1 is not falsy, so it would remain 1. But if it would have been a falsy value, and we would do the logical assignment with OR, it would be reassigned to 100. And last year we got the knowledge operator. 2020 we got the knowledge operator, and we can also use that for logical assignments with question mark equals, say 100 here. And this knowledge is only for null or undefined. So if I run this, it would remain 0 because it's not knowledge. But if I change it to, for example, null, you'll see that you would reassign it to 100. And you could say that this is probably the same as doing x equals x question mark 100. And in most cases it is, but it will actually do an assignment in either case. And just to show an example of this, I have this object with a getter and setter, where the setter causes a side effect. And if we do it like this, the old way, we would cause the side effect to be triggered because we would do an assignment just with the same value. But with a new syntax, we can run this code and you will see that it will not trigger any side effects. So that's the logical assignment, which is new. Lastly, we have the weak ref functionality, which holds an object. And in JavaScript, every variable that you hold a reference to can't be garbage collected. But with weak ref, you're allowing the object to be garbage collected. And here we have some more code. And you can see that to get the object you hold in a weak ref, you would call dref. And if the garbage collector has taken your object away and deleted it, this cache would variable would be undefined, and it will console log this line. But if it has a value, you could get the count here, for example, which is in our object, and you could see that it prints 0. And if you would like to, you could attach a callback to your weakref object. And this callback will be triggered if the garbage collector has taken your object. And then you would be able to do some logic if you would like to. So the weakref functionality is kind of, you would only use it if you know what you're doing and you have special use case for it. Because otherwise it's not quite recommended because you're not in control over the code. You don't know when the browser is going to run the garbage collector, and it could be different from browser to browser. So that was every feature I would like to talk about, and which helps us write simpler and better code. I have this GitHub repository here, where you can see examples from every new feature since 2015, and you can find the interactive slides on this link. And that was it. Thank you all for listening.
Thank you very much. That was a very nice and short and very quick introduction. So
Yeah.
that was very nice. I really enjoyed it. Let's see if there are any questions. Oh yes, there is a question. Question from Øyvind. So very interesting talk. How do we see JavaScript developing in the future? Oh, so it's like any oversights for the future?
Yeah, I haven't looked into what because there are many features in the proposal stages being worked on. I've briefly looked at what's coming next year, this year, but I have not quite the full overview yet. So too early to say for me.
That's totally understandable. So that's that's fine. Actually, there is a question in the same direction here from Julian. What's the best place that you recommend to kind of to look for those news and to be aware of what's coming and when it's coming and this kind of things? Is there like a website or a blog or something like that?
Yeah, there is a good website I know about. I can post it in Twitter because I don't remember the link right now, but otherwise it would be to look for developer news. It would probably come up around the summer each year on those pages. Yeah.
Perfect. That's great. All right, then. I don't see any questions, so you still have a few seconds to finish typing your questions and press enter if you haven't done so yet. So, and in the meantime, I'll just give a few seconds because there is a tiny little delay between this live stream and YouTube stream. So I'll just kind of wait for a tiny little bit, and it seems like we're not getting any questions. So I think I will thank you for now and say thank you for joining us yet again for the second time, second year. And we really hope to see you again. And thanks for a great talk.
Cool. Yeah, thank you.
All right. Bye-bye.
Bye.
Hello. Hello.
Hi there. Hello. Hope you can hear me well.
Oh, yes, we can. Fantastic. Great to have you here. Thank you for joining us. That's really a really tight schedule that we have here. We're already down to lightning talks. Now you are the first, what should I say, regular length talk. So you'll do 20-25 minutes talk, and then we'll do the questions at the end. It's great to have you with us. And like with all the previous talks, I would like you to ask questions, be as active as you can, as you want. Type all of them in our YouTube stream, and I'll be bringing them up to the speaker at the end of the talk. So you'll be talking about progressive web apps, and I'm really excited to hear more about it. I'll leave the stage to you, and you can introduce both yourself and talk about the topic as well.
Thank you very much. Thanks for having me. Thank you for invitation here. And as introduced exactly, I will guide you through an adventure and tell you more about PWAs in the 2021, actually in 2022, as the year that we have currently right now on the calendars. But I guess not so much developments happened in 2022. So let's focus on 2021 and let's talk about those exciting challenges and developments that we had in the previous year, especially in the area such as specific and very near and tightly connected to the mobile devices, such as progressive web applications. So not to prolong anymore, let's start. Quick introduction, quick about me. I've started 7 years ago my career in cybersecurity, so I've did a lot of penetration testing and in general testing and the security of mobile applications. Such a phase, very specific area of expertise, but it was really nice to acquire also those skills. And later on, I've got through several startups, several ideas and businesses to run, to build from scratch, actually, mostly revolving around being a role of CTO or building a technology or the technology stack from the beginning. And finally, I've landed as in my current job in ePoint, where for over 5.5 years, I started as an e-commerce architect, developing some of the projects that we had on agenda back then, and moving swiftly to the research and development area. While when I started with the PWA, it was a trend back then, but I started to research it to get more info about it. And finally, to put it in a good use, that means to build some nice web applications and then progressive applications for our customers, because we are, as an ePoint, we are a software development agency. So we did many projects that are PWAs for our customers. Later on, Vantage into hybrid applications, so Flutter, React Native. We'll talk about it more later on. And most recently, my focus areas and my areas of expertise and also constant development are the mobile web and mobile applications, where mobile web for over 2 years, I'm working with the local chapter in Poland of Google, while we do such an initiative such as Hackathon, PWA Hackathon 2 years ago, or projects regarding the e-commerce area, audits of the UX and mobile performance for the e-commerce businesses in Poland. So currently, mostly I'm connected to the new technologies that web has for the mobile and mobile web performance. Also, I'm a Google developer expert, so a GDE since September 2021, so a fresh one, but started actually doing those tasks as a GDE many years before. So a quick quick introduction about me. I know we are on tight schedule, so I will move further on. If someone would want to have my contact data or some social accounts here on the left side, you can have it. But let's move it to the next phase of my presentation, of my slides. As a company, I've spoke about it briefly. ePoint, my company, we are on the official Google list as the first CE company that specializes in the PWA's development. We did it 2 years ago. Still, though, up to date, right now we do have on a global scale only 48 companies that are specifically doing the PWAs. We are one amongst them. So those cooperations started about 2.5 years ago, and it continues as for now. But enough talking about the company, enough talking about me. Let's talk about the topics of the PWAs. Let me start from a brief but important question. What is your perspective as a developer, as a manager of the developers, or as a person who takes care of an either mobile or either web development in the company? So it can be one of those three. I've heard of the PWAs, possibly. I've seen other applications. I've seen the real use cases. I've seen that someone used it, or on my mobile phone it popped up, install or add it to the home screen. So that might be of, let's say, one specific state that we could have. But let's move to the another one. Either I am implementing or upgrading the site to the PWA standard. It's also possible. So I'm in the middle of the project. I'm doing something exciting. I'm developing or actually upgrading my site to a PWA standard. There is also a possibility of that. Or I already have a PWA, so I've built something. It's right now working for the real user customers or users, and it's something that it's live. So it can be one of those three stages. The others are possibly not even possible, but we've got the state as for now. So possibly you're in one of those three. Let's talk about a different topic. Let's talk about the use of devices during a pandemic, and let's see where the mobile currently is at. Red line here on that chart, we do have a mobile devices, yellow line desktops, a green tablet, so like a skippable group of devices. But in the year 2018, something happened, and that something was that the trend, the line of the usage of the mobile devices exceeded the desktop devices. As an example, here is just, as you might notice, it's a Polish Google search queries from 2017 to 2021. It's a data from Google, and it talks about the usage or more rather source or devices that are using the Google search as a website. So as you may see, most of them up to date are mobile devices, while the desktops, the PCs, are rather in a declining trend here, as we can see, and I guess as we can notice right here. So since 2018, you can visualize it as we will, let's say, this is a Google Analytics on Google website. So possibly you can see devices, groups, and trends right here. So either such events or things as a pandemic, waves of the pandemic, first wave, second wave, third wave, the fourth wave, didn't change that trend. Still, mobile devices were on top. Still, it's like the most popular group of the devices that we are using up to date. So it is something that is worth mentioning at the beginning. While on the other side, let's say on the native applications and the native approach to mobile devices, we do have something like that. We do have mobile apps overflow as for now. So On the Android side, as of 2021, the quarter one, it changed a little bit for the next quarters of the year. We did have about 3.5 millions of mobile applications for the Android as a platform. Those data are worldwide here. While for the iOS, for the Apple devices, we did have in the end of the 2021 are over 4 million of applications. Most of them are totally something that can be replaced with a PWA or a well constructed and designed website. So there's even a Twitter fan page regarding that. It's called "This Could Be a PWA," something like that. Check it on Twitter. It's for sure. It's here. It's a very interesting fan page that tells you about those applications that easily could have been a mobile app. An PWA app, so a website that is working on a mobile devices flawlessly. But here we do have also a huge amount and immense amount of applications on iOS platform, so on Apple platform, that counts also inside it the applications such as yellow torchlight, green torchlight, white torchlight, and etc. Duplicates, and as much as useless and obsolete applications as you may imagine also as well. But the previous way of develop applications was like that. From the idea development process, it was like developing the another different project with another set of technologies, another developers, and also other tools for the iOS. For the Android, different set of tools, different team, different project. For Windows or for the desktop development or for the web development, yet another set of tools, set of people, set of best practices, etc. So at the end, we did duplicating those code bases, duplicating our time, multiplying the costs and time for various devices and various platforms that users are using, like let's say Android phones or Apple phones. And that changed a little bit, and it's still changing because we had those two areas, those two fronts in a coming storm. Actually, that storm has broke out like 2 or 3 years ago, but still it's something that can be visible right now. We do have mobile web pages, responsive web design, PWAs right now. So the web pages that are trying to get into the place that native apps was before, and they are succeeding in that, I must say, pretty much due to the development of the current and new mobile browsers, the browsers engines also as well, and the other technologies such as access to the devices APIs. We'll cover it later on. While the other side of this discussion is native mobile applications that from the beginning, from the scratch, they were able, developers developing native mobile apps were able to achieve any level of hardware APIs, achieve any thing that they wanted to do with the mobile phone because it's a native code and everything is possible here. While on the mobile web pages, many things, including push notifications, including working offline, were not possible a few years ago. But right now, that successfully changed. We do right now have something compared to that, to the old process, to the old way of developing apps. We do have something like that. So the web browser is the main channel through it we are viewing the size, the applications, the mobile web applications, the PWAs, and it's doable on desktop, on a smartphone, either iOS or either Android. It's no matter to that. The web browser, any modern web browser, is a channel of development, channel for our users, customers to get into our ecosystem, get into our application and use our content or use our functionalities, as well as native applications did this before. But where is it? Where in that is PWA actually? You can treat it as a trend, you can treat it as a technology, you can treat it as a standard. The latest one is possibly the most correct one. It's a standard, and it was invented by people from Google a few good years ago. The main thing that PWAs are trying to achieve and trying to answer is the balance between the engagement of the users and discoverability. So SEO techniques and also being able to be discovered by Google, Bing, or other search engines. While we know pretty much that mobile native application does not have any level of discoverability apart from the Apple App Store or Google Play Store, because the content inside is confined inside those applications pretty much. PWA, so on websites, pretty much that inherits everything from the way of developing the website, does not have those problems. So we couldn't leverage the things that we have here, such as SEO techniques, such as optimization for the ranking, for the search engines, etc. So this is here. While on the side of engagement, applications has always the, let's say, the top level of engagement, because we are installing them, we are using them, we are getting used to, they are on our home screen. So the only lacking thing, the only gap that was to fill here was to provide websites a turbocharger that allows them to be functioning and engaging people in the same way as native applications were doing that before. So a way to add or install such kind of a web mobile app into my home screen, to my app gallery, a way to have advanced features such as, let's say, geolocation, access to a camera, etc., etc. So this is something that actually happened, and we've seen a lot of PWAs that are using fully it. But that world is changing very frequently, and as for now, we know that PWAs are websites that works as an application, and practically that's the definition. PWA is a website that uses the latest front-end technologies as well, to make it look and behave as much like a regular mobile or desktop application works usually. So the level of immersion should be extensive here, as much as possible, you can say. In one word, if I would be required to put something for the progressive application, it's website app, practically, because it's a website, it's an application, it's something in between, it's website app. As I told you before, so that means that it's not kind of a trend, it's not a kind of a technology, only one focused on doing and solving one thing. It's a standard, a set of rules that after fulfilling all of them, we can name our site a progressive web application. Those rules are defined by Google and change also frequently. Until 2021, we do have three categories that we could be able to benchmark PWAs: stable and working in offline, installable on mobile devices or wherever, optimized for mobile devices, so responsive web design, certificates, HTTPS, also as well, and many others. While starting for the 2021, there are only two categories for the PWAs, for sites to be a PWA. Google also make it simpler. It's installable and it's optimized for PWA. That's kind of a word that possibly tells you nothing, but it means that it's some analogy to the optimized for mobile devices, but it's called right now in Lighthouse in the benchmark that tells you that in the easiest possible way tells you that this site's a PWA or not. It's called optimized for PWA, so that means that the site is working really well on mobile devices and has the other requirements to be a PWA that I cover in a moment. So until 2021, those checklists and that specific one checklist that is enforced by Lighthouse, so a Google benchmark of everything practically, I'm personally using it for the performance testing, for PWA testing as well, for accessibility testing, and for many, many other things it can be used. Here, as an example, PWA benchmark. So we have a category fast and reliable. It was testing while the site loads really fast to be responsive on mobile device, and if it answers code 200 of HTTP when the device is offline. So check for offline mode practically. Installable, apart from using HTTPS, registering a service worker that will be covered later on, and giving user an option to add that application to appear on their mobile phone screens in a home screen or either on other menus. And PWA optimized, that it does not really redirect HTTP traffic to HTTPS, and that check was also here. So security, custom splash screen, manifest JSON case, that also will be covered later. It was checked here. It was renamed to PWA optimized. Earlier on it was called mobile optimized. So that was until 2021 with small modifications. Right now we do have that stage and that benchmark. The categories are really simplified. Here we do have installable category that only checks if either a web app manifest, the manifest JSON, and service worker meet the installability requirements, so they are present, they are working well with the browsers, with the Lighthouse benchmark as mentioned here. And the PWA optimized, it checks practically if the service worker is working correctly, if it controls page and start URL, and later on the security, splash screen, customizations on manifest, and also icons. Maskable icon and Apple Touch icon, if it's provided, it was modified also recently, but those points are being checked here, and if we are fulfilling all of those, we could name our application a proper PWA right now. The 3 additional positions on the bottom of the screen, cross-browser work, each page has an URL, so also an ranking factor. It's something that it can be checked, but manually the Lighthouse benchmark does not cover it. Also, the second thing that defines a good PWA, it's an usage of mobile phone APIs, access to the hardware. You can check it, you can browse the site, whatwebcando.today, created by my friend from Poland. That website is providing you an exact information on each device that you will run it, whether through that specific browser you are able to achieve access to specific APIs. And you might see on a generic Android device with Android 10 or 11, you are able to access such an API such as offline mode right now, interrupt sharing, payments, credentials, push messages, push notifications, permissions, task scheduling, or on the right side, home screen installation, that the key thing for the PWAs, Bluetooth, NFC, USB even. So even an advanced communication features can be right now done through the web app channel. So I guess this is important, and this is something that a good PWA, such an application that is a web application but tends to replace a native mobile app, will need to have, because native apps are using it from the beginning and are still on that matter. In order to track all of those changes, in order to get to know precisely which API will be introduced in each version of the most popular browser, that is a Chrome, and the Chromium engine that it's underlying a good foundation for that browser, and also many other browsers, you can check a figutracker.web.app. Here the URL is provided on the top of the screen, while from the team that is developing and extending the Chromium engine, they are providing information about the Fugus API, so the APIs that are extending and providing the developers way to access the hardware of the mobile or desktop devices. Here, just an example from some time ago, you are able to check a web USB API, on which platforms it's achievable, and the level of the browser starting from it's enabled to be used publicly. If you do want to check the cutting edge features that are in origin trials, so before the public releases or a developer trial more earlier, you are able to do it scrolling lower and checking whether those features are bound to be distributed and put into the releases, and also on which platforms they are working. Here, as an example, we do have a mark of the PWA and the exclamation that it's a file handling API, or URL protocol handler registration for PWAs, which will be, and as for now currently are, a key factors to achieve better level of integration with mobile devices. So those are the things that are bound, or as for now, those might be even introduced. So to be up to date, I suggest to enter the figutracker.web.app and check whether the API are we trying to use, or are we considering whether do a native application or mobile application. Let's check at the beginning. At first, let's check those APIs, because as it seems, if it will be able, or we are able to achieve the access to that via web app, it might appear that creating a native application is no longer the case, or the most proper case for us. But the mobile web PWAs and responsive websites, or the websites in general, does based on 2 pillars. We do have such pillars as performance. Earlier on, it was checked as a part of the PWA benchmark. Right now, it's not checked, because we do have other benchmark. We do have a web performance optimization, WPO culture, WPO also area of expertise that can be used. So it is something that that is a different area, but it's worth to mention it here. And engagement, so the PWAs, the ways to be able to install those applications, those sites on your mobile device, or any other device practically. So those two things are key areas when we are developing a site that is bound to be working very well on mobile devices and also on desktop devices. We need to consider them. For the performance, just a quick overview of that. I'm recommending to use, because that's also my daily area of expertise, to audit the sites of the area of web performance. So I'm recommending to use, if you are able to, and if you want to approach it professionally, to use the two sets of metric on the left side, Chrome User Experience Report, CRUX. Those are the real user metrics coming from real devices. You can use it, browse it through tools like Treo.sh or Google Data Studio. You can access that. Those data are showing you how real users are, how for them the site is loading in, let's say, in 5 or in 10 seconds, so how much this time is consisting for them. So we're able to check the specific page load times for your end customers here. While on the right side, Lighthouse, PageSpeed Insight, laboratory toolkits, they're enabling you to find weak spots and to identify them and to work on them, because they are testing at the current moment on the current developer's workstation perspective your site. So good thing to remember, I guess, good thing to work on. Let's talk right now about how to approach PWAs, the last part of my presentation, and actually what's behind the speed, the look, and fit for mobile devices. 3 crucial things: service worker, PWA manifest file, and hardware features. That doesn't change from the time being and from the beginning of the PWAs. Service worker and JavaScript file, actually, or a set of files that works between the application and the browser. It collects the customer information or sends push notification to them. It's kind of a middle man between the backend of your web app and the mobile or desktop devices of the customers, of the users. So it really works as a middleman. It transfers the data and also responsible. It's also responsible for caching, so for saving reusable data for later visits of the user. Files, content, everything. Through Service Worker, we can build a really great caching strategies and build a really great offline mode for our mobile web applications. So it's important, and it's also an underlying factor for the sites to be a PWA. It can be used in many scenarios as a push notification sender only, as a service that is collecting some data and putting them to a good use later on, or as an offline or caching strategy mastermind. But PWA manifest file is just a single file, but it's a powerful file embedded in a main directory of our website. It provides unique functionality such as assigning an icon to an application, splash screen, hiding the address bar, so the view mode of our application, and many other things. So a file defining how that application will look like as in a native, not exactly native, but as in a mobile app view. So when we are opening it from the home screen or from our menu. And access to hardware features, I've told you about it a little bit. Camera, camcorder, push notifications, either near field communication. Those things are able to be accessed and to create great functionalities based on them. In terms of the browser's popularity and work of those specific functions between many browsers, as you may here see on that screen, add to home screen functionality has a rather good coverage. Obviously, there are some minor things that need to be covered later on or wouldn't be covered at all, like Internet Explorer, but who cares about Internet Explorer anymore right now. But the Edge, the Chrome browser, the Android browser, all of the mobile browsers are actually respecting and working with it. So it's an important factor. On the service worker side, it's even better. Like 94% of globally used web browsers are supporting this standard. So we can work very well on those techniques. So it's something that is worth to be mentioned here also. While the cutting edge technologies and APIs such as file system APIs, they are still need to be seriously worked on because the support is in original developer trials of the Chrome, of the Edge, or on the Opera. and the other browsers are not covering it right now, but I guess it will change in the near future, while we have a great API for manipulating files on the device's local system. So this is something that it can be leveraged later on. Some key and fun statistics also as well for the PWAs. Service worker and performance area. As you might know, service worker works for caching calls, so it can handle various caching strategies. It can manage your offline mode, and it can also accelerate the page load times of the subsequent next visits. So right now, on the left side of the screen, we can see the first paint, so the time that some first element will be painted on the screen on a mobile or on a desktop device. It's a desktop here specifically. It's without service worker, so those times are mostly revolving around 1 second, 80 milliseconds, 800 milliseconds, etc., etc. While with the service workers, those times are bound to be near zero. So as we can see here, it's a great acceleration, a great technique for also building a site that loads in a blinking of an eye. So might want to also to have an interest in that. What else? Offline usage, we can tell by numbers that most of our users of, let's say, standard exemplary application that is a PWA are online users. Some of them will work on offline with obviously limited range of functionalities and limited pages that they can be accessed, but it's still something that needs to be designed and worked with. While the app install banner, most of the people are still right now tend to ignore it, tend to use it right now as a website through browser. Only like around 12% of people, 11.5% here, are accepting the banner. 26% of people are dismissing it. So those stats are giving us the hindsight of the overall things revolving about the techniques and the things that are connected to the mobile devices. What's next for the PWA developments? Very quickly, because we are at the end of the time. TWA, Trusted Web Activities, so a technology made by Google and developed by Google that is bound, and its sole aim is to provide you a way to pack a PWA to be as lightweight container as it is possible, and to put it in a Google Play Store. Adaptation aside, a PWA to TWA takes about 2 weeks. It's about 10 times shorter than developing a native mobile application for two platforms. And it's a huge game changer in the way that we can build up a really well working website, upgrade it to a PWA, and then put it in Google Play Store as a TWA app that will work as that original website with the no remarks of the browser around it. So we'll have like that. So it's a technology that comes at our hand very quickly. We did our first project in that 2 years ago. It was Morella.net mobile application, mobile web application, pretty much actually. It started from us for developing a PWA on the main site, so the Morella.net. Then later on, via Trusted Web Activities, putting it in a Google Play Store, Apache Cordova Apple App Store, and Huawei Quick App on Apple and on Huawei App Gallery. So 3 major mobile platforms covered by one code base, one development stream, and one technology revolving around PWAs. So a nice thing to do on mobile right now in 2021, in 2022. One more thing that I need to say, the case of an Apple devices, because as you are developing the sites or doing something around them, the case is important here because Apple devices does not have as much level or the access to APIs as Android devices. It's not the same level as Android, we must say. Support of PWAs on iOS, it's since iOS 11.3, so it's a pretty long time as for now. It supports service worker, it supports manifest files, it works pretty well. Apart from that, you will not get any banners encouraging you to install that. You will get only add to home screen while you click share menu and scroll up to that. Performance on mobile Safari is connected to a mobile Safari performance in general, but you get the pros and cons revolving around that also. There are still some shortcomings, pushes from www channels, so the web pushes are not accessible right now. It's not working. They are working though on WebKit, so on the Safari engine of implementation of that, so it might change a little bit in the nearest future. Camera, it does not work really well, and there is a 50 megabytes service worker cache limit, but you can omit that with IndexedDB, so it's a thing that can be omitted. The, I guess, most troubling thing is that Apple specifically tries not to work on it, as it's the WebKit, the case that it was really loud in developer environments and DevRel environments regarding the development on WebKit and the other browser engines. We know how it's looking like, but maybe in the future something will change in it. But as for now, due to that, we do have no support for such technologies, very advanced and very nice in usage, such as Touch ID or Face ID. So we won't get it on Apple devices. Some of them, like pushes from web channel or camera, can be omitted or can be done via Apache Cordova or other containerization methods such as Flutter or React Native, but it's a way around, not direct way, as Google did with TWA for Androids. Many people that use PWAs, either a global pure player services such as Uber, Tinder, or Apple, even in some of their sites, Google Cloud, AliExpress, Forbes, ING. So those are the, among many other names, the sites that upgraded themselves to the PWA and are working on a mobile experience that comes from a web experience. And the last part of my presentation, because the next slide would be the end slide, the gradation of the mobile and web technologies. After doing some projects in the mobile and the mobile web area, I've come to a conclusion that for each business case, for each project, there's also a place on that scale that you can see right now on my screen. Either it's a mobile web, responsive web design website, a simple blog, a WordPress site, etc. So it's best as it is a mobile website, it's still a website, and it's best as it will remain here. Why we need something more advanced from the phone, from the phone's hardware, let's say, we can do a PWA, great for e-commerce, let's say, as an example. Why we need some more advanced security features and performance, we can delve into React Native Ionic, more advanced performance and closer to the native and the hardware, Flutter, and then fully native approach, Kotlin, Java, Objective-C or Swift for the Apple, for the Android and the Apple devices. Right now, native is rather recommended to build upon it the games, mobile games, and the heavily calculating applications, so those that are heavily using the hardware of our mobile or desktop devices. So yeah, we have something like that right now. Some few useful links. If the presentation will be shared later on, those are the ones that I mentioned earlier on through various of my slides, but also a few neat sites about PWAs and development of the web technologies as well here to be used later on. And on my side, that's all. Thank you very much for having me on this slot on this event. And if there are any questions, we'll be happy to answer them. You can find my contact data here.
Thank you very much. Thank you for a really interesting talk. And there were a few questions in the chat, but actually you managed to answer them just a few minutes afterwards. So there was a question about push notifications on Apple devices and things like that, and then you just answered it just a few minutes later. So thank you very much for doing it, and thank you for joining us today. And it's been really great pleasure. So we're looking forward to seeing you again at some point at our GDG events, at next Devfest. We have a Devfest. It's called the Devfest 2021. It's not a typo. It's actually the feature, because we it's a part of 2021 edition. But there will be another Devfest in 2022, which is this year, but that will be happening after summer at some point. So just that is cleared as well. Thank you very much for joining us again.
Thank you very much. Take care. Bye-bye.
Bye-bye. So, Håkan, great
Hello.
to see you again.
Yeah, great to see you.
Welcome back.
Thank you so much.
Good to see you again, and we are very happy to have you again. I think if I remember that correctly, that's your second year at Devfest. So it's fun to have you as always. It's I will let you do the presentation of both yourself and the topic. And I will just say, like I said previously, please write your questions in the chat and we'll try to answer them. And I will bring the questions to the speaker at the end of the presentation. So you have 20-25 minutes to do your talk and a few minutes for questions as well. Take it away. The stage is yours.
Thank you so much. So hello, good afternoon, or good morning, or good evening, wherever you are, and welcome to my talk on why you should consider WebAssembly in your next front-end project. But before we start here, I just want to go through the agenda here. So we're going to talk first about what is WebAssembly, and then we're going to write a Hello WASP application, a Hello WebAssembly application, and then I'm going to give you an introduction to Rust. And then I will explain how can you use Rust, which is a more high-level language, and compile it down to WebAssembly, and then package your WebAssembly in an NPM package, and then upload it to NPM, and then use it in a standard web application. So we're going to go through all of that. And then we will have a look at game of life, and we'll talk a little bit more about performance when using WebAssembly, and we're going to have a quick look at some real-world applications. We're also going to talk about the future plans for WebAssembly and mention some other frameworks that are also using WebAssembly. And then we have come to maybe a more cryptic headline called New Old. We will see what that contains. And then we have some conclusions and then finally some references. But before we start, I just want to say a couple of words about me. You can see my background here. I work as a manager for AI and big data at Miles. And I'm also quite involved here in the local user community in Oslo. So I'm part of the Norwegian.net user group. I'm also part of Azure user group Sweden. I'm part of Oslo AI and also run my own AI school here together with eParty and Gosia Borseka called AI42. I'm also Microsoft MVP in AI and the Microsoft Certified Trainer. And if you want to get hold of me, you can find my social media handles here on this slide. Now back here to the agenda here. So the background of WebAssembly is that there was a group formed in 2015 by all the major web browsers. And by 2017, they had WebAssembly released. And right now, WebAssembly is W3C standard. So it's on the same sort of range as HTML and CSS and JavaScript, and then sort of the fourth standard is WebAssembly. So WebAssembly is supported on all major browsers, both on the desktop versions, but also in the mobile versions, which can be a good thing to remember. So if we try to contrast JavaScript with the WebAssembly, we can say that JavaScript is a much more high-level language. It's very flexible and expressive, and you don't need to compile it. And as we all know, it has a huge ecosystem. But WebAssembly is a much more low-level assembly-like language. And as we'll see, it also has a compact binary format. And what WebAssembly promises us is a near-native performance. And the way that you use WebAssembly is to use a more high-level language like C or C++ or Rust or Go, and then you can compile these high-level languages, you can compile these down to WebAssembly, because you don't really want to work with WebAssembly sort of from the start. So we will have a look at that too also in a short while. So this image is trying to demonstrate here what I was just talking about, that you have a high-level language that you can translate to sort of an intermediate representation. And then the compiler will compile this down to target architecture, either x86 or, for example, an ARM architecture. So this is what usually happens. But now with WebAssembly, what happens is that we will have code that will be executed over the web. So then we don't really know which kind of target architecture will this run on. So we can say that WebAssembly is sort of a machine language for a conceptual machine. And we can say that WebAssembly instructions are virtual instruction. So the browser will download the WebAssembly, and then the browser can compile it down to the target architecture. And this slide here is from a blog post by Lynn Clark that I also recommend if you want to know more about it. So as we said, WebAssembly or WASP, it's a new browser standard, and it's based on a previous project called ASM.js. And if you're interested, you should have a look at that if you want to know more about the history behind WebAssembly. And it's an intermediate language in the same way as Java compiles down to bytecode and C# compiles to MSIL code. And it's also strongly typed. So we have 4 different types in WebAssembly. We have 32-bit integers and 64-bit integers, and then 32-bit floats and 64-bit floats. So now we will actually build our first Hello Wasp program. But the thing is, as you saw on my previous slide here, that we don't really have any string or any chars or something like that. We only have the float and the integer. So when we want to build our Hello Wasp program, that is usually that takes the form of a mathematical expression. So in this case, we will just make an add program. So here is our hello world in Wasm, which is add. So we can, WAT is the WebAssembly text format. So we can express this in text here. So we can compose a module which have a function that is called add2 that takes 2 input parameters. Both are 32-bit integers. And then we have a result, which is a 32-bit integer. And then WebAssembly is a stack-based language. So you can push and pop on stack. And then there are some 60 different types of operations, like mathematical operations, that you can perform on the things that you have on the stack. So in this case, we want to perform an add. So then we need to have a i32 and integer 32 add operation. And then we also need to clarify what is the name of this function for the calling application. So then we define it by using the export keyword, and then we give it a name like add2, and then which function does this actually reference. So this add2 will reference this internal function add2. We can also have a look at how the actual code looks like. So we can switch here from the textual format and the binary format, and we can also write out this binary format to a textual representation. So that is what we have done here. So we can see that WebAssembly is much like an assembly-like language. So if we want to use our WebAssembly, what we can do is we can just do a fetch on our WebAssembly on an HTML page, and then we can read it into an array buffer, and then we instantiate WebAssembly. So as you can see here, we just need to call WebAssembly.instantiate because WebAssembly is part of the W3C standard. And then we can take an instance, we take results.instance and then export, and then the name of this function, which we called add2. And then we can perform our operation. So in this case, we do add2 on 2 and 2. So if we run this in the browser, we will have an output of 4 here. So that's sort of our Hello World example. So one tool that could be useful to know is the Wasp Code Explorer. So what you can do with the Wasp Code Explorer is you can load in a binary WebAssembly, and then you can get the textual representation back. So that's what we've done here. We took this Wasm file, the binary file that we developed in our previous example, and then we loaded it into the Wasp Code Explorer. And then, as you can see here, we got the right textual representation back here for our add function. But if we want to make some more sophisticated programs, we don't really want to work with WebAssembly from scratch. So what we much rather would like to do is we would like to use a more high-level language and then compile the high-level language down to WebAssembly. And one of these languages that we can use is Rust. So Rust comes from Mozilla. It's a system programming language, which has a syntax similar to C and C++, strongly typed, and it also compiles down to native code. And one of the design criteria when they made Rust was that it should be memory safe, so you shouldn't have any dangling memory pointers or anything like that. And when we talk about Rust, we need to say a couple of words about the Rust toolchain. So with Rust, we have something called RustApp, which is an installer for Rust. And then we also have Cargo, which is similar to NPM. So it's the Rust package manager. And you can store your, so it's called a crate. So you can store your crates on a site called crates.io, which is the package registry for Rust. And here is an example of a Hello World program. So we just print out Hello World on the command line in our program, and then we use the Rust compiler, rust-c, on a Rust file, and then on a Windows machine, it will generate an exe file, and it will execute the exe file and print out Hello World on the command line. We can also use cargo. So in this example, we used cargo new Hello World. So what it does is create a package structure for us with a main.rust file and the cargo file. So in the main.rust file, we can define that it should be print out Hello World, and then the TOML file is like a package definition where we define the name of the package, the version, and the authors, and any type of dependencies. So if we run the cargo run, it will compile this Hello World application, and then it will run the exe file that it will generate here. So these are the different types that we have in Rust. We have some primitive types like integer and float, and also some primitive constructs like function pointers, and arrays. So now when we know a little bit more about Rust, then what we can do now is we can write a Rust program, and then we compile it down to WASP, and then we can upload it. We can create an npm package and upload it to npm, and then we can use it in our own website. So that is what we will go through here now. So first thing that we need to do is we need to install this Rust toolchain, the Rust app, the cargo, and the Rust compiler. And then we need to install something called the WASM pack. And the WASM pack will also install something called the WASM bindgen. So the WASM bindgen is sort of a glue file between WebAssembly and the calling application. So if we have a look at the files that are generated here, we have a TOML file, which is this package definition. And then it says that we have a dependency on the WASM bindgen. And then we have our main Rust file. So here what we do here is that we define that we're using an external crate, the WASM bindgen. And then we also define that we want to use an external function. So we want to use the standard alert function in JavaScript. And then we can also define our function, the function that we're going to be using here, which we call greet, which take a string as an input, and then we use the JavaScript function, the JavaScript alert, in order to alert it out on the console. So then we're using wasm pack build and target web. So if we use that command, it will compile our Rust code to WebAssembly, and it will also generate through this wasm bindgen. It will generate a JavaScript that will be like a glue file between the WebAssembly and the calling application here. So it creates a package directory, and then what we can do here is we can publish the package up to npm. So we publish this package up to npm and call it Hello Wasp Silver, and then we can have a look here at what does it contain, this package. So first, it's a TypeScript file which defines what are the functions that are available for an external application to call. So right now it's only the greet function, and then this Hello Wasp Silver is this glue file that I was talking about. So what it does, it tries to pass our arguments or pass our information or data down to WebAssembly. So you can see here, for example, for the greet function, it tries to pass a string to WebAssembly, and then it tries to call this WebAssembly.greet function here. And then we also have a package file. And then if we want to use this package, we define just the webpack config, where we have a start index file. And we also have a package JSON, where we define that we want to use this Hello Wasp Silver package. And then in our index file, we refer to the index.js file. And in the index.js, we are calling our Hello Wasp Silver asynchronously. And then we can call JS greet with our input. And then we get that output here on the console. But then if we want to have a little bit more functionality here, so this is also an example here that is taken from the Rust WASM IO book, so an introduction to Rust. So it's the game of life. So some rules here for the game of life, that if you have a cell that has fewer than 2 live neighbors, it will die because of underpopulation. And if you have a live cell with 2 or 3 live neighbors, it will live on to the next generation in the simulation. And any live cell with more than 3 live neighbors will die because of overpopulation. And if you have any dead cell with exactly 3 live neighbors, it will become a live cell because of reproduction. So then we can run this to see. So we can see here, this is the simulation and this is the simulation board. And then we have a pause button that we can pause, and then we can manually go in and edit some cells. So now we stop the simulation, and then now we add some more cells in the simulation, and then we continue the simulation. So let's have a look at how that was done. So again, this is the cargo file, which is very similar to the previous file. And this is our main Rust file where we define sort of the simulation board or the universe. And then we also define some getters and some setters for getting the width and the height of our simulation board. And then we also define the toggle cell function so that we can actually go in manually and toggle the cell. And this is the TypeScript file with all the different functions that are available for an external function. So you can see, for example, width and height and toggle cell are available for us to call. And then this is this glue file that I was talking about. So it's like a binding, or it's like a binding here between the calling application and our WebAssembly. And this is the way that you could use it, very similar to our previous examples. You define a bootstrap file and you load it asynchronously. And then here you have the game of life, the setup of that. And then you see in the red, we define this universe.toggle cell for a specific row and a column. But now over to performance. So I said that one of the main goals here with WebAssembly is that we should have near native performance. So here we have some experiments where we've used the same algorithm both in JavaScript and also in WebAssembly. So one of the things that we can see right off the bat is that WebAssembly is much more performant than JavaScript. But the other thing, which is maybe even more interesting here, is that you can see that with JavaScript you have a much wider distribution of these different time points. So whereas with WebAssembly, that distribution is much smaller. So that means that with WebAssembly, you can be sure of your performance. So it will not vary, it will not have as much variance as you have with JavaScript. And also another thing that could also be interesting to know here is that JavaScript has been around for a much longer time than WebAssembly. So we can expect that with time, the web browsers and the compilers will be able to optimize for WebAssembly, so that we can expect this difference in time to be even larger than what it is today. So I also have some examples here from the real world. So here is one example here. So one practical example here of how you should use WebAssembly is either if you already have like a desktop application that you want to be able to export out on the web, then what you can do is you can compile it down to WebAssembly, and then you can just use it in your web application. Or another interesting use case is if you have something that needs to be very performant, like for example, it could be a game engine or a render engine, or could just be some mathematical calculations that you need to perform very fast. That's another good example here. But the first example here is some people that has digital signal processing library written in C and C++, and they wanted to expose it on the web. So what they did then is they used the WebAssembly, and then you can have a look at what it looks like. So then this is what you can do in real time. You can do on a video, you can create different types of filters, and all of this is in real time in the browser through WebAssembly. Then we have another example is with AutoCAD. So with AutoCAD, what they have is they have a large number of drawings, and then they want to be able to expose that on the web. And they have used WebAssembly for that. So what they have done is this is sort of an overall sketch here of the architecture, so they can use the same type of AutoCAD core C++ code, and then they have a wrapper. They have a wrapper layer here with WebAssembly, and then they can use any type of modern front-end technologies like React or Vue or anything that they would like to use. So this is also an example of like the single responsibility principle, so that you can actually focus on your core competence. So the people that were working with the core C++ code, they can still work with that and maintain that, whereas the people that are front-end expert can work more on the front end. And this is made available then through WebAssembly. And then some future plans here for WebAssembly. So as you've seen, we've always had this glue file, which is a JavaScript file so that you can call between the calling applications and the WebAssembly. But what they want to be able to do is they want to be able to directly call down to either web APIs or call directly to DOM elements. They would also like to be able to directly import WebAssembly in JavaScript. So right now you needed to do this this asynchronous call in order to use WebAssembly in your JavaScript application. And then I can mention serverless WebAssembly, because WebAssembly is not only for the browser. So we have different providers like Cloudflare and Fastly that support WebAssembly as a serverless option. And what it brings us both faster launch times, and you don't need to rewrite your JavaScript, and much more lightweight applications. So this is a schematic overview here of, in the first case, we have all the logic done on the back end, and then you have like a simple front end. Or you can also have the calculations done in JavaScript and do it all client side. Or in our third example, we compile our logic down to WebAssembly, and then we use it all on client side. Or we can use it as a serverless WebAssembly option, which is our fourth example. And then we have some different providers here. So for example, we have Fastly. They have something called the Fastly Terrarium, where they have a engine called Lucet. So with this, you will have an initialization time of your WebAssembly runtime with 35 microseconds. And then you have also Cloudflare, which is using the V8 engine, and it will have just an initialization time of 5 milliseconds. Or you can use it on Node, and then you have an initialization time of 200 milliseconds. So this could be good for you to know and try out and adapt to your use case. So we have some different types of frameworks that are now using WebAssembly. So we have Pyodide, which is an experimental Python runtime, so you can run NumPy and Pandas and Matplotlib and so on directly in the browser through WebAssembly. Then we have also assembly script. So assembly script is a subset of TypeScript that are compiled to WebAssembly. And one thing to take into account is this is a smaller project, so it has it has sponsors, but it's nothing like Mozilla that stands behind Rust, for example. And then we have from Microsoft, we have Blazor. So the idea here with Blazor is that you can compile your .NET code to .NET assemblies, and then through an open source version of the .NET framework, which is called Mono, you can run everything in your WebAssembly in the browser. So this is an example, simple example here of a counter where you can increment your counter, and then this is maybe comes as unusual, but then you can actually see some of these, like run the Blazor app DLL or the Mono framework or the Microsoft JS Interop DLL, run that in the browser, which is actually quite interesting. So now we come to this new old headline here. So one thing that you might ask yourself is, haven't we really seen this all before here? So we've had in the past, we've had ActiveX components, and we've had Flash, and we also had Silverlight. But one of the main differences from that time and from now is that these have all been proprietary technologies, whereas now we have WebAssembly is actually W3C draft. And as I said, it's sort of the fourth building blocks of the web. So we have HTML, and we have CSS and JavaScript, and then we have WebAssembly. So I think that's a sort of a security that that WebAssembly is not going anywhere, and it's very interesting technology here. So what is the conclusion here? Should we go WebAssembly all the things? Well, I don't really think so, because WebAssembly is very good for some use cases. Like, for example, if you have this desktop applications that you want to be able to run out on the web, or if you have something that needs to be very performant, then WebAssembly is also a good candidate. But if you're a JavaScript developer, you don't need to worry too much about running out of job, at least not because of WebAssembly. So I think WebAssembly is just an addition to your existing toolbox. So finally, I have some references, so you can find more information about WebAssembly on these references. And if you're interested in Blazor, which is the Microsoft alternative here, you can also find information about that. So with that, I would like to thank all of you for coming to my talk. And if you want to reach me, if you have any more questions, you can always reach me on Twitter, where my Twitter name is Agrevlis, or you can reach me on email through this email address. So thank you so much.
All right. Thank you very much for doing this. This has been quite fun. I think we all learned at least something tiny little bit more, or even more, or just learned totally something new. That's really great. There were a few questions. I mean, we're a little bit over time, so we'll be quick. But there was a question about how to work with this thing. I mean, will it work with a big, huge project? I mean, it might work with the smaller projects where you kind of have a control and everything, but with the bigger ones, it's there were some comments that will it work? What's the way of doing that and everything? And the second part, I'll just ask it right away because it's kind of connected. The second one was also something with a debugging, because like how easy can it be to debug all that thing? So over to you.
Yeah. So one of the things that I didn't touch so much about was about tooling. So we're still, even though WebAssembly has been around for some time, the tooling is on a quite not so sophisticated level. So for example, we don't really have any IDEs for working with WebAssembly or anything like that. So that's one of the main difficulties, both with debugging and also for taking in use in much larger applications. But as we can see, it's not impossible. Like we could see, what some of the examples that are showed here are actually quite large examples here. So it can be done. But I think if you should truly investigate and see, and also keep a check up on WebAssembly. I think the tooling will probably be much better here with time.
All right, that makes sense. I mean, it's always like that. But the new breaking technologies, like bleeding edge kind of technologies, it's always like that, right? You create a technology, people start using it, tooling will come, and there will be more and more support for that. So that's great. I don't see any other questions so far. There were some comments and some comparisons and stuff, but no questions. So I think I'll say thank you very much again for doing it. Thank you for joining us. It's been always fun. It's always fun. It's been fun. Yes.
Thank you so much for having me. Thank you.
Bye-bye. All right, Mohit, welcome. Hello. Great to have you with us. So I will leave the stage very soon for you to introduce yourself, introduce your topic and everything. I'll just remind yet again to everyone who's listening us live on YouTube, use the YouTube chat to ask questions, type them there. And we'll be back at the end of the talk after like 20-25 minutes when Mohit is done talking, and we'll ask the questions live and talk about that. So I think I will not keep you all waiting, and without any further ado, I'll leave the stage to Mohit to do your thing. Talk about Kotlin.
Thank you. Thank you for giving me the stage and letting me present myself. So let me quickly get started. Today, I'm gonna share my thoughts around Kotlin multi-platform. Mm, it's late, kind of late to say Happy New Year, but still Happy New Year, everyone. So before I get on to the actual talk, this is my agenda for the day. My aim with this talk is to help you understand what is KMM, irrespective of irrespective of your experience as a developer, and what benefits you can leverage with KMM, and how, if you really get excited with my talk around KMM and you decided to build your first application, I should be able to give you some basic few tips how to get started with it. So let's move ahead then. So, a little introduction to myself. I'm Mohit. I have been a mobile developer for around 12 years now. I started my journey with Android 1.3, if I remember correctly. It has been a long time. And since then, I've been building mobile apps, and I got an opportunity to build 3 to 4, 5 great products. Currently, I'm working with MongoDB based out of Ireland, working as a Realm developer advocate. So that's all about me. If you have any queries or questions around Android or mobile in general, or you want to share your feedback or any questions regarding my talk, you can always reach out to at my Twitter handle, Code with Mohit. So what is Realm? Realm is an object-oriented database. Um, Object-oriented database specially designed for mobile applications. It's an open source by nature, and the main key feature of the SDK it is that it helps you build offline first application. If you decided to move forward with it and you want to build the complete end-to-end solutioning with it, it gives you sync out of the box. Sync means you can share your data around the globe with the people. It comes out of the box, and the cloud realm also have very exclusive functions like functions, triggers, or support for GraphQL and whatnot. We support all the major platforms on mobile, iOS and Android both definitely. We also support gaming platform like Unity. Even after that, if you decide to build a hybrid app, you can use Flutter or React Native SDK of ours. If you decide to build a web based application, you will find our SDK supported there. Just to let you know that we are soon coming up with our KMM version of the SDK. That's gonna go live very soon. And in the future talk, you'll also understand why KMM became an obvious choice for us. So enough of my promotions. Let me go into the actual talk. Why KMM? To understand why and the need for the KMM, I'll have to go a little bit into the history of mobile development. Mobile development have been there for almost a decade now, and I've been fortunate enough to be working since the starting of the development. I've seen a lot of things moving around here and there, but one thing which I consistently noticed from I would say probably 1 or 1.5 year later is that people have been trying to solve one problem: how to build mobile apps for all the platform with one code base. And the reasoning behind that was very obvious. With one code base, everyone was thinking that, with one code base for all the platform, you would require lesser code to write. So developers will write lesser code, which in turns will mean that if there are bugs, there will be lesser on that, and it will be quicker to fix them, and overall the time to build one code base will be lesser than building multiple code bases for iOS different, for Android different, and all those, which in turn translates to two simple things: lesser developers, and biggest of all, which any organization for which any organization matters, less money. But from a developer perspective, if you think, it kinds of represents the pattern that don't repeat yourself. In the later talk, you'll also understand why I mentioned don't repeat yourself pattern with promoting KMM. But with all these platforms available, trying to build app with this approach, there were a few problems also that got introduced over the period of time. One of the things which I could notice from my experience was, and you would have also noticed that sometimes you'll feel that you're using an Android app, but the user interface or the app is behaving like an iOS one, and likewise on the iOS as well. So this was one of the very common problem which came in with all these hybrid platforms coming into picture. From a developer perspective, the picture was altogether very different. Performance was a very big challenge. If you have been a mobile developer for quite some time, you would have heard the 60 FPS benchmark. That has been there for quite a long time. It's just because the hybrid apps or the apps which were built with one single code base were not up to their mark. Things got changed a little bit with Flutter and React Native coming into picture. Performance has improved, community support has improved majorly, but it has been there just because the two very big companies, Facebook and Google, were behind them. So with all this, what I'm trying to present one simple problem. People are trying to build apps for all the platform with one simple code base, and they want the performance and interaction of a native app. So that was the one problem. Now let's try to look this problem from a very different perspective, from primarily a developer perspective. So if you have been a developer, there would be a situation in your career or during your development time that your counterpart, like say iOS, has developed the feature, and the same feature you have to also develop on Android. And sometimes you'll feel that I wish I could have copied them, simply copy that feature onto the other platform. Okay, there could be various reasons for that. One of them, you could be lazy like me, or your feature might be running late because of some complexity related to the platform, or the UI is very complex on one platform, it's not on the other one. It could be any reason, something like that. But if you think from a high level perspective, you will understand why I'm trying to propose this. Because at the end of the day, whenever someone is trying to build a feature, it is nothing but a combination of some business logic with a UI on top of that. This business logic would be some business rules and uh, some code or logic to bring up the data from one of the different resources. But naturally you can't do this. It's not very simple. The platform has to support, the programming platform has to support, the languages has to be common and all those stuff. So definitely it's not possible, but the idea was very simple and nice as well, right? Kind of going into the same lines, don't repeat yourself. So if I try to combine both of the problems together and just try to break down into very simpler things, we want to build apps with one code based for all the platforms. Okay, and it should be simple enough or performant enough that gives the performance of a native apps. If you'll see here, you'll also try to understand that most of the application has logic, or as per me, 70% of it is pure logic. Only 30% of it is UI. So why not bring all things together? Why not write the logic in such a manner that it can be exposed to any of the platform, and we kind of follow, or we clearly follow the pattern of don't repeat yourself. Now, this is where Kotlin multi-platform comes into picture. This is the idea which is what it is trying to promote. Why not have a common module which will contain all our business logics, methods to access data, and rules over the top of it, and then somehow kind of try to expose or share this business logic to build platform specific UI. Since most of us, I believe, are mobile developers, I'll be more specifically talking about Kotlin multi-platform for mobile. In simple terms, it's also called as KMM. But in general, Kotlin multi-platform is supported on various platforms, be it building native apps or Mac OS apps or Windows or Linux apps, even for wearables. Okay, so it's a widely acceptable format which can help you build apps, not just mobile apps, but apps which can run on any platform. So now, since you have understood why or what is the need of the KMM, let us also try to understand what magic KMM does, or how KMM does its magic. In my opinion, if you'll say what is KMM, I will simply say KMM is nothing just collection of bunch of Kotlin modules. In general, it has a common Kotlin module, which includes the language's core libraries and the basic tool. This code is written and works everywhere on all platforms. Then with this common module, with Kotlin multi-platform libraries, we can reuse this logic in the common module. Now, once this is there, it is exposed to the platform specific version of Kotlin, like say Kotlin for Kotlin JVM, Kotlin JS, or Kotlin native, which includes the extension to Kotlin language and platform specific libraries and tools. Through these tools, you can access the platform native code and leverage all the native benefits. One of the benefits which I was mentioning you earlier, that we want to have the performance of the native platform. And the another good part about this is that even with all this, the artifacts which gets produced at the end of the day remain the same. So there's no changes over there. So if you look at the project structure, it is fairly simple. You can see that there is one shared module wherein you'll be writing all your common logic, as I mentioned you earlier. And then over the top of that, you can specify your platform specific code, Android and iOS specific code in the Android and iOS app modules. Shared module can be further broken down into the platform specific code and the common code. This is very useful in scenarios wherein, um, let's say for example, you want to get a user location and using the platform specific APIs. So in Android, there's a different way of doing it, and there there is a different way of doing it. So with that, you can even leverage those ways of doing it. But in general, let's say for example, you want to build something like this. What would be your approach of doing it? Like you want to write a function, or you want to introduce a common specific code and then further down break down into platform specific code. One way that will come to your mind is, why not do the traditional way, right? Let's create an interface and then write platform specific implementation. That's the traditional way of thinking it. The other way of doing it is the KMM way of doing it, by the use of actual and expect. So actual and expects are the Kotlin mechanism of developing a Kotlin multi-platform application that needs platform-specific API access. Okay, this clearly calls out that, okay, this when you define an expect, it means that this is just a declaration, and with the actual implementation, it would be written on the platform-specific uh, module. With this actual and expect, you can expect that it works throughout all the common Kotlin declarations, such as function, classes, interface, properties, annotations, etc. So now let's try to look down at the basic implementation of actual and expect. So this is just a declaration of it. We'll go into a small example of that as well. So in the common module, I just defined my expect, and then on the platform specific modules, I've written the implementation of both of them while using the keyword actual. So so one of the examples which I have mentioned here is, let's say for example you want to generate a random UUID. This is the common logic which you want to expose, but you want to write platform specific code for this. So in Android module, you can simply go and you can use the UUID, which is there in Java utils. But in iOS, there is nothing called Java utils, right? There is platform specific foundation libraries. So you want to use that. So there you in the iOS part, you just go and define your actual, okay, there will be a UUID implementation, which will be using NSUUID dot USID string. Okay, so here you can see how you can split it based on the platform specific thing. So now let's move forward into another example. So now you want to just understand, okay, what is my platform right now? Okay, you just want to expose a function called platform, okay, which can be further used by your UI modules exposed further. So then it goes down to the very simple and the same thing. You define an expect class called platform, okay, which has a member variable called platform, okay, and this platform can be accessed by the external modules. And then now what you do is you define your actual and tell, okay, in Android you need to use Android OS property to understand what is the platform. On iOS you need to use UI device property to understand what is the device and its version. Fairly simple, right? Now let's move down to some more logic around it. If you have been developing apps with Kotlin, you will understand that the suspend function plays a very important part of it. And it is also a very important aspect of the language, because it clearly redefines how the asynchronous or non-programming is done in Kotlin. But this is not available on iOS or Swift. It's not there, right? So how will you do it? But still you want to use that leverage for that. Don't worry, Kotlin also provides you provisioning for that. With KMM this is possible. Basically whenever you write a suspend function, as you can see in this code snippet, and when you try to use it in the Swift block, it converts into a callback mechanism. So everything remains the same. You don't have to change it, and you have the flexibility of using your suspend functions as well. So this is around the basics of what you can do and what not. It's not possible. Definitely, there is nothing possible. There's everything possible with KMM. I didn't mention anything around that. Okay, so this is how the basics move around with KMM. But Kotlin language by default is not sufficient for building any mobile app, right? You will be needing some external library support as well, right? You will be needing a library for reading the data from the internet. Like earlier, we used to have Retrofit or Elomofire for iOS, right? How do we do that? So for that, we have Ktor, which is another Kotlin supported library, which you can use that. Now, once the data is there, you want to pass the JSON and read it, right? For that, you can use Kotlin X serialization. And at the end of the day, you decided, I want to save my data. I want to have some local data around it. So in that case, sorry, in that case, I would recommend you can use Realm for that. If you come across any other requirement and you want to just explore what kind of libraries are available on Kotlin multi-platform, I would recommend you to check out this GitHub repository. It's very useful. It has a bunch of all the supported KMM libraries available. Now let's quickly get started and try to understand how do I build my first KMM app. It's fairly simple. Just install the KMM plugin on IntelliJ or Android Studio, and rest all the things is taken care by this plugin itself. As soon as you install the plugin, you can choose the template from the plugin of building a KMM app. Post that, you will have to give some basic details around it, like name of the project, the package name, the location, the minimum SDK required for the Android project, Then some other details like what would be the name you would like to the name you would like to call for the Android module, for the iOS module, and for the shared one. So so in that case, I would recommend you keep them as default because that's the standard of it. And you can also define the package manager which you will like to download the iOS related dependencies. Now, since that's done, so you are able to write the project now. You, as I mentioned you earlier, but how do you run it? That's the beauty of the KMM plugin, which you have installed on the IntelliJ or Android Studio. You would be able to run both of the applications from the same tooling itself. You don't have to open just an Xcode to see how to run the application. You can do it from the Android Studio itself. This is a screenshot of the IntelliJ, wherein you can see that I am able to run both iOS and Android application together on the same platform. So that's the beauty of it, and this is the output which you'll get from the by creating a default template project with the KMM plugin. Now let's quickly try to see the setup of the project. I'll try to run quickly. I think so I'm running a bit behind. So when you try to understand how the magic it is done, it's fairly simple. In the plugin module, you simply define what is the plugin you have to use. You define your Kotlin multi-platform plugin. Then you define the native Cocoa Pods, which is used as a dependency manager for iOS. And then you define your common project as a library project. Then another specific area of the Gradle setting is that you define all your targets and your source set. You define which area, which source set you have to use as a common for the common, which you have to use for the iOS and which you have to use for Android. Here you can also define your source set for the testing module as well. So again, you will be able to see something like this. Now, this is that. Now the decision comes in. Now, one of the very important decisions you'll have to take: when should I use KMM and when should I not use KMM? So this decision purely depends on your use case. What is your legitimate use case? How does your team feels about it? And there are some other important discussions that has to be taken place, like who will write the common code, who will maintain it, how iOS and Android will bridge the gaps around it, because it's fairly new for both of the platforms, but iOS will have to do a long learning curve as compared to the Android one. So these decisions should be taken into consideration when you're thinking to decide when you should use KMM. With respect to the business use case, I won't suggest any of the cases where you shouldn't use KMM. But for most of the typical business use case application, be it e-commerce or any application where you have day-to-day business logic, get the data from the network, display it on the UI, take some user action, and then do the same. Then it's fairly simple and the right choice of moving towards the KMM, because you will save a lot of code around that. Few of the other pros and cons which I would like to talk about at the end is that I'll start with the disadvantages right now. So the Kotlin multi-platform API, that is still in alpha phase. They plan to release the beta version by this summer. A summer or spring, I'm not really sure. I don't remember correctly right now. So that's one of the disadvantages. But till now, with my experience of building KMM projects, I have never faced an issue or any issue with respect to the support of that. If you're trying to do the Gradle configuration by your hands for the existing projects, yes, there would be a little pain. It's not fairly simple to set up the project right away. So you will there will be some problems around that, but you will get over it. Another disadvantage you might see is the resistance within the team itself. Since the platform has been evolving so quickly, be it Android or iOS, there would be a lot of resistance within the team, that do we really need to migrate to this platform, because from Android perspective, first Kotlin, then Jetpack components, and then other components coming into picture, and now KMM. So there will be some hindrance from the Android side, and from the iOS side, for them would be also the hindrance that we don't know the platform altogether. So for us, it will be like starting the board from the very start. But then you will have to, have these discussions around that. That's one of the kind of a disadvantage I see with respect to the within the team. But from the advantages point of view, one of the very big advantage I like to mention is that you follow the pattern of don't repeat yourself. You are forced to follow the pattern of suppression of concern. You get all the benefits of the Kotlin programming language. That's one of the most used languages right now, as per the recent Stack Overflow space as well. Another benefit, which another disadvantage, advantage I would say, is that there's no bridging right now, because at the end of the day, you are building native apps as well. So the performance issues and all those stuff will not be there. Um, the commitment is very low. You don't have to start from the fresh. You can even start with one feature. You can just change the existing project and see that. So it's a very low commitment kind of a thing. You don't have to go full-fledgedly. Uh, Although I mentioned in the disadvantages that there will be resistance from the iOS team, and here I'm saying that the learning curve will be small. The learning curve will be small because one part of the team already knows how things work, because they don't have to learn too much differently. Kotlin is still, they have been using in their apps. They have to just learn few more semantics around the Kotlin multi-platform. So that's why I like to mention that the learning curve looks like very high, but it's not actually. It's very small. And that's all for me today. Thank you for time. If you have any other queries, I'll be happy to give you answer on that. And feel free to reach out to me at code at with Mohit on Twitter. Thank you.
Yeah.
Do we have any
Thank you,
questions?
Mohit, for the wonderful presentation regarding KMM. So we have a questions. Yeah, we do have
Yes,
a
please go
question
ahead.
in the chat window from Moira. Do we need to write platform-specific UI?
Yes. So I think so. I didn't mention this clearly. So with KMM, you get a flexibility to write your common code in one go, and then over the top of that, you can write platform-specific UI. Okay, so you can use your Jetpack Compose for Android and the Swift UI for iOS. You get that flexibility. KMM is not writing the UI for you. It's just writing the business logic for you. Does this answer the question?
Yeah, thanks. Yeah,
Okay.
I guess so. Irvin is satisfied, I guess. Yes, yeah. Yeah, thank you, Mohit, for the wonderful talk. So in next up is Sulaiman Fateh. So his talk is shooting a glance at Android app widgets. So we welcome Fateh to the stage.
Hello, Leonard.
Hi, Fatih. Welcome.
Yeah, thank you so much for having me.
Yeah, nice to meet you again. Yeah.
Yeah.
So
so should I just start?
You can start sharing your screen, and then we can go. Yeah. Can you share your screen?
Yeah, sure. I'm just sharing it. Yes. Yes. I hope you do see my screen now. Yeah, so hello everyone, my name is Fatih. I am an Android lead at DNB Bank. Today we're going to be talking about how we can create Android app widgets using Glance library. But before start, I would like to talk more about app widgets. If you have ever created an app widget, you know what I'm talking about, so you know the pain. Even though it says create a simple app widget in the documentation, if you just scroll down a bit, you will see that it's not that easy, and you will see that also creating an app widget and the process is different than just creating a normal Android app. It's mainly because app widgets lives in a remote process, and in order to be able to interact with the remote process, you need to provide something called remote views. And the remote views has a lot of complex APIs already. So because of this reason, Android team has created the library called Glance in order to overcome the complexity of these widgets. Today, we're going to be talking about what is Glance and how we can actually use Glance in our apps to create an app widget. And then we will see the already provided actions, some of the provided actions by Glance. And then we will see the size modes that we can use with Glance. And at the end, we will be discussing about what are the benefits and disadvantages of using Glance library. So let's get started. First of all, I have also told you that Glance is a library to create app widget, but what does it make it different than creating a normal app? The main reason is Glance is built on top of Compose runtime, which means that you are actually able to use the composables in Glance library, and Glance library will take care of the rest. But how does the Glance library do that magic? It's mainly doing the conversion from the composables to remote views. Glance library's main responsibility is converting your composables to remote views. But that comes with some limitations because remote views already has a lot of limitations. And that also applies to the composables that we are writing with Glance. Also, I would like to mention also that if you see any term called glanceables, it is also the same with composables, but the only difference is it's used any composables inside the Glance library. So glanceable is a composable, any composable coming from the Glance library. By saying that, let's go on the main list. We have also talked about its main responsibility is converting your composables to remote views. And the next is Glance library has already Android 12 widget improvements out of the box. So if you're using the Glance library, then you will get the Android 12 widget improvements out of the box, like dynamic coloring and the responsive layouts, etc. Lastly, but not least, it is backwards compatible up to API 23. And even though it compiles with API 21, it will not be working as expected. So minimum supported API level is currently API 23. Enough talking. I know I told a lot about this library, but now let's see actually how we can implement a simple app widget. This time, I promise you it's going to be a simple, not like the remote views, but we're going to be using some composables, and Glance library will do the magic. So we will start by extending Glance app widget receiver. Glance app widget receiver is a broadcast receiver to listen the updates coming from the app widget. We start by extending that and then creating our app widget inside our app widget. So I just called it Clocked App Widget Receiver. It's a sample project, so I can share it afterwards. But for now, I just call it a Clocked App Widget Receiver. And what we are doing inside the App Widget Receiver is simply creating our main app widget. And remember to define the Glance, this Clock App Widget Receiver or whatever app widget receiver you're defining in your manifest file. Then we will go for the actual app widget. Glance provides a class called glance app widget. By extending this glance app widget, we will get access to the composable content function. In this content function, whatever composables you write in this content function will be rendered as your app widget. So let's go ahead and write some composables. Let's start by inserting a text. Let's just write a text composable here, and it says hello from a glance widget. If you run this, then you will see a app widget in the widgets, and if you just drag and drop, you will see that it will show that text. Don't worry about the color of the text. For the sake of this presentation, I removed the color, but it's mainly because I was testing this glance library with blue color. And then as we've seen this text, there is one little difference actually. So this text is actually not coming from the composed material library, but it is coming from the glance. The main reason of this one, as we discussed, the remote views. Remote views has its own limitation, and it applies to the text composables in glance library. So the normal composables that we are using in our app is tightly coupled with the Android framework, which is not actually what we want when we are creating an app widget, because in app widget, we're using remote views. So in the glance library, there are composables specifically created for glance, and we need to use those composables. So it means that we can't actually reuse the already existing composables in glance. So it also applies to modifier. If you are going to define padding, or if you want to make the composable clickable, what we are doing is we are doing it through modifier, right? So it's the same with glance composables. We are using modifier, but this time it's also not coming from the compose UI, the modifier that we already know, but it is coming from the glance library. So you have to use the glance modifier. And of course, it has some limitations, and it's not the same with modifier, even though we have common APIs like clickable, background color, padding, etc. Even though it looks similar, it's not the same as the modifier that we are used to. As we discussed, the main reason of that is it's built on top of the Compose runtime. You can think Glance as another platform that is built on top of the Compose runtime, just like Compose Web. In Compose Web, there are different widgets, right? If you have a text composable for Android, you can't just reuse that composable in Compose Web. So you can think the same as Glance. You can't just reuse the same composable that you're already using for Android in Glance library, because its job is to convert the composables to remote views. So we talked about the Glance and how it works. Let's go and talk about the actions provided by the Glance. There are 4 different types of actions already coming from the Glance out of the box. If you want to start an activity, broadcast receiver, or start service, do make sure to use the actions provided by the Glance library. Or if you want to have your own custom callback, let's say you want to show a toast message when the user clicks your app widget, or you want to do something or log something when the user clicks your app widget, then you can make use of the action run callback API coming from the Glance. Let's go and implement something with action. So when I want to implement something, whenever user clicks the app widget, I want to show an activity. In order to achieve this, I define a modifier, and I make that modifier clickable, and I give the action as action start activity by my activity name called my activity. If I do that, then whenever user clicks the app widget, it opens my activity. But what about if you want to have your custom action? If you don't want to just start an activity, broadcast, receiver, or service, but instead you want to have your custom action, then you can easily do it by changing that action start activity to action run callback. And then you have to implement your own action callback. So there is a class called action callback from the glance library, and if you want to implement your own callback, you have to implement that interface and give that callback to this action. So these are the actions provided by the glance library. What about the sizing of the app widget? You might have noticed that in Android 12, there has been a lot of improvements about app widgets, and sizing is one of them. And these are coming already with the glance library out of the box. Let's go and talk about sizing. So there are 3 different size modes coming in the glance library. Let's go each one by one. Let's start with this size mode single. So single size mode means that your content composable function is only called once with the minimum size provided by the app widget metadata. And there is also another thing called local size. Local size is a composition local coming from the glance library. And that local size keeps the current size of the widget. But it does not actually always keep the current size, but it also keeps the size of the widget provided in the content composable. So if you're defining your app widget with size mode single, then it will always be called with the minimum size provided by the app widget metadata. But how are we going to define the size mode? So in order to define the size mode, you can just override the size mode and set that size mode to single. If you do that, then as you see in this video, the last line shows the size of the app widget. But if you notice that even if you resize the widget, the last lines are not changing. This is mainly because the content is not changing. The content is only called once, and then the size of the widget is actually always be the same, which means the minimum size. But what about if you want to get the resized size in the content composable? Then you can actually use the size mode exact. Whenever you use size mode exact, then your content composable function will be called every time the size changes. And it means that local size composition local will always have the latest size. In order to define your size mode again, you can just do it as the same we did with size mode single. You can override it and then set that size mode to size mode exact. And then you will get your content function will be called every time you resize the widget. Now, if you see in this video, the size of the widget is always changing and the last lines are always changing. It's mainly because we're getting callback each time user resizes the widget. But what about if you don't need to update the widget after every resize? For example, if you want to show something, if there is a space, and then if there's enough space, you don't need to get callback every time when the user is actually resize the widget bigger than that space. So then there's also another size mode called size mode responsive. Size mode responsive, if you use this one, the content composable is going to be called for the size defined by your app widget. So it means that you are going to define the size supported by your app widget in compile time, and then local size composition local will always have one of those sizes defined by you. If you want to implement this size mode responsive, first of all, what you need to do is you start by setting some sizes, responsive sizes supported by your widget. In this case, I define 2 sizes, small box and large box. Then you are going to give this override the size mode and set it to size mode responsive. And then you have to give set of sizes supported by your app widget. Lastly, in the content function, by reading the local size composition local, you can check if the size is equal to small box or large box, and depending on that, you can call the appropriate composable function, and then your content will be rendered based on that composable function. So now if you see this in video, Now, if I resize it, it's a small box. And if I resize again, now it's a large box again. But now the size is not changing. The last line is not changing. It's mainly because whenever you are using size mode responsive, the content function is only being called if you're actually changing between the size supported by your app widget. In our case, it's the small box. If it's going from small box to large box, then the content function is being called, or the other way around. As a TLDR, as we discussed, Glance Library, you can make use of the composables, write some composables, and Glance Library converts those composables to remote views in order to make to creating app widget process easier. Currently, it's not possible to use the same composables that we are already using in the app because they are tightly coupled with the Android platform. But in Glance Library, we want to just convert the composables to remote views. So whatever limitation in remote views, we will also have in the composables, so glanceables in the Glance Library. And do make sure that make use of the actions and size mode. If you want to make it responsive, do use the size mode responsive. Or if you want to get a custom action, then you will make sure to use the action run callback API provided by the Glance. And remember that it's still in alpha. There might be breaking changes in the feature. And do not forget to submit your feedbacks to the team so that they can actually find some bugs and improve the Glance library. So that was it. If you have any questions, we can go for Q&A session. Thank you a lot.
Yeah, thank you, Fatih, for the wonderful explanation on the Glance feature.
Yeah, thank you.
Mm-hmm. Yep. Let's see whether we have questions in the chat window.
Sure.
No, it seems to be quiet.
All right.
Yeah.
Cool. So everybody's happy with that then.
Yeah. Yeah. Maybe one question for myself.
Yeah, sure.
Yeah. Okay. Okay. There will be a short break now until 2:30. Yeah. If there's no question. Yeah.
we've already started to see the difference we can make by working together as a community.
Hi, welcome back, everyone. Yeah, our next speaker is Monica, and the title of the presentation is Unit Testing Made Easy with Mock-K. So let's welcome Monica to the stage. Yeah.
Thank you, Leonard, for the introduction. Hello, everyone. Before we start with the session, let us all meet Julie. Julie is an Android engineer working at XYZ company, and she's working on the ABC Retail mobile application. So she has started writing code in Kotlin, and because she had been writing earlier in Java and she was using Mockito as a testing framework, she looks forward at using Mockito for unit testing her Kotlin code. And she finds certain problems with Mockito, like Mockito cannot mock or spy final classes. Now, to solve this problem, she comes up with certain solutions. So before I move further, I just want to confirm once, is my screen visible? Is my screen visible? Okay, so she explores certain solutions for fixing that problem. That is, we can make our classes open or we can use interfaces. But all this would require her to re-architect her code. So she explores further more solutions, and she understands that we can either use the incubating feature of Mockito core, which is having a folder named Mockito extensions in your resources, which will have a file named mockmaker, and it will have mockmaker inline as its content. Or we can use Mockito Kotlin wrapper, which provides helper functions of Mockito in Kotlin. So with these two solutions, most of our problems get solved, but there are further more problems with Mockito. That is, it requires one to write a lot of boilerplate code to mock Kotlin components like Kotlin objects, which are singletons in Kotlin. Or second is it doesn't support mocking of private and static functions. So for mocking of private and static functions, either you can make your private functions visible for testing using @visible for testing annotation, or you can use power mock in conjunction with Mockito to mock your private and static functions. But power mock is known to have a reduced code coverage, and it comes with a lot of byte manipulation risks. So with all these problems there, she goes to her friend Oleski and she asks him that these are all the problems which I'm facing with Mockito. I am using Kotlin, which is the first class language now for Android app development. So now what should I do to fully test my code? And then he gives her a solution, that is Mock-K. So hello everyone once again, and I welcome you all to this session, which is unit testing made easy with Mock-K. I am Monica. I'm an Android engineer from India. I'm India's first female Kotlin GDE, and I'm there on Twitter and LinkedIn and on GitHub as well. So if you have any queries post this talk, please feel free to reach out to me there. So because we are talking about Mock-K, let's learn what it is. So as its name signifies, Mock-K. So the extra K stands for Kotlin because Mock-K is a mocking framework which is built specifically for Kotlin. It provides first-class support for Kotlin features, and it has a DSL style Kotlin syntax. So to get started with Mock-K, we'll include the dependency. So Mock-K can be used for both local and instrumentation tests. I have used it for local tests only, but it can be used for instrumentation tests as well. So with Mock-K, we follow the same principle of testing, that is arrange, act, and assert, the 3A principle. That is, first you arrange your test data, create your mocks for your method call to happen. Second is act, which is do the method call. And third is assert, which is after the method call, verify whether the actual value is same as what you expected or not. So let us get started with using Mock-K for mocking. So if you have a MVVM style architecture in your project where your UI controller like fragment or activity invokes the view model, and view model in turn invokes a repository for any network or database operations. So in that case, your repository class should look like this. It should be having it should be single source of truth, and it should be actually making calls to your API or your database. So if you are testing your view model where you are actually calling the repository, you would want to test the view model class only and not end up testing the repository. So in that case, you will be mocking the repository so that you can mock the repository, mock its functions, get a mock result, and in turn end up testing your view model only. So to mock this repository, we can mock it using Mock-K in two ways. We can use Mock-K and we can specify the class type, which in this case is video repository, or we can use @Mock-K annotation. So when we use the annotation, we'll have to use this initialization method which comes in with Mock-K annotations. We can use it like this, and then that is what we need to do to actually mock the class. Then there are further constructs like every and verify, which I'll be talking later in the session. So this is another example where you have a class under test and you have a dependency class, and class under test calls a dependency class. So again, if you are testing your class under test, you don't want to end up testing the dependency class. So in that case, you will be creating a mock of dependency class. So this is how you create a mock of your dependency class using Mock-K. In the first line, you use Mock-K dependency. You create a mock of your dependency class. Now you want to mock certain methods so that those methods, instead of doing that actual computation, return a particular mock result. So for mocking the method result, in Mock-K we use every construct. We had a similar construct in Mockito as well, which was when then return. Here it is simply every, and in every you specify that on dependency mock, when calculate result is called, the result should be 1337. It should not perform any computation. It should return this particular result. And then you perform your act step, that is you make the call, and after that you verify. So with Mock-K you can verify using the verify construct. In using the verify construct, we verify whether the method call has happened on a mock or not. So here we verify that calculate result method call has happened on dependency mock or not. and then we assert whether the result which we got is equal to 1337, which is our expected result, or not. And then we use confirm verified on the dependency mock. So I'll be talking about confirm verified later in the session. Now let's have a look at another example. Here you can see we have a class named data service, and it has two methods: get data from DB and do some operation. Now here, because this is just an illustration, these methods are taking a string, returning a string, but in actual code they'll be performing their database operations respectively. Now if we have to mock this data service class, again we write mock k of data service, and then to mock this particular method. So if you see, get data from database returns data is returned, but I want to mock this method so that instead of it performing any computation, it should return the mock result. So to do that with mock k, I use the every construct here, and I write every, which is my then I use the mock of my data service, which is service. I use dot get data from DB with the parameter and say it should return that particular result. And then I do this method call that is on the service mock. I call this method get data from DB with the parameter, and I get a result, and then I verify whether the call has happened, method call has happened on that particular mock or not. And I also use equals and verify whether my result, which I actually get in step number 2, matches the expected result or not.
Hi, hi, Monica.
Yeah.
Sorry we have to interrupt your presentation. I guess we are seeing the PowerPoint with the slides entitled solution. Is that intended on your side?
No, it is mock annotations right now. Let me share my screen again.
Yeah.
If that is happening.
Yeah, I can see it. Could you share screen? Yeah, thank you.
Yeah, so is it visible now? Mock annotations?
Yes, that's better. Thank you very much. Yeah, please.
Okay, so now let's move on to the different annotations with mock k. So here you can see we have a class inject test service which has two variables of type data service. So because inject test service class is actually using these two dependencies, to test inject test service, we'll be mocking these two dependencies. So let us see how we can achieve that with mock k. So here you can see I've used mock case annotation method, and I've created mocks of these two dependencies using at mock annotation, and then I'm using inject mocks because these two mocks will actually I'm creating a mock of this particular class, and I want to inject these two mocks in this class because these two are dependencies of which this class has. So in that case, I use inject mocks here on the inject test service. And then as I mentioned with the annotation method, we need to use the mock annotations initialization method in our setup. Now moving on to spine with mock case. So spy stands for the real object. So in case if there are any methods which we don't mock, in that case they will return the real result. Otherwise, for methods which we mock, we'll get the mocked result. So we can spy a particular class with mock k using spy k and tell the class type, and then once we get the spy, we can say that every call or to this particular method should return a mock result. Then when we do that call to that particular method, it returns as the mock result. But because the other method, like you remember data service had two methods, so this is just one method which I'm mocking. I'm spying the entire class, but I'm mocking the other one method, so the other method will return me the actual result. So you can see for the other method, I have not mocked it. I have not used the every construct. So when I make the method call, it actually gives me the actual result. Now moving on to relaxed mocking with mock case. So there can be times when you wouldn't want to mock a particular method in a mock. So if you don't mock a particular method in a mock and happen to make a call to that method, in that case you'll get mock key exception that the method on the mock hasn't been mocked. So to avoid that, we have this option of using relaxed mocking in mock-K, which can again be used to relax mock-K annotation, or we use mock-K relaxed equal to true. Now you can simply create a mock of your class with this and use relaxed equal to 2 parameter. This will create a relaxed mock, and by relaxed mocking, what happens is that when you do a particular method call and the method hasn't been mocked on the particular mock, in that case it will return you the default value. So here I'm not mocking anything using every construct, and I'm simply making the method call. So in that case, because the method was returning a string, I get the default of return type, which is default of string, which is an empty string. So that is how like even if you don't mock methods on a mock in mock-K, you still don't get any exception. Now moving on to relaxing unit functions. So the same can be achieved in by using a parameter relax unit fun in your mock-K annotation, or using the same parameter in the initialization method. Now moving on to mocking objects. So Kotlin objects are equivalent to Java static classes. So we write an object like this: object name, and then method. So to mock it in mock-K, it is very easy. We use mock-K object and the object name, and then we can mock the other methods of it using the mocked every construct, and we can verify using verify construct. So here the Kotlin object, when mocked using mock-K object, behaves as a spy. So for methods which you mock, you get the mock result. If you don't mock any method, you get the actual result. Now for the same object, if we try to mock using Mockito, so as I earlier mentioned that that will require us to re-architect our code, and we'll have to use interfaces. So you can see the same object, if I have to mock using Mockito, I have to first create an interface with the method. Then I have to get the object. I have to get the object, implement the interface, and I have to put this override keyword before the method. And then I can mock with the help of mocking the interface. And I can specify when this particular method is called on a mock, what should be the mock result. So that is how a tedious mocking with mocking Kotlin code becomes with Mockito. Now let's move on to unmocking objects. So unmocking objects means you move the object from mocked state to unmocked state. That can be achieved using unmock or unmock all or unmock object. And next is mocking enums. So here you can see I have an enum with 3 values. So I can mock it using same mock object and the particular enum value. And now moving on to the next section, which is capturing parameters. So capturing parameters can be achieved via capturing slot or mutable list. So capture slot is when you want to capture value of the argument which was passed to a particular method. And mutable list is used when you want to capture and store specific argument values which were passed during various method invocations. So let us see an example of this. So here you can see I have created a mock of data service, and then I have created a slot. So because I'm capturing the parameters which were passed, I need to have the slot of that particular parameter data type, which in data service you saw both the methods were accepting type of parameter of type string. So had it been one method have accepted parameter of type string, another parameter of type integer, then if I would have been mocking and trying to capture values which were passed to the method which was accepting an integer, I would have created a slot of integer. So here I have created a slot of string, and then I mock the particular method on the mock and say that it should return the expected result. Then I make the method call, and then I can in the assertion step I can verify whether the captured parameter, the actual captured parameter, is what I expected or not. So I can do that by using slot.captured. Now next is mutable list. Mutable list does the same work as capture slot, but it captures the values passed over different method invocations. So here you can see in place of slot, I'm creating a mutable list of strings, and then I'm mocking method, and here I'm passing capture list, and then when after I do the method call in the assert step, I verify the mutable list, I verify the size, whether two invocations have happened or not, because with the two parameters I'll get to know that two invocations has happened, because this get data from DB was accepting only one string parameter, and then I can verify each and every parameter using a list of a particular array index. Now next is mocking constructors. So we can mock constructors using mock-k constructor and simply specify the class. So here I'm mocking constructor of data service class, so I'm specifying data service : class, and then in the every construct I can say any constructed data service get data from DB should return some particular result, which means that any object, any instance of data service on any instance, if a particular method is called, then return that particular mock result. And similarly, you can verify that on any instance of data service, a particular method has been invoked in the verify construct. Now moving on to argument matching. So either you can supply the argument values, or you can use matchers like EQ, which stands for equals, or any, which stands for any. Next is chaining calls. So here you can see that we create a mock of car, and then we mock we perform a chained mock call, that is car.door.window state. So this way also we can have like fluent mocking of calls, and we can do verification as well of fluent method calls. Mockito also supported this. Now next is mocking the hierarchy. So here you can see we have an interface address book which has a list of contacts, and contacts in turn has name, telephone, address, and address has certain other parameters like city or zip. So in this case, if we have two contacts, then we can see how contact is holding the mock of address. So you can see if I have to create a mock address book and I have to create mock of contacts, then I can first of all, to have hold the mock of address in contacts, I can either mock individual parameters, that is address.city returns New York, every address.zip returns 123, or I can create a separate address mock, that is within the contacts mock I create a every address I create an address mock using every address returns a particular mock, and there I mock the individual values of city and zip respectively. Now let's move on to how many number of times if we want to verify particular method call, then how do we do that with mock-k. So we can verify at least, at most, or exactly times with mock-k. So if you write at least equal to 2, it verifies that at least 2 calls, 2 or 3 or more than 2 basically, have been called on a particular mock. At most 2 means 0 or 1 calls have been done on a particular mock. Exactly once means exactly once, and you can use exactly 0 as well to which in turn means that basically there has been no method call of this method on this particular mock. So this corresponds to exactly equal to 0 actually corresponds to verify no more interactions in Mockito. Now let's see if we can verify the order. So mock-k provides us this facility as well, where we can use verify all to see all calls happened without checking any order, verify sequence to see the calls happened in a sequence order, that calls happened in a specific order and was not called means particular method was not called on particular mock or list of mocks. So the difference between verify sequence and order is, in sequence maybe if there are 3 method calls happening A, B, and C on particular mock, and you specify a verify sequence, and in that you just verify whether A and C have happened, it will pass. But if you verify the same with verify order, it will fail. Verify order requires you to verify all the calls which happened. So here is an example of that as well, where we create a mock of data service, then we call get data from database method with parameter param. Then we call do some operation with parameter param, and then do some operation with parameter param2. So we with verify all, again this passes because we are verifying all calls. You can note that I'm calling get data from DB first, but in verify call, verify all, I have put it as in second. So because verify all actually verifies that all calls happen without actually verifying the order. Next, in sequence, you can see that I've passed it in the correct sequence, but if I skip any of the calls, then also it will pass. Sorry, any of the calls in the verify construct. And then verify order, I've specified in this particular order, so they will pass. Next is verification confirmation. So verification confirmation means you confirm whether all the calls which happened in on that particular mock have been verified using verify construct. This is achieved through confirm verified. So here you can see I have created a mock of data service. I have mocked this particular method get data from DB and specified that this should be the mock result. Then I make a call to get data from DB, and then I verify get data from DB has been called on service mock with the verify construct. And then I use confirm verified on this mock, that is the service mock. So here it will pass because whatever calls have been made in the method, there has been only one method call, which is get data from DB, and that has been verified as well in the verify construct. But here you can see that in the act step, I'm doing two method calls. One is get data from DB and one is do some operation. And I'm verifying only one in the verify construct, which is get data from DB and not do some operation. So in that case, confirm verified fails. Now there can be times when you want to exclude some calls from getting verified, and you don't want to have your confirm verified also failing and ask you to actually verify those calls again and again. In that case, you can use exclude records. You can specify the mock and the method call on which you want to exclude from this process. Now let's see how we can mock functions which return units. So to mock functions which return unit, you can simply use every and then mock dot particular method just runs, means it simply runs, or it returns unit, or it answers unit. So I'll be talking about answers later in the session. Now let's move on to mocking extension functions. So here you can see we have an extension function which is on test obj. You can mock it in similar fashion as you mock any other class. You can see first we are mocking the test extension class, and then we are mocking the particular method. Now let's see how we can mock top level functions. So if you have a function in a file, then to mock it, we first use mock static and pass the fully qualified file name, and then we mock the particular method using every construct. You simply say every method name returns, okay, it returns a particular result. So that is how easy it is to achieve mocking with mock. Now moving on to answers. So the difference you can see here I've used every and I've used returns with it, and here I have used answers. So answers basically returns a lambda, a complex result. That is the only difference between returns and answers. Now if you have some Java class which you want to mock in your code, so that you can achieve using static Java class which you want to mock in your code, or any static method, you can achieve that using mock static. You use mock static, pass the class, and then you can mock the respective methods using as you do in Java, like class name dot method name returns particular thing. Now mocking private functions. So for mocking private functions, you basically use dynamic mocking. That is when you mock using every construct, you specify mock and then your method name within square brackets and quotes. Now here you should have the exactly same method name which you have given, otherwise there'll be an exception. And by default, private functions don't get recorded in verify calls. To enable them to get recorded in verify calls, you need to use record private records equal to true attribute. Now moving on to the next section, which is mocking varargs. To mock varargs, basically when you mock them using every, you can pass any number of parameters, or you can say any integer vararg, or you can say varargs all integers which are less than 5. So you can use these different combination with varargs, because a method accepting varargs accepts any number of parameters. Now moving on to mocking coroutines. So coroutines is something which is introduced in Kotlin and for asynchronous programming, and that makes our lives a lot easier. So Mock-K, which provides first-class support for Kotlin, also supports testing coroutines. So we can use the same FD and verify constructs, but we just have to use a different phrase for them, that is co-FD and co-verify. So we add the coroutines test dependency, and then we can use co-every and pass and say the mock dot suspend function. When you make a call to it, it should co-answers return a particular result. So again, here we were using answers earlier, here I'm using co-answers. Now, if you want to see whether a particular call is getting timeout after certain number of seconds, even that is achievable through Mock-K. You can use verify timeout equal to certain number of milliseconds. Here it's 3000 milliseconds, which is 3 seconds. You can see here in this example, there are two suspend functions. One returns a class result and the other returns a default. So we'll see one by one how we can achieve mocking with these with Mock-K. So first line, I'm using co-every and mocking that particular method and saying it returns a particular result. Then in the app step, I'm doing the method call. I am doing this within run blocking because it's a suspend function and needs to be executed in another suspend function or a coroutine. And then I verify the result using co-verify. Now, same thing here. I have used return. Same thing with co-answers would be co-answers and just returning a lambda. Now, there was one function which was actually returning a default result. So that can be mocked using co-every, and we can return a completable default. We can return a default result, default mock result actually. And then again, we'll be doing the method call and we'll be using await and awaiting the result. And then we can actually assert the status, or we can verify using co-verify whether the call happened on a particular mock or not. Now, I would like to throw some light on code coverage with Mock-K. So I mentioned earlier that Mockito has certain limitations, and sometimes PowerMock helps it to do some things, but PowerMock is known for a reduced code coverage. So this is not the case with Mock-K. Mock-K provides first-class support for Kotlin features. You can test everything. If you write tests for all your code, if you cover each and every line and each and every branch, then for sure you will be able to get 100% coverage. There is no Mock-K does not have this limitation of supporting everything and then having a reduced code coverage. This is not the case with Mock-K. Then I would like to share this Jacoco report where I wrote test cases for my class for the different methods, and I was able to actually get 100% code coverage with Mock-K. There is one limitation of Mock-K, that when you execute Mock-K on your entire code base, which has like a lot of test classes, then there might be a caching of mocks. So to avoid that in the test classes where you're using Mock-K, you should actually clear your mocks before each and every test, and mock it before and after your class. So that is how you can avoid that problem when you are running a lot of test cases parallelly or sequentially which are using Mock-K. There is one code sample which I have put on GitHub, which I would like to share with you all, that has mocking and testing of coroutines, a coroutines application, and mocking is achieved there using Mock-K. So you'll get all these things which I spoke about, like co-every, co-verify, co-answers, and various Mock-K constructs and ways of testing. You'll find all this there in this example. You'll find this, as I spoke about, like view model testing and all this is there as well. So that was all for the session. I'll be available on the chat for some time to be for answering all your questions. And in addition to this, you can reach out to me on my email ID, or you can reach out to me on Twitter or LinkedIn. Thank you so much.
Yeah. Thank you, Monica, for the great introduction and explaining Mock-K to us. It's a wonderful tool that maybe some of us may consider to use. Yes. Thank you very much once again, Monica.
Thank
Yeah.
you.
Hi. Hello once again, everyone. So today we have Morten here to speak to us about synthetic controls for Google Vertex AI. So let Morten presenting his content to us. The stage is yours, Morten.
Great. I hope you can hear me. If you
Yes.
can, then yeah, that's cool.
Yeah. Could you share your screen? Yeah.
I certainly will. There you go.
Could you share your screen? Yeah.
Yeah, working on it. Entire screen and allow. And then, does this make sense?
Yes.
So if I do like this, for example, is that good? Right. I can't see the chat now because I only have one screen in this little meeting room here at the company. So if there are any comments or anything like that, Leonard or somebody needs to sort of give me a verbal shout, a verbal tap on the shoulder, and then I'll respond. So welcome. It's nice to good to be here. I'm Morten Forfang. I'm a director at Compitas. And for purposes of this talk, I guess I should also mention that I'm a PhD in artificial intelligence, and I'm a former associate professor in statistical pattern recognition. But over many, many years now, I've worked in sort of a consultancy. The topic for today in this talk is I've named synthetic controls for Google Vertex AI, with the subtitle, What Can We Learn from the Nobel Prize in Economics 2019 and 2021? And I do realize that many of the things might be Greek to parts of the audience. So we'll talk about what synthetic controls are. We'll delve into Google Vertex AI for those who are not familiar with that. And we certainly talk a little bit about the economics Nobel Prizes for 19 and 21. Then. Yeah, and before I do this, I will switch back here and I'll go over to the Vertex AI and I'll kick along this Jupyter Lab because I'm going to show you some code there. And sometimes it takes a little bit of time to sort of get it going. Seems like it's reasonably happy there. So that's fine. We'll go back here and then where was it? Blah, blah, blah. Here. Right. So let's talk a little bit about the subject matter first, and then afterwards we'll look a little bit at the code if you want to. A common question that data scientists are asked has to do with why. As you can see on the right side on this slide, we put lots of money into a marketing campaign. We got increased sales, but was it such that the money we put in were in fact the thing that got the sales increased, or was it something else? What we can say, what data scientists generally can say, is that something coincides. There is a correlation. We can take a cold data set and we can state that, look, every time this thing goes up, this thing goes down. That's correlation. That we can say. But one cannot normally say anything about causality. You couldn't normally say that because this happens, then this happens from a cold data set. So that formula, that mathematical approach to sort of, just taking the numbers and stating something, you normally couldn't say anything about causality. In fact, if it is such that you at university are asked by your professor from a data set like this, how do these columns tie together? And you say that, oh, look, column A causes column B, you will fail. You'll be sent back with a textbook and asked to study it again because you can't say that. So causal things, if you were to make statements about causal things, there are a number of ways you could do that. But one gold standard for that is the randomized controlled trial. And I'm sure you all know sort of the ramifications or the skeleton or the structure of this. It's a typical way in the medical trial, some randomly chosen people get a pill with an active ingredient, and another group of randomized chosen people get a pill which is a placebo, which is kind of, it has some sugar or something like that, but it has no active ingredient whatsoever, and nobody knows what they get. And then if it is such that you can see an effect only in those who get the pill with the active ingredient, then you can make a statement about causality. And for many of these things, for example, this marketing campaign, you can't say that. You didn't design your work that way. Which brings us to the Nobel Prize of Economics in 2021. These researchers, they were pondering about the classic economics question: if you put in place a minimum wage, is it such that unemployment goes up or down? You can make arguments both ways, and it's really hard to know. And then some years back, the governor of New Jersey were about to put in place a policy of minimum wage. And they were thinking, so hang on, if we look at restaurants, and we look at restaurants in Pennsylvania, and we look at restaurants in New Jersey, they're quite similar. So maybe it is such that if employment changes in New Jersey, and it doesn't in Pennsylvania for restaurants of a particular kind, maybe we can infer something from that. And they do some rigorous statistical work on that, and they are able to make a convincing argument that in fact you can say something about causality in this case. And that's really interesting. If that is more broadly applicable, that means that under certain circumstances you can make a statement that has to do with causality, even though the data set was made for an entirely different purpose. And that professor I mentioned from university, he was wrong. He shouldn't have sent you back. He shouldn't have failed you at your course, at least under certain very constrained circumstances. Somebody might then argue that, but hang on, with a randomized control trial, you need something randomized. You're not doing anything randomized. You're just picking restaurants across the border in Pennsylvania. So no. This is not good enough for the gold standard. It might be that you can make some statements and some hypotheses, but it's not statistically rigorous enough. It's not good enough. Which brings us to the Nobel Prize of Economics in 2019, because I suspect that this work paves the way for that work in 2021. In 19, these guys, they're not working on restaurants at all. They're working in development work. And they're basically sort of having a fight over the applicability and validity of RCTs, the randomized controlled trials, the gold standard for how to make causal inference. It's good for lots of stuff. It's still the gold standard. But it's important to know, and which then this Nobel Prize work sort of makes very explicit, that under lots of circumstances, the RCT is not necessarily the best tool you got. One thing is that, like, if I were part of that experiment and I eat that pill and I get less headache, and the researchers are concluding that with great confidence, it is such that if you eat this pill, you get less headache. I might ask, so does it help with shoulder pain, knee pain? The trouble is that the RCT, the gold standard for making causal inference, doesn't help you with that at all. So the internal validity, the experiment was made for revealing whether you get less headache. It's excellent. The external validity, an analogous reasoning over in a similar domain, nah, you haven't got too much help there. So that's a problem. Another problem is sample size, in the sense that when we were in Pennsylvania, that was on a societal level. You can't run a randomized controlled trial, having a rigorous approach to how all those people and all those geographical areas behave, and that there aren't confounders, spurious things that happen somewhere. So under many circumstances, it's not really it's not a practical thing to do an RCT. So what do you do then? There are alternatives. You can be the anthropologist. You can sort of live with the natives. You can be among the restaurants in Pennsylvania. You can understand how the business goes. You can see how the manager works, whatever. And you can sort of, after a while, sort of get an understanding for the semantics of the field. And in that way, make possibly very valid causal statements that are not based on statistical methods. You could also have a model In physics, for example, if I'm sitting here and the light suddenly goes off and I go over to the fuse box and I see that the fuses are blown, statistically speaking, is it such that the fuse went and the light then went, or is it such that the light went and then the fuse went? For most of us, that's a ludicrous question. Of course, it is such that the fuse was blown and then the light went. That is because we have model knowledge. We know something about the domain where there are causal things. So this illustrates that there are a number of ways to causal inference that are not RCT based or are not gold standard based. And that opens the way for that perhaps we as data scientists can make valid statements about causality under certain circumstances, even though we're not following the gold standard. So to sum up, causality is usually, or not usually, but frequently, more interesting to a client or a customer or a business than correlation. Correlation, really easy to answer, but doesn't tell the customer equally much. Causality, really interesting, but very hard to get by. Okay. Work in economics implies newish tools. And I'm saying newish in the sense that, these guys get Nobel Prize in 2021. That's new. Yeah, it is. But having said that, as we'll see in a second, many of the methods here are not that new. And if you look down to the tools, the nuts and bolts of it, it's really old. There's nothing new there at all. It's only the way you apply those tools and the context for it that makes it possible to make causal statements. So then you might ask, so under what circumstances do they work then? And that's something we'll think a little bit about. Oops. Right. I might flatter myself with that when I was listening to who got the Nobel Prize of 2021, it was such that, I realized that, in fact, this is a very general thing. It could be applicable across all kinds of fields, and it could be a tool for the scientists. And I think that was right. Unfortunately, I wasn't the first one realizing that. There is quite a lot of literature, papers, theories, tools, GitHub things that are out there that can supply a data scientist with a toolbox for making causal inference. Okay, so why am I having this talk then, if it's all old stuff? Well, it isn't that old. The Nobel Prize came in 2021. And if you look at these tools, as I've listed out here, this little menu, and if you look at where they come from and when they were developed and things like that, quite a number of them are fairly new, as in last 5 years. And some of them, as in the one we're going to look at a bit more in detail, is a very active field. So you might be forgiven for possibly not having heard about this, and that it, in that sense, is newish, I guess. So in this menu, lots of overlapping methods, related methods. We'll have a look at what is called synthetic controls. And synthetic controls. The key idea here is that if we go back to that randomized control trial, we have a control group. Those guys who get the pill that are with the placebo. And then we have the group that actually gets the pill with the active ingredient. And the synthetic control is basically, in some way, conjuring up that control group, bypassing those stringent requirements that the RCTs are demanding. And what we're generally going to do is that we're going to take a data set and we're going to, for example, the restaurants in Pennsylvania, New Jersey, and then we'll say all the restaurants in New Jersey and Pennsylvania before that minimum wage policy came into place. We'll take all those and we say they constitute a kind of sort of common basis for normal behavior as if that policy didn't come along, right? The problem with that is that those restaurants are not chosen randomly. They are definitely not random. They are very much there, very dependably there. So that's an issue. And then synthetic controls as a discipline, as a theory, basically says that, okay, but if we take those samples in some kind of multidimensional domain and we build a regression model based on those samples, then that regression model will kind of smooth out the rough edges and make it such that sort of, all those confounders, all those things that spuriously could have affected whether employment went up or down, is kind of sort of smoothed out across the board, across all the restaurants. So that's how we sort of make it similar to random. It's good enough for random. And here is where that 2019 Nobel Prize comes in once again, that the gold standard itself has, it isn't entirely a polished thing. There are weaknesses and problems with that as well, because there are cracks. Okay, fine. Then it might be that we could also accept other ways of arguing causality that also have cracks that are good enough. And synthetic controls, among other methods, as this Nobel Prize from 2021 might suffice if you want to. So we're going to build a regression model based on all the samples we have before whatever effect comes into place. And then we sort of go forward the tape to after the effect comes into place. And then, the restaurants in New Jersey, they will then after a while we know the correct answer, whether an employment in New Jersey went up or down for those restaurants, whatever, right? Pardon me. And then we can ask that regression model, what do you think would happen 2 years after that policy came into place? Because it doesn't know anything about the policy. How would the normal behavior, the control group, how would they be? And then you can compare the differences, and that you could do in a statistical way. So that's generally the method. There are a couple of things you need to think about and sort of have control over. One thing is, of course, if you're including restaurants in Pennsylvania, you need to make sure that restaurants in Pennsylvania are not under a minimum wage before or slightly after, or similar kind of effects, right? So the untreated must be untreated. You need in general to think about confounders as in things that in general comes from outside and either influence the independent variable or the dependent variable, either influences whether there was something that influenced wages or something that influenced employment, and you need to correct for that. And there's this thing about the treatment needs to be abrupt, it needs to be at an event. It can't be something really gradual or something. It needs to be on an aggregated level. So this is kind of sort of, my example from the Nobel Prize was on a societal level. So you can't work on instances. You need to work on sort of, an aggregate if you want to. And the effect must be significant in the sense that, these are statistical things. So if that effect, the unemployment, for example, if it is so little that it just drowns in noise, well, then you don't have much to work on. And you need to have enough data points, and that is in some contrast to that it is on an aggregated level. Usually aggregation also collapses the size of your sample space, right? Right, so I'm then going to switch over to something a bit more code-like. Google has something called Vertex AI, which is kind of sort of, the collected AI services of the Google Cloud Platform. Presently, lots of fun stuff there. One of the things they have is a workbench, and inside that workbench there are a couple of Jupyter Notebook offerings. Very plain fare, very standard things in general. You could either spin up your own notebook on a VM and you have control over images and dependencies and whatnot, or you could run a managed notebook, which is basically, no surprise, that you don't deal with the underlying hardware and infrastructure and all that stuff. You just press a button and it works. That offering is less mature, so there are a couple of sort of enterprise features that are not there yet. I'm sure they will come. But it has this is a sidetrack maybe, but it has some quite fun other things. For example, there is this thing that when you do Python development and you do it in a notebook, you're very much in sort of an exploratory setting. The strong suit of notebooks is that you can share things, you can show your colleagues, you can collaborate, things like that. The not so strong side of a Jupyter notebook is taking whatever you've built and put it into production or put it into a pipeline or making sort of making it a repeated thing or whatever. And there is a new button in the Vertex AI in preview, where you can take a notebook like this and just collapse it as kind of an artifact, as an executable artifact, and then you can run that as an executable artifact, as a script if you want to later, and you can schedule it, things like that. Yeah, it sort of ties in with an MLOps, kind of as in machine learning operations kind of sketch, I guess. Maybe it isn't entirely, the paint isn't entirely dried, but it's something that's worth looking at. Anyway, let's go back to the notebook. I'll jump out of here and I'll go over here. So for those of you who haven't seen a notebook before, I hope the fonts are not too unreasonable here. We're not going to look very much at this anyway. Lots of code, cells, you can execute them, things like that. What we are going to look at, hang on, I didn't do that. I should do that. Hang on. Yeah, I should talk about that first. Sorry, unstructured. Bear with me. Right. So we're going to look at a data set which has to do with traffic data, traffic accidents from Britain. For those of you who are data scientists, I'm sure that's a fairly familiar thing. Very large data set, publicly available, 750 megabytes of lots of time series and categorical data. And if you want to try out things and wonder whether a method works or whatever, a great place to be. And we're going to say that in 2010, due to lots of public complaints, speed bumps are removed from roads with speed limit 20 miles per hour. So that's our event. That's the pill being eaten. That's kind of, the minimum wage that comes along. And crucially, that means that for 30 miles per hour, 40 miles per hour, 50 miles per hour, there is no removal of roadblocks. Entirely fictitious in the sense that, in fact, no roadblocks were removed, or road bumps were removed. It doesn't really matter. It's just an illustrative example. It sort of fulfills some requirements. It's an event. It only affects a slice of the data. And it can be expected to have an aggregated significant impact. If you removed all speed bumps all across the country for 20 miles per hour, you could expect there to be some kind of event that shows up if you want to. Then we'll go back here. Sorry about that. No, we'll go back here. So top graph, I hope you can at least roughly see this. God knows how the resolution is. Are basically from 2005 to 2017 traffic accidents where police attended, easy to register. And you can see that it goes down. That's nice. And you can see that for 40 miles per hour, the big bulk of traffic accidents are. So we need to normalize this data, because if we're going to build a regression model, then it needs to be normalized. Such that here is a normalized version. We've sort of centered around the mean. We've removed some variance, things like that. Then it looks like this. Blah, 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 lots of code. And here, top graph, exactly the same. We put in a dotted line. That's where the event comes in. Middle graph, that's just the zoom out. And here, as I said, is the basis for the regression model. We'll do regression based from 2005 until 2010 across all speed limits, including the one that is subject to the treatment. And then we will, after 2010, for that bottom graph, ask the regression model, how do you think traffic accidents will develop for 40 miles per hour, for 50 miles per hour, and for 20 miles per hour? And then we know the actual numbers, and this graph plots the difference. And you can see that the regression model generally says that for all of the speed limits than 20, the ones where we remove the speed bumps, the behavior is similar. And in fact, the regression model is a bit pessimistic. It actually went better, less traffic accidents than the regression model predicted. Whereas for 20 miles per hour, it went worse. More traffic accidents, presumably then, because of the removal of those speed bumps. And we can make that causal argument because there was a synthetic model, that randomized controlled group, if you want to, that we employed for this purpose. Good enough compared to what the RCTs could have given us. And we can then make statistical arguments based on that. We can do a direct Fisher method, or we could do a correlation matrix where we can show that all the other speed limits than 20 are behaving in a particular way, and 20 miles per hour is after the treatment an outlier, significantly differing from the other ones. That's all there is to it, really. And if you now also say, what? Am I listening to a guy who's showing me how to make a regression model? Yep, you are. You are certainly listening to a guy who's showing you how to build a regression model. But the important thing is that the regression model is put into a context and used under certain assumptions that make us able to make a causal argument. A multiplication sign can be used for calculating quantum field behavior and also how much you owe your buddies at the restaurant. So that multiplication sign can be used for all kinds of purposes, and regression model likewise. It all depends on the circumstances and the assumptions. And just to wrap it up, you need to then, of course, think about those questions we had in the beginning, those assumptions. Are we sure that nothing else happened that had a similar impact? Were, in fact, only the 20 miles per hour speed bumps removed? Or was it such that, when they did the work, they did just a neighborhood and they removed all the speed bumps for 30 and 15 and 10 as well? And removing speed bumps nationwide doesn't take 5 minutes, does it? I mean, have they finished? Did it take a year to do? Things like that, which will then sort of collapse your entire argument. I'll leave you with this quote that sort of ties in with the Nobel Prizes for 2021 and 2019. The synthetic control approach is arguably the most important innovation in policy evaluation literature in the last 15 years. So a method worth looking at for those of you who are data scientists and frequently are asked about causal questions, why questions, when in fact, you can only say things about coincidence. Thanks a lot. I'm open for questions to the extent there are any, and I wish you all a nice afternoon.
Yes, thank you, Morten, for the great presentation on artificial intelligence. Yes, since we are a bit running short of time, so we would encourage attendees to ask questions on the chat in the chat window, so that we can respond accordingly in the chat window too.
That would be great.
Yes.
No question is too difficult.
There's 2 questions there at the moment. Yeah, the first one: have you seen any real-life applications of the concept of synthetic control in real-life AI ML models? This is from Rustam.
Hi, Rustam. Great question. And you're arresting me on a particular point here. Why aren't you mentioning any cases? Why is this such an artificial data set? That's fine. I was just playing around with it. I was curious. No, with our consultancy in Computus, I haven't seen that we've used synthetic controls. Are there any real-wise applications? Yes, lots of them. As I said, there is at least 5 years of engineering out there. Lots of methods, and you will find lots of real-life applications of this out there.
Yes, great. The next one is from Vi Hop. Can Vertex AI be also used to analyze models with indirect effects, a la structural equation modeling, SEM? Is Morten offline? Oopsie. I can see that Morten is offline for some reasons. So I would invite Rustam back to the stage as the next host.
And we're back. So we are back here. We are back with Guillaume, and we'll be talking about, well, not we, but you will be talking about security and cloud and everything. So I'll be in the background listening in, and I will be collecting all the questions. So if you have any questions, feel free to ask them, put them in the chat, and I will be back after you're done. And we can talk about the questions and comments and stuff that shows up in in the chat window and the YouTube stream. So without any further ado, I think it's time to leave the stage for you. So, the mic is yours. Take over, present your screen.
Yeah, I think it's okay. You can see my screen and we can start. So, hi everyone. I'm very happy to be here with you to talk about security and serverless because it's a too trendy product and solution in 2022. First of all, I'm Guillaume Blaquer. I'm Google Developer Expert on the cloud, and I'm also a cloud architect at Accenture. But before going into detail of the serverless and security, I just would like to share with you the same definition of serverless. What's serverless? Serverless, in fact, it's an operational model. That means you don't have to manage infrastructure, security, network, firewalls. All this stuff are managed for you by the cloud provider. Of course, you have to trust the cloud provider, but all these boring things are not up to you. It's you need to focus your effort and your developments on the programming model and on your services, your microservices, because it's also a trend to develop with microservices. And these services has a specificity, they need to be stateless. Stateless, that means you can't persist data inside the service. You can create a service that connect other services like database, file storage, blob storage, or whatever you want outside your serverless service, but the service itself must be stateless. Why? Because it allows you to scale up and to scale down very quickly and easily, and especially because you can scale to zero. That means you have zero instance deploy at a point of time. If you have no traffic, you have no instance, and you don't pay when you have no traffic. And that's why it's a pay-as-you-use model and very interesting to optimize your cost and your agility. Sometimes you have also models that it's managed, it's not serverless. A managed service is a service that you pay even if you don't use it. For example, on Google Cloud, you have a Cloud SQL, you have an instance of the database, MySQL, Postgres, or Microsoft SQL Server that you create and you pay even if you have no request on the service. It's managed for you, but it's not pay as you use. So in this big family of serverless, because serverless on Google Cloud, you have a lot of products. You have analytics with BigQuery, you have messaging with PubSub, you have Vertex AI and Workbench for managed notebook, just seen before. And the focus here is on the serverless compute. Serverless compute is products where you can run your code that you then develop. You have Cloud Function. When you develop only a single piece of code, it's a function, in fact. You have App Engine. It's more complex. In fact, it's a web server, but you deploy also your code. You deploy a Flask server, for example, in Python, or Spring Boot application in Java. You deploy your code and it's deployed on App Engine. And finally, you have Cloud Run. And Cloud Run, it's a container. In fact, you package your web server inside the container and you deploy your container on Cloud Run. All these products scale to zero and scale according with your traffic and the requirement of your traffic and activity. So now, why talking about security? We are talking about security because serverless is a new paradigm. As I said, you don't manage the servers, you don't manage the network, you don't manage the IPs, you manage not the infrastructure. And it could be disturbing for companies that would like to use serverless, but they are lost to enforce their legacy security pattern that work very well with infrastructure, VMs, and so on. But in serverless, it's more difficult, and it's the purpose of this talk. In fact, the teams want to ensure the same level of security and enforce the same best practices, manage the network, enforce their legacy policies, such as having static outgoing IP, serving only internal traffic. They don't want to expose publicly some URLs, some IPs, and to stay only hidden from the external internet, from the public internet, want to deploy TLS certificates to encrypt the traffic and to use custom domain to customize the endpoints, have high availability for business continuity, to control who can access to the service and how the service can access to other components, other services on GCP, and how to mitigate the external threat like DDoS attack, like code injection and stuff like that. The last point, and it's very trendy and very popular for now, it's the software supply chain that could be also critical points for the security team. So let's jump in all this topic, and I hope I will provide you some detail to mitigate and to enforce some best practices and best pattern on Google Cloud and serverless products. First of all, we'll talk about patch. So when we talk about patching, we need to patch the VM to stay up to date because your Linux VM has CVE. With serverless, you don't have VMs, and of course, the patch management is easy because no VM, nothing to patch. Okay, that's finished. But in fact, not. Why? Because when you deploy something on Cloud Function or on App Engine, you deploy something with no server to manage, but you deploy your code, and your code also includes dependencies. And you can have security issues in your code and in the dependencies, and you need to patch, to update, patch your code or update the dependencies to fix some security issues that you can have in the dependencies. And when you talk about Cloud Run and the container, a container, okay, you deploy your code and the dependencies inside the container, but you also use a base image. Most of the time based on Linux and Linux distribution, you can have some issues in this base image. You can install system libraries, and these libraries can have some issues also. So you also need to patch and to update the whole container, the base image, the system libraries, your code, and the dependencies. And you still need to continue to patch the things. It's not at the infrastructure layer, but it's at code layer, and to continue to do this job. One of the best practices is to perform weekly, for example, a weekly build with the latest version of the dependencies and the system libraries, and to run the integration test, the unitary test. And if all is green, you can deploy the new version with the latest version of all dependencies and libraries. It's a way to be sure to be always up to date. Then, when you have a serverless product is deployed somewhere on the serverless world managed by Google, you don't know exactly who, on which network, on which VPC, but you need to communicate with services inside your project, inside your VPC. And because it's your network, it's your private network, you need to communicate with private IP between this serverless world and your project. Same things if you have an external platform, on-prem environment, or another cloud provider, and you connect this platform with a VPN or a cloud interconnect. You need to use a private IP because you don't want to reach publicly this external platform, and you need to route your traffic and to use private IP to use the VPN or interconnect. But because you don't manage the network and you don't manage the IPs, public or private, it's difficult. And the solution on Google Cloud is an important product named Serverless VPC Connector. In fact, it's simply a bridge between the serverless world and your VPC, and the traffic is routed from the serverless world to your VPC, and you have a private IP inside your VPC. Then you can route your traffic to your project and to your resources in your project, Compute Engine, GKE, Memory Store, File Store, and all the private resources that you have inside your project. But you can also route your traffic through a VPN or an interconnect to reach an external platform with a private IP. And like that, even if your world is not, the serverless world is managed by you with IPs managed by you, you can achieve the security and to use a private IP like that. Another situation, another use case is to use static IP. Why? Previously in my company, we used a FTP server on-prem and we trust a login, a password, and a requester IP. And when we use a serverless product, we don't manage the IPs again. And when a request is initiated from the serverless product to the internet, you use any Google IPs used for that to go to the internet. That means if you and I use the same service, we can use the same IP to go to the internet. And so you can't trust this IP because it's not your IP. It could be also my IP. It's random. To solve that, again, you can use a serverless VPC connector. Why this time you route the traffic to the serverless VPC connector and you use a cloud router and a cloud NAT. And on this cloud NAT, you will reserve one IP, one public IP reserved for you, usable only by you and by your services. And so you can trust this IP. And so because you can trust this IP, you can allow it on your external platform and the service that check the source, the requester IP, and like that, you have solved your issue. A point when you talk about internet and public exposure, because by default, Cloud Function, App Engine, and Cloud Run are publicly accessible when you deploy them. It's by default. You have to ensure the encryption of the data. And for that, you can use a TLS certificate. It's a best practice, it's a non-practice today on the internet. And in fact, you have nothing to do because natively your traffic is served in HTTPS and use a wildcard certificate managed by Google Cloud, and you have nothing to do out of the box. It's like that. Of course, you can use a load balancer, use your domain name, use your certificate if you want to customize the endpoint name. But if not, by design, you use TLS certificate managed by Google Cloud. However, even if the services are public by default, maybe you don't want. You don't want because you can have service only for internal purpose, because it's internal batches, you process sensitive data, or simply because you want to reduce the attack surface, you don't want to expose publicly your services. But by default, the service, when you deploy them, are publicly exposed, and you can't change that by default. By design, always your service, Cloud Run, App Engine, and Cloud Function are publicly exposed to the internet. But you can limit the access with a parameter and a feature. So this feature works only with Cloud Function and Cloud Run, not yet with App Engine. With App Engine, you have firewall rules, but it's not exactly the same. Here, the context is for Cloud Function and Cloud Run. In fact, you can say on the Cloud Function or Cloud Run, you can say the ingress, you can set it to internal. That means the service is still viewable from the internet, except that you have an additional check performed by Google Cloud before routing the traffic to your service that say only the internal traffic coming from your VPC, your VPC is allowed to reach the serverless product. That's great, but if you want to reach, for example, a Cloud Function from a Cloud Run and your Cloud Function is ingress internal, how you do? You can do that with a serverless VPC connector, again, to route all your traffic from Cloud Run to your VPC. And because you are in your VPC, you can reach the serverless product with ingress internal configuration. Of course, you have also other resources inside your VPC, like Compute Engine or Kubernetes Engine that are by default in your VPC and can reach automatically your services in ingress internal mode. But you have services only internal, but sometimes you don't want that. Oh, I forgot something. Of course, if you have also an external platform, you can reach privately with a private IP, with a VPN or a cloud interconnect your VPC. You can perform a peering. And because your request goes through your VPC, you can also reach your serverless product. That's great, but that means only internal traffic and only traffic that you manage, because it comes from a network that you manage, can reach your VPC, your serverless product. And it's not perfect because sometimes you want to expose publicly your service, but you don't want that the requester access directly to the cloud function. So you can say only the traffic coming from my VPC and coming from cloud load balancing can access to my serverless product. So you can set the ingress internal and cloud load balancing. And like that, you can expose a load balancer and allow public traffic to access to your load balancer, but never the public traffic can reach directly the cloud function or the cloud run service without going through your load balancer. And we'll see that on the load balancer, you can add additional check and additional layer to protect your services. So now let's talk about high availability. High availability is a requirement for more and more applications to be sure to be always uptime. And if you have the habit to deploy some services on Google Cloud, as in Cloud Function, Cloud Run, or App Engine, you can remark that you never mention the zone. You always mention the region, never the zone. Why? Because by default, by design, when you deploy a Cloud Function, App Engine, or Cloud Run, it's natively regional high available, and you don't have nothing to do for that. It's out of the box. And by default, it's okay for you. But you can go to the next step and to be globally high available. And for that, you need to use a load balancer and to use a unicast IP. That means an IP that can be reached from any part in the world and routed quickly to the Google Cloud network. And behind a load balancer, you can deploy different backends like Cloud Run, Cloud Function, App Engine. And something that's great with this load balancer, that's two things. The first one is the latency. It routes the traffic to the closest location from the closest location from the users. That means if you are in Australia, you will go to the Cloud Run instance in Australia and not go in Europe or in the US. Except if you choose to delete the Australia region, or if you have a massive outage in Australia, a tsunami, for example, and the Australia region is not accessible, the traffic is automatically routed to the closest location from Australia. I don't know if it's the California or the Europe, but that's fine. Automatically, the load balancer does the job for you, and you are easily globally high available. In addition, I repeat that when you deploy your Cloud Run services, App Engine, or Cloud Function, you pay as you use. That means you can deploy Cloud Run, Cloud Function on any region in the world. And if the services deployed, for example, in Asia are never used because you have no customer, no user in Asia, no problem. You won't pay more. You will pay only for the services, the region that is used really by the users. And so by default, you can deploy in the 24 region of Google Cloud. No problem. It's not an additional cost for you. So now we'll talk about permission and access. And you have services in Google Cloud. You have a Cloud Function, App Engine, and Cloud Run, and you want to access to Google Cloud resources. For example, BigQuery, PubSub, KMS, or other services. And you need to authorize the service to access to a BigQuery dataset or to PubSub topic or subscription, and so on. For that, you can use the IAM, Identity Access Management service, to grant role on a default service account. In fact, on each service that you deploy, by default, you have a default service account when you deploy your service. That means if you have two Cloud Run services, both will use the default service account. The problem with that is if you have two services with Cloud Run, one use BigQuery, the second one use PubSub. That means you will need to grant the two roles on the same default service accounts to allow the two Cloud Run services to access to the service. But one service will be granted to access to PubSub and it doesn't care, and the other one will be able to access to BigQuery and it doesn't care. And so you don't enforce the least privilege principle, and it's not perfect. To solve that, you can use a custom service account. That means you create a service account by yourself and you add this service account on the service that you deploy. And like that, you have a Cloud Run service with a custom service account that can access only to BigQuery and the other that can access only to PubSub. And like that, you have enforced the least privilege principle. And in addition, you know who, I mean the identity, the service account identity has access to a resource in your project, and the traceability is better because you know who use or which product use that service account, and the debug is easier. The way around is how to control who can access to your service. Cloud Run, Cloud Function, and App Engine is very, very, very similar. It's named EAP, Identity Aware Proxy. It's not a Google frontend, but it's very, very similar. In fact, in front of any Google services, you have a Google frontend that filter the bad traffic, the layer 3 and the layer 4 bad traffic, partial IP, and all the garbage traffic. And I said in front of any Google services. That means this layer is the same for YouTube, Gmail, App Store, and other Google services that you can use also. For that, you can configure Google Frontend and say, hey, Google Frontend, Google Frontend, perform no filtering, allow all the traffic to access to my services. Okay, all the traffic pass through Google Frontend, and there is no check on the authentication or on the authorization. But you can also say, hey, my service is private, and you have to check the authorization header. And a check is performed by Google Frontend and allow only the traffic authenticated and authorized. That means is the header is present, is the header is valid, is the authorization, is the user is authorized to access to the service. If yes, you can the traffic is forwarded to your service. If not, the service is discarded automatically by Google Frontend. That means if you have a DDoS attack with a lot of bad traffic or a lot of unauthorized, unauthenticated traffic, all this bad traffic is discarded automatically by Google Frontend, and you will pay only for the good traffic. And all the bad traffic is discarded by Google, and you pay nothing for that. And it's a great protection, a great first protection against DDoS. So, and yes, to the authorization header, in fact, it's a OAuth token with cryptography mechanisms. It's a short life duration, 1 hour max, and it's a standard today in the web to use it. So that's great, but sometimes you want to have a public access to don't filter the user on their identity, but you want to protect your services against threat, DDoS, and code injection. For that, you can use a HTTP load balancer in front of your services, as I presented in the global high availability section. And you can activate a feature named Cloud Armor. Cloud Armor, it's a web application firewall. That means it's a firewall that filters the traffic at the layer 7, the HTTP layer, in fact, and you can mitigate. You have automatic and predefined rules to mitigate the top 10 OWASP issues. And you have also a tier, a flat rate tier, a Managed Protection Plus. Why? Because when you set up a Cloud Armor, you pay according to the traffic that you process. And in case of attack, you have a lot of traffic. And to protect also your money, your services, but also your money, you can subscribe a flat rate. And even if you have an attack, you won't pay more. It's a flat rate that you pay with Managed Protection Plus. The last section is the software supply chain. And before going deeper, I would like to explain what is it. In fact, when you develop your application, you have a team that develop and push their code on a repo and a CI/CD pipeline, for example, on Cloud Build, run, and create an artifact and store an artifact on artifact registry. Then you can have also Cloud Build or another continuous deployment tool that deploy your container on Cloud Run or on Kubernetes Engine, for example. So Kubernetes Engine is not important because it's not serverless, but for Cloud Run, it makes sense. The problem here is if you have a bad actor or an unauthorized user, it could be a member of the development team that would like to perform a quick fix on an issue and build the container on his own environment and not on a Cloud Build environment. He can add some issues, some bad libraries, some trackers, some backdoors and stuff not very cool and not very fun in your service. And you can deploy this bad service, not validated, not checked with your security step in the Cloud Build. And you can deploy bad things in production. And to prevent that, you can add binary authorization to check automatically the source of the container. That means you trust artifact registry, great, you can deploy on Cloud Run or Kubernetes Engine. If it's not come artifact registry, you can't, and you protect your the source of the build and the source of your code. I won't go again this part. It's only some feature on the supply chain software supply chain. Just a word about Cloud Function and App Engine. In fact, you also use Cloud Build. You also build a container behind the scene with Buildpack. But because it's fully managed by Google Cloud, the build and the deployment, you don't need this feature because you can't inject external container to Cloud Function or to App Engine because the containers are built natively, automatically by Google Cloud before the deployment. That's why only Cloud Run is concerned by this feature and not Cloud Function and App Engine. A final word to say to you that security is very important. If you start to use it from the beginning, it's not more expensive. And I'm sure all of you have in mind a company that have a clear future because the product was very good, but a security issue stops the business, even stops the company. Personally, I have in mind Zoom with a great ramp up with the COVID-19 and the remote work and so on. And because of security issue, their ramp up has been stopped, and the business is not as good as they could be. It could be. So think the security from the beginning is not so expensive. It's not more expensive, and it can save you and your business. So I'm 1 minute past the delay. If you want to contact me, don't hesitate to send me an email or send me a message on Twitter. I will be happy to answer your question after because I don't have the time now to answer you. Thank you very, very much for your attention.
Thank you very much. Thanks for a great talk. And I was just sitting here and thinking, like, what questions do I want to ask? What things that we were, but everything was so clear. So it was kind of hard to come up with questions. I actually managed to come up with one, and it's a quick question, so I think we can do it now live. What if people want to do some kind of a mix of like multi-cloud, hybrid cloud kind of solutions? Will many of those things that you explained, how will that work? I mean, what's the kind of starting point if you have a hybrid cloud, say?
Yeah, so I'm not so expert for hybrid cloud and infrastructure. In fact, I know some products exist, but you can't use a dedicated cloud solution. You need to have a multi-cloud solution.
Yeah,
I know that
Anthos,
Google,
probably, yeah.
Yeah, like Anthos, and I know that Google has solutions, but I'm not multi-cloud. I'm very focused on Google Cloud. I'm sorry, I can't answer your question.
No
I will
worries.
say anything though. So.
Well, that's good. I think that's a good answer as well. But I think that's a very good point as well. Like, use something that supports multi-cloud. So probably Anthos will be a good start, or endpoints and stuff like that, and you'll get a lot of things out of the box as well. Oh, there is a question. So there is a question from Vaibhav. Could you use Cloud Armor with App Engine using custom domain?
In fact, not, because when you use custom domain, you don't use a load balancer, and you can use Cloud Armor only with a load balancer. So in fact, you have to define a load balancer to add or to register your load balancer in your domain and to use your certificate with your domain, and then to use App Engine. But you need to have a load balancer, and to pay a load balancer, I think it's $20 per month. But you need a load balancer to use Cloud Armor.
All right, thanks. Yeah, I think I don't see any other questions coming in, so I think we'll encourage everyone, kind of move the discussion to chat. I mean, there is still chat. Our chat is open, so write them there, and hopefully we can try to route it to you, or get hold of you somehow, or do it on Twitter as well. So again, thank you very much for being with us. Thank you for doing this talk. It's been very, very, really fun. Thank you very much.
Thank you. Goodbye.
Bye. Martin, yet another. Oh, echo. All right. Yet another fellow GD. Great to see you here. So welcome to Devfest Norway. I'll leave the stage for you in a very, very, very short second. So I'll just, yet again, reminder, write your questions in the chat. We'll be asking them, Martin, when he's done. So take it away.
Hello. Actually, I'm very happy to actually be here and present to this audience. And the time is short, and I prepared some live demo as well. Hopefully they will work as well. So I will start my presentation, and we will go along with it. So we are talking today about cloud workflows, and especially we are focusing on the new features that were recently added to the cloud workflow system. We will see how to automate services, and not only the cloud, so everything which is possible to automate by, let's say, HTTP and so on. So about me, I'm Martin, I'm Hungarian, living in Romania. I answer a lot of questions on Stack Overflow. My day job includes running backend, scalable system, and my favorite products are, let's say, BigQuery, Redis, these kind of systems. You can find me on Twitter, you can find me under Pentium 10 name on Stack Overflow and GitHub, and slides will be available on SlideShare. Whatever question you have, use the chat, use the Twitter, and we will hopefully be able to answer it. Our agenda today includes walking talking about cloud workflows, which is, let's say, a recent but not so recent addition to the cloud. But there has been new features added to the product, and we will cover what those mean in real life, and we will see examples of those. So let's see. Cloud workflows. When we talk about workflows, in the nature of the word, it does a lot of things. So it can orchestrate any API, it connects steps, it does internal to your cloud, external to your cloud, internal to your infrastructure where you have servers, or internal also to the APIs where you have Google APIs, you could have your services and so on. So in a nutshell, it sits on top of all the, let's say, servers and serverless or platform as an application system, or in the top of all the APIs and other APIs as well. And here it could be any SaaS API like SendGrid or Bitly shortener. It could be your private API, or it could be other cloud as well. So essentially, it's an orchestration service on top of the services. In a bulletproof and in a bullet list, we could see what it's offering. I need to mention that it's a serverless HTTP service automation. So it means serverless. It means that you don't need to provision infrastructure. You just set up your code, which could be in YAML and JSON, and you actually set up on Google Cloud infrastructure. So it has a price component because it's a managed service. It's not expensive at all. You have for $1 100,000 steps and so on. And it lets you to do fantastic things on this workflow engine. And I would say that this is mostly developer conference. So let's focus on the developer side of it and application wide, what can be built out of it. And of course, this is a GDG conference with a Devfest, so it's much more related to Google Cloud products, but I will showcase also external APIs as well. What I like about Google Cloud Workflows is that it integrates with any Google Cloud product without worrying about any authentication. So that's really helpful. With just 8-10 lines of code, you are able to actually call a service which is part of the Google Cloud as well. So let's see samples, because people want to see samples. In a nutshell, let's say the basic automation is having a scheduler, could be a cloud scheduler, for example, a 9 a.m. trigger, and do what? These are just simple steps. Start a compute engine VM, start an instance, eventually do a wait on this operation, have a condition, and in case there is a failure, notify the team. So that could be just a basic workflow where you have systems that call the API of a compute engine VM. It has a wait functionality. It has a condition to analyze, and it also has access to the log system and access to the notify system, which could be an external API like a Slack channel, whatever it is. So this could be just a basic example. But application-wise, it could be that receiving an order could trigger a workflow, and the invoice generation could be part of a workflow. So creating an invoice could be a step, and that could be, for example, engineering an app engine route that's part of your application. Or it could be other service as well. This is just a basic example. It could generate a PDF, for example, using a Cloud Run service, because your application is polyglot, so you deploy the PDF generation in another language as a service. Then it sends the PDF via email using Cloud Run together with SendGrid as well. So this could be a workflow execution and can actually do step orchestration. Now, this is visually how it works, but let's see code samples. And here we don't need to talk about workflow basics. Workflow basics essentially for developers are steps, are anything which is a call or a request. It could be HTTP call, sequencing 2 steps or sequencing multiple steps for it, working with sub workflows, which means that you write, let's say, sub-functions, but they are called sub-workflows. You use the internet to locate sub-workflows because it's full with recipes out there. And the nutshell is that the goal is that you need to connect anything on cloud or external service. So these are the workflow basics, and let's see now examples. And I'm actually going to switch to my IDE in order to show you some direct examples there. So this is my VS Code. And for example, here is a basic workflow where it has two steps. It reads Wikipedia and it returns a result. So what you see here is that it runs a HTTP GET service, it has the URL, and it has the query parameter. And now I need to run this example. VS Code lets you to actually set up quick pens. And here in task.json, I actually set up the commands that let you to actually deploy a workflow or execute a workflow or describe last. This is a fragment command which I use to actually describe my last executions. And I'm able to see in the status bar that I'm on a current project. How this is working? It works because actually there is a GCP project switcher extension. And it happens that I'm the author of the project, so I'm featuring this to you as well. You can add to the VS Code, and you are able to actually see the current GCP project in the status bar. You can switch it, and it's a nice addition to your developer experience. Now, let's get to the basic workflow. So I need to deploy it. Right now, I'm using the task pane actually to launch this command, which is gcloud workflows deploy command. So this workflow deployed. Now I need to execute it. By executing it, I will get the execution ID. The execution ID is here. And I could, for example, get this command to actually see how the execution went. So if I put this in a new terminal, then I will be able to get the execution of that particular workflow, how it went. And what you see here is that from Wikipedia, I got some keywords about Norway or anything else that I want to search. Now, if I change this, for example, Tesla, and I want to do all the flow, I set up a workflow run event, which has also the deploy, it has also the execution. It describes the last execution, so it will automatically do all the stuff for us. What you need to observe that the results are in here, but actually this was very fast. So it was a couple of seconds. We didn't have to wait for infrastructure to be provisioned, to be deployed. Executions are immediate. And as the result is obtained, you are able to see it as well. Results can be strings, JSON, whatever it can be. So this is just a basic example of running a get statement. Now, you may wonder how to run a post statement. Let me show you that as well. So here you have a link shortener, and the link shortener is bit.ly. The long link is one of the Google Cloud blog pages. And here you have in the headers the API key in order to use the bit.ly service. You need to observe that the bit.ly service is outside of the Google Cloud. Essentially, this workflow is just shortening the link as well. But it's more to it. This is a bad example because the API key is in line. And next is actually obtaining the API key from Secret Manager. Secret Manager is a service of Google Cloud. And here we have several steps in order to obtain the bit.ly API key from the Secret Manager. Essentially, after we have issued the API call, and this is the API call that needs to be issued, what you need to observe here is that the API call is obtained from the manual. So actually, I've go to the internet and looked for Secret Manager and how to read the API key, what is the request URL, and so on. Then you need to observe that the authentication is automatically handled because it's part of the Google Cloud Platform. So the invoker who invokes the workflow is set up to access Secret Manager and is set up to access this key. And once that key is being obtained, it's being decoded, and the decoded thing is actually part of this system. So it's not inline into the code and so on. So if I run this, you will see that it deploys immediately. It will do also the execution of it. And the third step is actually running the execution. So there is an issue here. I think the value provided is invalid. Yes, because I'm on a run project. Let's see on the workshop project. I am actually switching this to the workshop project now. And let's see how now the API key is going to be obtained from the secret manager. This is the example to actually using with secret manager, and there is one more to it. So we will see next in my slides that we are going to see the new features of Cloud Workflow. Now, essentially, you need to see that some workflows are part of your YAML definition. Here you have a workflow with parameters, and in the sequencing, in the steps, you are able to actually name the workflow, the sub-workflow, and the parameters to it. This is really helpful in order to reuse code or get codes from the recipes as well. And essentially, we got to what's new in workflows. What's new in workflows? So let's go and see. I prepared 6 chapters for it. So functions and string function, JSON function, iterating syntaxes are common things that developers love. Also, there is the map, the hash one, and now they support dynamic keys as well, which means that you can use a variable as the key definition. It comes really helpful. It lets you to actually use all kind of string operations to actually process a result, get a sequence from the results, and use that later in your application. Reading out a time fragment, parsing a file name, and communicating that to the next step in the engine. Resource limits have been increased to 256K. So workflow in a nutshell is a very compact application, and you could, for example, use up to 260 kilobytes of memory and application as and variables part of your application. So if you have, for example, a really large API call which handles more than 1 megabyte of data, it's not suitable yet for workflows, or it doesn't handle files. So this is the future only. Now, there is also capability to do scheduling also from the UI. This is a nice addition to the UI if you are using the UI of it. I need to show you in a nutshell what is the UI. So essentially, this is how you see one of your workflows. If I refresh it here, you should see the workflows which I deployed. These are the HTTP GET, Bitly secrets, and so on. And whenever you hit create, you are able to actually set here a scheduler, and it lets you quickly to actually use the scheduler of the Cloud Scheduler to trigger a workflow from the UI. Next is connectors, and this is a new section. As you see in my presentation, it's more developer friendly. So connectors are like libraries, and they are actually a shorter syntax, and they'll help you a lot with retries and long operation. You could have an API where you need to set up a job, you need to poll on the job, and you need to get the results of the job, but the connector will resolve it for you. Let's see in practice how are the connectors. So if I follow the next example, you need to observe here that I'm using a connector here, and that's part of the connector definition. What you see here is that it's a Google API. It's for Secret Manager, version 1, project, secrets, versions, and accessing the string of it. And that string is automatically decoded, that string. So the previous example where I had to know exactly the API URL, I had to decode it. It's actually compacted to this example. Let's see if this example runs smoothly, or it it will cause us issue, which I don't want to actually spend many things on it. So permission denied. Yes, secret managers. I need to revise my secret manager. I'm using 2 products here. Let's see. Well, maybe I will get luck. Again, I'm using many projects for presenting at conferences, and I didn't check this. Okay, so that's connectors. What you need to observe that it's a shorter syntax, and it will actually let you to do many things. Actually, I show you that before it's a long syntax, after it's a shorter syntax. What you also need to understand that it can have a timeout, the connector, and it can be up to 1 year, so it helps you to actually be very good for long-running workflows. And it has a blocks system for the workflow execution, so it's not using, let's say, resources, and it's not using any out of heap components and so on for this operation. It doesn't leak memory and so on. And I got a question at the previous conference that what operations can be used in the connector. So there is a manual for it. They are constantly adding products to it, but a few of it are here, like BigQuery, Cloud Build, Functions, Cloud SQL, Management Task here, Compute Engine, Dataflow, Firestore, Document AI, and Workflow itself as a service. So this list gets bigger and bigger, and it's really helpful that they compact the system operation for the connectors. Next is callback endpoints. And callback endpoints needs a context switch in your head, because these are async calls. So it enables async executions, like getting a signal from an outside application. Or you could do a workflow where you have a human in the loop. So a human sets a button or approves something, then the workflow will continue. Callback endpoints are an amazing feature as well. They are defined with 2 code sections. Essentially, you create a callback and you set the method of it, and you get here on the result of this call is a URL, and that URL needs to be pinged from the outside application, so the outside of your workflow. And there you have a await callbacks listener, also part of your callback, where the callback is coming back, and when this is actioned, the workflow will continue from that section as well. I put here a diagram of the anatomy of a cloud workflow. In a nutshell, when a workflow starts, it's in a running state. It will execute step 1, 2, 3, and so on, and it will succeed. This is the basic of a workflow. But for example, when there is an await callback section, the await callback section creates a listener, and it listens on an endpoint, which means that the event, when it happens, it will issue a HTTP call to that endpoint, and the workflow will resume, will continue. Essentially, and it will succeed. Workflows or the callbacks can time out as well. So, for example, you can do operation like I'm waiting for an event to happen in 1 hour, and if it doesn't happen, it times out. You can gracefully shut down your workflow or gracefully step further using the operations. And of course, failed exceptions can happen because developers make mistakes. Good. In a nutshell, callbacks are awaiting sleep, wait, or tracking tables. You are not required to actually do polling or while loops and so on. And it lets you to actually use webhook endpoint. The webhook endpoint is secured with authentication, so it's important that the application needs to authorize itself when it does the ping on the workflow. Next is something amazing, and that's in preview. It's Event Arc integration. And let's see what this is. So essentially, Event Arc is a service that connects logsings, collects events to any other Google Cloud product. Essentially, right now, it's available for Cloud Run, but you are able soon be able to run it for workflow as well. And this opens up what you can do with workflow, because any Google Cloud source which emits a log statement or emits an audit log or event is available to be set up as an observer, and the EventArc platform will trigger for that based on once delivery, either a service to Cloud Run, either a service to workflow. This opens up ways how you can use workflow to actually connect anything in the Google Cloud Platform. I mean, anything which emits to a log statement. Also, it will let you to actually set up a custom source when you publish to the PubSub. So essentially, you can have an application, or you can have a external to cloud system, an application publishing something to PubSub, and that will result in an event which is actually could be processed by a service of the Google Cloud. So I'm not saying this is hybrid cloud because it's not infrastructure wise, but you could, for example, have a system which is on premise or another cloud, and you push a message to the PubSub that's been picked up by EventArc and routed to Cloud Workflow and will trigger the workflow. So if you don't have a workflow engine, you are able to actually look and work out based on Cloud Workflow. Now, in a nutshell, these are the changes and the newest addition to the workflow service. Let's see a couple of examples. I blogged about using Cloud Workflows to actually do a Firestore backup. So essentially, there is a scheduler which has the right permission to trigger a workflow, and it will do a Firestore API operation to do the backup, and the backup is placed on Google Cloud Storage. This article is on martoncodocmedium.com. There is no paywall, so you can check it out. Some advanced use case is similar one, using workflows to load cloud storage files into BigQuery. So you have the Cloud Workflow stepping in, it sees the cloud storage, and it will do a for each, for example, for a list of files that are part of a bucket, part of a folder, and it will process it and it will import it into BigQuery or do whatever operation. Here, instead of BigQuery, you can have many operations with that file as well. You can route it, for example, even to Cloud Run, or to create thumbnails, or to create, hierarchy analysis and all kind of operations. This is part of an article on the same platform as well. The third one, this is an advanced and complex one for those folks who are in the DevOps operations. So you may have the need to actually run share commands and orchestrate compute engine VMs. Essentially, what's in here is that the Cloud Workflow is starting all the steps. The first step is actually starting a VM, then waiting that VM to boot up, and then in order to run a share command, which is done here, it submits a Cloud Build job. The Cloud Build job will connect with a Cloud IAP tunnel to the compute engine, and it will execute the arbitrary share command to it. Then once it's done, it's stopping the VM. Essentially, I get the question that why do I need to stop or start or stop the VM? Well, that's part of this example, but you could have a VM running and you just actually run a share command on it. This works on Linux systems, so it's part of the IAP tunnel service as well. This lets you, for example, to actually do operations like running arbitrary commands, running database migrations, and running workflows where you have another external system controlling the trigger mechanism and so on. This article is also available on the same platform. As a conclusion, so it's extremely developer friendly. It's easy to build and operate. It scales out. I didn't demonstrate the scaling, but it works amazing. It doesn't lose state, so you can set up variables in between steps, and those variables are acquired and it's available for them. It handles errors, timeouts, so it's very developer friendly. It's just a YAML syntax. You don't need to maintain a library. You don't need to maintain a version. You deploy it, it's there for 10 years. You don't need to come back and update it and so on. And you can build out a lot of recipes or find out from the internet to connect a lot of services. It's auditable, which management wants, that what operations are done and when. And it enables to use async workflows, which is essential in a multi-business, in a multi-program business and enterprises of nowadays. So essentially it opens ways that are endless, and even it could be a marketing job, it could be a retail, industrial IoT, or actually just the developer one, which is automating the cloud, shell script replacement, orchestrating DevOps workflows. But also I've seen in the industrial world that it's part of digitalization of internal policies. So you have already the processes, you have the workflows defined in an organization, and they can actually build it out. Workflow-based maintenance needs are one of the futures because it lets you to actually pause for 1 year a workflow, so you can actually generate code, generate a workflow that will be triggered 8 months in the future, and so on. So basically this is my talk, and hopefully you loved it. And if you have any questions, post on the chat as well. I will be monitoring it and I can answer it for you. I have one more demo, but I'm run out of time. I wanted to demo the callback feature, but I need 5 additional minutes for that, but I will skip it because I'm out of the time.
Thank you very much. Could you mute yourself? Thanks. Otherwise, I get the feedback. Thank you very much for doing this. It's been really interesting, and I got some good ideas as well. It got me thinking, just sitting there like, what can I do with this kind of stuff? One thing that comes to mind is that, can you say, there are actually 2 things. So one of the questions that's been asked here is about the cost. So like, how does it scale? How does it like work with scaling, and if it can it do automatic scaling, and how much would it cost like money-wise?
Yeah, that's a good question. So cost-wise is based on steps, and based on internal steps, and based on external steps. So right now the steps are, the cost is $1 for 100,000 internal steps, and 2.5 for 100,000 external steps. But be aware that the workflow could have 20 internal steps. So it's not just one execution, it's based on steps. So essentially people forget it that a workflow could have around 25 internal steps as well. And this is just works out because you could set up one-off workflow for whatever action in the next year, because there is also a 1 year pause, so you could work out for that. And in regards to your other question, scaling is offered based on the invocations as well and state. So first of all, workflow is only part of 4 regions. It's not available yet on every region. So on those 4 regions, they offer the SLA of like a Google Cloud product, and they are working out to add 2 additional regions as well. I was able to actually try out to invocating a couple of thousands of items, so I didn't had to run workflow which are millions of it. only a couple of thousands, and for there it works out great. There is no latency, so whenever the request is issued, the triggering request is issued, the workflow starts kicking in, and the receiving service need to handle it. So the workflow is too advanced to actually pay attention to the receiving service. That are you able to trigger that API? Are you able to handle the amount of requests to that part?
Thank you. That's very interesting. That's really that's something I'll need to play around a bit more with. One more thing, how does it work to can you say a few words about debugging, and also if are you able to run it locally or test it in one way or another, or when something goes wrong, if it is possible to debug other than going into the logs and see what actually went wrong?
It's a managed service, so it's part of the Google Cloud Platform. It's hidden. It's a black box, so you need to debug it like a serverless app. So by using recipes to have internal steps that let you to debug which step is doing what. Logs are much more friendly. So, for example, in my application, if you turn on the screen sharing, I will show you that I have a command, gcloud alpha logging tail, which is part of my action. And logging tail is one of the action that I constantly monitor when I develop with the cloud workflows. And so let me clear the screen. So logging is started, for example, initializing tail section, and for example, callbacks. Let's use the callbacks. I'm running the execute of the callback, and in the tailing section, immediately it will show up. So look, it was there. And essentially, I was interested, for example, to get the URL of the callback section, and the URL was posted in the logs. So this is how you debug it. And you could obtain, for example, this URL and go to another screen. I'm just demoing now. The connection was lost. I'm just debugging now the callback service. Come on. So essentially you can get this URL and ping the callback service, but you have here all the logs of it. And again, the command is gcloud alpha logging tail. So this is what I use, and it's really helpful. This is not just workflow based. So you have all the loggings here. If you have a large infrastructure, you need to add filters to it, but I'm using only for demoing on conferences this talk. So essentially now we had this workflow, which I started. Let me demo one more action here. The callback feature. So there is a URL I'm not actioning now. And if I want to describe the workflow, which I started for the callback, it says it's active. So it's waiting for me to actually have my event adding a callback to the workflow. And now in this other screen, I'm issuing a callback action to it, like it was an application. Oh, I mismatched the URL, I think, because I didn't direct it. So actually, when I access this URL, I'm able to actually see that action finishing. So that's what I wanted to demo.
Perfect. Thank you very much for doing this. That's very interesting. And thank you for joining us. I think we'll need to jump over to our next speaker, but we hope to see you soon at our other events. And again, thank you for coming.
Yeah, thank you for being here. For example, next time maybe we can have only demo sessions without presentations, as people want this workflow thing. They want to live it, the experience. I'm seeing a lot of questions on Twitter. can you hop on a Zoom session to show me much more exactly? So they don't need presentation. Live coding is the next thing for it. Okay,
Indeed.
have a nice day. Thank you for being here. Bye.
Thank you. Bye-bye. All right, Michelle, nice to
Hello.
have you with us. Welcome to Devfest Norway.
Thank you. It's a pleasure to be here.
It's a pleasure to have you here. You have 20-25 minutes to do a talk, and we'll be in the background, and we'll be collecting questions. And at the end of the talk, one of us will appear on the screen again and ask the questions that people might have asked while you're doing your talk. So without any further ado, I think it's time. Take over the stage. And
yeah, thank you.
Mike is.
Thank you. So welcome everyone to my talk, Solving Imaginary Scaling Issues, which is a kind of personal journey amongst wrong architectural decisions. Let me present myself. I'm Michele Riva, Google developer expert in Google Cloud. I'm an incoming senior architect at Nearform. In like a few days, I'll be joining them. I'm a book author, and I'm the author of Real World Next.js, which is a book about Next.js, of course, and just for you to know in case you're interested. But we're talking about books. We are here for something else. We are here for this specific book. The first time I've seen this book, it was a meme shared by dev.to, so the practical dev, which is a Twitter account from a popular blogging service. And it's about solving scaling imaginary issues, as you can see. And I thought, oh my God, they are spying me, because that's what I do almost on a daily basis. So I was like, okay, I'm quite scared, but we can do that. Let's see what I learned during the last years making wrong decisions. So I hope this talk can be beneficial for everyone here. First of all, we need to identify what scalability is. So fullscale.io states that scalability is an attribute of a tool or a system to increase its capacity and functionalities based on its users' demand. Scalable software could remain stable while adapting to changes, upgrade, overhauls, and resource reduction. And let's concentrate on that last sentence. Scalable software can remain stable while adapting to changes, upgrades, overhauls, and resource reductions. And every single imaginary scalability issue I'm gonna share with you, it's an overreaction to one of those things. So let's see those things in detail right now. First of all, we have changes. The system should remain stable when applying any kind of change to both the infrastructure and the application. For example, switching from Compute Engine to Google Cloud to make the whole infrastructure more cost-effective. Meanwhile, I'm doing this transition. The whole system should be available, should remain available. So that's a kind of metric for kind of identify pitfalls in our architecture. Upgrades. The system should remain stable when upgrading any of their components. For example, if we are upgrading our software, our web server, or upgrading the runtime, for example, switching from Node.js like 14 to 16 and so on, the software should remain stable up and running for the whole time. We shouldn't have any kind of downtime. Overhauls. So the system should remain stable during maintenance and debugging. For example, if the system is not working properly, it should be easy to identify and inspect production deployments. And there is the last one, which is the first one that came into our minds when we are talking about scalability, of course, which is resource reduction. The system should remain stable under high load. For example, an e-commerce is rolling out a great promotion with huge discounts. There is a lot of traffic on the website, and the connection should remain stable. So, for example, we have a little server, and we weren't planning so many users browsing our website. So we now have a happy problem. We have to scale, meaning we can scale horizontally, meaning by decoupling the system into multiple nodes, or vertically, meaning giving more power to our machines. So, of course, resource reduction, because we have a fixed amount of memory and power computational power, and we need to satisfy every single request. I'm going to share with you 4 different scenarios that, as I said, are a kind of fun overreaction to those 4 things that we just seen. And I gotta say, this is myself, my young self, being foolish with being happy about trying new things and trying to understand how to make our system scalable. So this is all my fault, and I'm really sorry about that. Imaginary issue number 1: this programming language doesn't scale. Oh, that's a bad one. Okay, we all know that Facebook is written in PHP, so there is many people out there saying like, PHP, I wouldn't choose PHP because it's not scalable. I do not accept that statement, because PHP, if you're good at writing PHP, it can scale. Of course, Facebook then created the hip hop virtual machine, and then created the hack programming language, compiled PHP to C++, whatever. But they were able to solve a problem and scale a product built in PHP. So that's not an excuse. And the younger Michele thought that was a real problem, but it's actually not. And we are used to see like Twitter had to abandon Ruby on Rails because Ruby on Rails cannot scale, and they had to adopt Scala. But guess what? We don't often have to handle the massive traffic of both Twitter or Facebook, of course. And last of all, WhatsApp is written in Erlang, so we should use Erlang because it's a massively scalable system. But again, we are not Facebook, we are not Twitter, we are not WhatsApp, so there's no real need for us to use a very specific programming language such as Scala or Erlang that are built for scalability. We just can use what we are more confident coding in, and that's enough for us. And when I say we are not Facebook, Twitter, or WhatsApp, I mean that Facebook in 2021 had to serve 2.9 billion users. How many users do we have in our typical website? I mean, this is a good metric, but there are just few websites having these happy problems, of course. And what about WhatsApp? They're serving like 100 billion messages per day. Do we really have to serve the same amount of messages or traffic with our applications? So the questions we should ask ourselves are, how many active users do we have today? How many active users do we expect to have in the next 5 years? How much should it cost? Would it cost to teach the whole team to code in Erlang, Rust, C++, Scala, or any other highly scalable language? That's a hidden cost. And I want to share this tweet because it's amazing. They're sharing how they were able to serve 43 petabyte of traffic every single day during the Cyber Monday using Ruby on Rails and MySQL. So the excuse saying Ruby is not scalable, it's not valid anymore. A strong engineer culture, it's what we need, as states in this tweet, of course. So imaginary issue number 1 debunked again. Good PHP code scales better than bad Erlang code. And good Ruby code scales better than bad Scala code. We should all be aware of that. Believe me, I tried this. And imaginary issue number 2. We need to use cloud functions. And here I'm talking about Google Cloud Platform again, of course. And we need cloud functions to manage high traffic. Serverless computing scales better. That's true. But at what cost? So I try to identify a simple situation where we have like a number of invocations per day, and we are going to see how much we will spend. Keeping in consideration that the cost of Google Cloud Functions are first 2 millions of invocation per month are free, and beyond 2 millions, we just pay 40 cents per million. So it doesn't sound like a lot. Then it depends on the kind of compute time and RAM we use. For example, if we use like 128 megabyte of RAMs, we spend something. I cannot even pronounce this number. It's too, as you can see, it's too tiny for me, and my English is not good enough. But as you can see, every 100 milliseconds, we spend a very tiny fraction of a cent. And then we pay for networking. So the first 5 gigabytes are free, and then we pay like 12 cents per gigabyte, which doesn't sound like a lot. So this is what I try to identify. So let's say we have a simple but critical REST API that gets 50 requests per second, which translates to 129,600,000 requests per month, which are a lot. The average execution speed is 300 milliseconds. And for that specific API, we can use the cheapest RAM option, which is 128 megabytes. And for each invocation, we require around 100 kilobytes of bandwidth per execution. And I'm being like super positive about that because it's not a lot. This is our cost. So Cloud Functions in Iowa costs around $1,600 every single month. And what if we double the API request because we are scaling? We go serving 259,000 requests per month, which is a lot. And that translates in a critical cost increase like $3,000 per month, which is a lot. And what if we use Cloud Run for the same, for the same task? As you can see, with the same amount of memory, with a similar configuration, we can serve the same amount of requests, spending like almost $200 per month, which is way cheaper from the Cloud Function counterpart. And I promise we can go even cheaper than this. If we go on Compute Engine with an E2 standard 2 machine and a free EP, and a public EP, of course, we will be spending like $52 per month. And we have like 8 gigabytes of RAM and 2 virtual CPUs. So we could potentially, if our software is good enough, we could potentially serve this amount of traffic. So we are going from $3,000 per month to $52 per month, which is a good decrease, as you can see. So imaginary issue number 2 debunked. Cloud Functions are good at managing spiking and unpredictable traffic. So if we are not able to predict high and spiky traffic, then Cloud Run and Google Cloud Functions are exceptional. They're terrific. They're able to manage for us auto-scaling and wherever. And they can scale really well, but they have a cost. And I want to iterate on another tweet I've seen. And as you can see, in that case, this user is using Heroku, where with just $7 per month, he's able to make like $5,000 of profits every single month. So without using Cloud Functions, and we don't have to overcomplicate things, as you can see. Imaginary issue number 3. NoSQL databases scales better than relational database management systems. And this is one of my favorites one. And I've fallen too many times into that rabbit hole in my past. And I want to share this tweet again. They're basically serving, let me say again, 30 terabytes of traffic per minute, which translates to 43 petabytes of traffic per day using MySQL. And there are a lot of people saying like, okay, DynamoDB, Firestore, or whatever NoSQL database will scale better. And I'm saying, what you know, it's what scales better, what you are comfortable coding with. There are many companies actively using SQL databases such as Facebook, Uber, Netflix, Instagram, Spotify, and many others. And they have massive traffic. They have a great engineering culture that can help them achieving great results. Remember when we said that good PHP code scales better than bad Erlang code, and good Ruby code scales better than bad Scala code? Well, same thing applies to databases. good MySQL knowledge, it's better than any NoSQL pure knowledge. Good experience with Postgres SQL is better than no experience with any NoSQL database. Don't overcomplicate things in the name of scalability. That brings me to the last issue. We need everything custom so it fits our use case. That's also one of my favorites because I fall in many times into that rabbit hole again, and I need to share another tweet again. And that's the same tweet I've been sharing for the whole presentation because it's perfect. That states that using like Shopify in that case can be good enough for anyone. So why should I build my own e-commerce if there's a platform, a good platform such as the Shopify one or Big Cartel, or using Graph CMS or any other CMS that solves the problems we already have? Again, good engineering culture is what brings value to what we build, not the technology beneath our choices. And there are amazing frameworks out there, such as Java Spring, Elixir Phoenix, PHP Laravel, and Ruby on Rails. And they are built with security, with performances in mind. So with team scalability, of course, because they allow easy onboarding to the project, common configurations, and modus operandi, of course, on how to write code and implement things on those frameworks. So imaginary issue number 4, it's debunked again. Frameworks already provide everything we need to implement most of the custom business logic we need in our apps. That's an important one. How do I determine if my application is really scalable or not? Because at the end of the day, we have to make decisions. And we have to determine if our applications are scalable enough, if we made correct architectural decisions. The first thing I'd like to highlight is my team scalable? I mean, are we ready to onboard more developers in our team? Are we choosing a programming language, for example, that everyone in the team, almost everyone in the team knows? How much would it cost for us to onboard a new person into that programming language or into that database or into that, I don't know, a framework, wherever? If the answer is we will be quick, we will be fast, then my team is scalable. Then we should ask ourselves, are we adopting this technology because we're excited about it, or are we doing this because it's the best solution to our problems? You know, many times we are following the hype-oriented programming. A new programming language comes out, a new JavaScript framework, we all fall for this. And sometimes we create a problem just to be able to solve that problem with what we just found out. And that's dangerous. And then, of course, do we know our app traffic? Many times we don't do our homeworks. Many times we don't do researches. And therefore, we end up choosing something that doesn't really fit our purposes. We overcomplicate things, thinking that we will be like following our competitors, like Facebook or big tech in general. But we won't be there until like 5 years, 10 years. So we just have to wait. And talking about competitors, we just need to stop speculating, and we just need to start understanding how our competitors are approaching the problems. We have to analyze our market. We have to analyze other competitors' technologies and decisions. That's how we can make great decisions to compete. And of course, we are developers. We want to have fun. And yeah, of course, I get this. But don't let that fun compromise your work. Don't let the hype-driven development to break through your development workflow. Just be confident with what you're choosing. And I'm trying to be quick so that the next speaker can come in. So I want to thank you all. Thanks so much for joining this talk. And these are my social networks. I'm more active on Twitter, so if you want to follow me here, I'll be glad to answer any question if you want to talk privately. And thank you again for being here. It has been a pleasure, and I'm happy to be on time. So Thank you.
Thank you, Mikhail, for a wonderful presentation. It was very interesting to see the presentation, especially when it comes to working in small teams, big teams. How do you plan your today and plan your tomorrow? One thing I do want to ask you is that sometimes maybe having, if it's a small team and not so much capacity, maybe having a cloud function turn out to be more manageable than, for example, having a compute engine and setting up everything on the compute engine. So I was just curious about your thoughts on that. How do you manage both scaling, but also at the same time managing the expenses for both?
Yeah, that's a kind of trade-off you have to make with your team. That's a management decision rather than a technical one, because of course we can solve the same problem using cloud functions and Google Cloud Run and compute engine. At the end of the day, we can find a solution by using any one of those technologies. So it's not a big deal to adopt any one of those, but it's about our product. So what will be costing more at the end of the month? Having a small team but with a high Google Cloud bill, or onboard the new people and doing the things in a more scalable way? That's a kind of decision that it's a management level decision and not a technical one anymore.
Yeah, again, it was a wonderful talk. I wish I'd seen this talk a few years ago when I was just starting out.
I've
But
been there.
yeah, I'm sure this would be of value to many more. But thank you again for having this presentation, and
Thank you.
I hope to see you again another time. Thank you.
Absolutely, whenever you want. Have a nice rest of the day, and thank you again.
Thank you. Bye.
Thank you. Bye.
Hello, and I'm happy
Hello,
to
hello.
welcome Nico. You have a very exciting talk, and especially on Bluetooth and web. So without taking much time and space, I would have you use the stage, and you're all ready.
Yeah, so hello everyone. My name is Nico. I'm a web developer from Switzerland, focused on modern front-end development. I'm also part of the Google Developer Experts program for web technologies, and I'm 1/3 of Say Hello. We are a small digital agency based here in the middle of Switzerland, we can say. And right now, as part of Say Hello, I'm working as a freelancer already since several months on a e-banking front-end written in React. Yeah, but today I'd like to take you through my journey with the Web Bluetooth API. So historically, the web platform was built around the idea to access a server and to render documents. And that was the original intention of Sir Tim Berners-Lee and his friends. So the browser has always been great communicating with a server, but it has been quite difficult to interact with devices right next to it. So in the last years, websites and web applications have become way more complex and powerful. And also with progressive web apps and the whole Project Fugu, we have seen a lot of new APIs and browser capabilities. And right now we have 3 very, very cool APIs that try to fill this gap. We have the Web USB, the Web NFC, and also the Web Bluetooth API. But first, let's start with the basics. Bluetooth is a wireless technology standard to exchange data that uses the same frequency as wireless LAN, but it was built to run energy efficient over a short range. And if you now think about this buggy and frustrating thing we used with our first cell phones, I have some very good news for you. That was the old Bluetooth Classic. Now with Bluetooth Low Energy, or also Bluetooth LE, Bluetooth 4.0, we have not only an upgrade, but we have a rather completely new technology, especially designed for IoT devices, that is very, very energy efficient and runs over a quite long distance. So I've seen examples where 100 meters plus were no problem. Also, with Web Bluetooth, the browser API, we always talk about Bluetooth LE because that's the standard that is implemented with this API. The way Bluetooth works is mostly like this. You have this one central device that communicates with one or more peripheral devices. In general, the central device is more powerful, has more CPU power, more battery, and the peripheral devices are the simpler ones, let's say, as I said, IoT devices and so on and so forth. We also refer to them as clients and servers. So the central device is the client, while the peripheral devices are the servers. And now the very important part and one very important feature of Bluetooth is that one central device can always communicate with multiple peripheral devices, while one peripheral device can only communicate with one central device. And also peripheral devices, they can't communicate with each other. They always need to have the central device as, let's say, as a relay. Now, one thing that's very important to mention is that BLE is not the perfect choice for all devices. As I said, BLE is very energy efficient, so it will only send very small commands when needed. But when you have or when you need a constant and also bidirectional data stream, you might still use Bluetooth Classic. So as part of BLE, the Bluetooth Special Interest Group introduced the Generic Attribute Profile, short GATT. It's basically a protocol that standardized the way how devices would communicate with each other. So we would have the GATT server. So each device provides such a server, and it contains a list of services. Each service then has a list of characteristics, and each characteristic identifies now a value, and it defines which operations can be performed on that value. So maybe one operation can be read, another operation can be read and written, and you can be notified, and so on and so forth. Now, each value is now just an array of bytes. So we are talking about a very low-level data structure in computer science, just an array of bytes, and the characteristic defines operations can be used. Now, one technical requirement is that all services and characteristics need to be uniquely identified, and therefore we have 16-bit or 128-bit UUIDs for each of them. 16-bit UUIDs are reserved for so-called standard services and characteristics. That's basically a list of UUIDs and their use case maintained by the Bluetooth Special Interest Group. But if you have use cases that are not in that list, and most likely you will have those use cases, you should use those unique 128-bit UUIDs. Simply because with all those possibilities, it's very unlikely that two UUIDs conflict with each other. But that's not a technical requirement, very important to say. I've seen lots of examples where they use custom characteristics or services that did use 16-bit UUIDs. So in the end, it's totally up to the manufacturer to assign those IDs, but it is recommended to use 128-bit UUIDs for custom characteristics. Now let's have a look at one example. Here I have a light bulb. This light bulb has two standard services, the device information service and the battery service, and those have standard characteristics like model number or the battery level. That's just standardized by the interest group. And then we have a custom service because there is no standard service for light, for colors, or for the intensity of the light. So they came up with a custom service. In terms of UUIDs, we have the 16-bit UUIDs for the standard services, and we have the custom UUID, the long one, 128-bit UUID for the custom service. Now, as one part, I'd like to look at the values of those GATT characteristics. As I've mentioned before, there are several operations that can be performed on characteristics. We have, for example, read, write, notify, indicate, and each characteristics can allow one or more operations. So, for example, a battery characteristics might only allow to read, allow the read operation, or it sends notifications, while, for example, a drone or the direction, the flight direction of a drone should, of course, also be writable, so you have a remote control. Each value is then an array of bytes, as I've said before. And as an example, I have here one characteristics or one value that consists of 3 bytes. We have 00FF64 in the hexadecimal as a hexadecimal value, and 0, 255, and 100 as a decimal value. So it's just this characteristic has 3 bytes. Could be more, could be less. It's totally up to the manufacturer to define how the characteristic looks like. Let's have a look at one example. I have here an app called NRF Connect for Android. It's basically an app that scans for all available BLE services and allows to play around and to interact with them. So as you can see here on my screen, I have the app. I can open up the app and I will see a list of all the devices. And now I can connect to the play bulb sphere, and I will see a list of all the services of that play bulb sphere, of that light bulb. I have the standard service for battery and the characteristic for the battery level. That's now 50%, which is enough. And I have a whole list of custom services. One of them is the FF0FF, and there we have a whole list of characteristics. And now one of those characteristics, I don't know all of them, but I know there's one characteristic that is especially interesting because it has 4 bytes. Right now it's FF000000, and now I can write this characteristic. So I can, for example, say, I want to set that to 00FF0000, and the light bulb turns red. I can try another value. For example, I can say, I want to have this 0000FF00, and it turns green. So we have red and green, and now I will try one other, that's 00FF00, and it turns yellow. So what we have here on that play bulb sphere, we have 4 LEDs, and each LED is controlled by 1 byte in the Bluetooth characteristic. So we have the white LED, which is the first one, then we have the red, the green, and the blue. So in the end, we can mix up with the intensity of each of those LEDs, we can mix any color we have in the RGB spectrum, or we have in hex code, for example. That's pretty cool about that light bulb. Now that we have the basics, we can finally dig into the web API. And that's actually quite straightforward, I'd say. First of all, we want to connect to a device. So on the navigator, we have a new Bluetooth object where we can call the request device method. Here we can either filter the available devices, or we can define accept all devices true. In that case, we want to filter by the name. And as a second argument, we also have to define what services we expect and we will use later on. Now, when this code is executed, the user will see this prompt there on the right side. And when he or she selects a device, we can then just connect to the GET server of that device. Now, let's start with a standard battery service. On the server we just received, we can now get the service using the UUID, and on that service we will then get the characteristic. On the characteristic we can call read value to read the value, and the value we receive is a data view, so we use getuint8 to read the first element, which is in that case the battery level. Since that characteristic also allows the notify operation, we can now also listen to the characteristic value change. event, and then we can update the battery level whenever it's updated on the device. Now, it's very important here that we must explicitly start or call start notification. As for the sake of energy efficiency, these events are not sent by default, so we have to tell the device that we need those events. Let's have a look at the light service. Here we want to read and write the RGB values of our light bulb. So there again, we start with the service and the characteristics, also by UUID. And now we read the value. It's just the same as before, but now we need the second, the third, and the fourth element, since the first element is the white LED, and right now we're not interested in the white LED. And to write the value, we can then call write value without response on the characteristic, which accepts an array buffer. There's also a write value with response, but that depends on the device you are using. So in that case, the playbulb sphere explicitly requires that we write the value without response. But that's already everything you need to know about the Web Bluetooth API. So it's a very simple and straightforward API, and it allows us to do so much cool stuff. Now, browser support looks quite experimental. I think it's no surprise that Google and Microsoft are pushing this new API, while the others are waiting for a bit more established state of the spec. But at least for iOS, there is a workaround. So if you want to play with it, you can use the workaround, an app called WebBLE for iOS. So speaking about playing around, let's start the fun part of that talk. So I created a little web application to control my light bulb. So I have the light bulb here, and I can then connect to it to turn it on first. So when it's on, I will see that in the little picker. Here we go. And then I can connect to my light bulb. So what you will see next is just a set of buttons, and I'm using the same code I showed you before. Here we go. So if I click on the red button, it will turn red. Green button, it will turn green. I think with the camera, it might not be the perfect color, but I also added a random color function. So if I click here, it will just generate a random hex value, and it will update the characteristic on the light bulb. So in the end, with the Bluetooth, we can basically control every BLE device around us. But the problem is, reverse engineering is a huge pain. I have ordered a couple of BLE light bulbs before I found the playbulb sphere, and each of them had a different structure of their characteristics and services. So as I said, there is no light standard. I tried logging those requests from their official apps. I have tried to make sense of the characteristics, but as I've said before, it's an array of bytes, and it's so hard to make sense of that. So it was just a huge waste of time and energy. So I started with my own hardware. Now I'd like to welcome Speedwheels on stage. Speedwheels is basically a little Raspberry Pi CRW, which has a motor driver hat with which is connected to 2 DC motors and wheels. It's not that fast, but it has wheels, and my son came up with the name, so I'm fine with that name. And oh, sorry, I just seen I need to go to my slides again. Here we go. And later on, I also added a little battery pack and a LED matrix which has 11 to 7 little LEDs, and I can control them using a characteristic on the device. I have the whole process documented in a Twitter thread, so I have the link here. My slides will be online after the talk, so you can have the link there. And also the whole software I built on the Raspberry Pi is also on my GitHub account, so you'll be able to, here we go, to have a look there as well. Here we go, that's SpeedWheels. Now, on my Raspberry Pi, I have a Node.js running. So I have a little Node.js application that is basically responsible for two things. It controls the motor and it exposes the BLE service. The motor basically needs two values from -100, which is full speed backward, to +100, which is full speed forward. One for the left, one for the right wheel. And the BLE service is responsible for the battery service and which is a standard service, and the motor characteristic, which is a custom service I created. Now, the biggest question I had to answer is how I structured my characteristic. And since I am a front-end developer, whenever I want to transfer data between two parties, I would just use JSON. Here we go. I will take the object from the motor. I will just JSON stringify that, create a byte array, and I will just write that value. So I have around 23 bytes for each request. I think that's perfectly fine. As a front-end developer, my range of payload sizes goes from kilobytes, which are good, to megabytes or gigabytes, which are bad. But now I really hope some of you might have a better understanding of hardware and data structures, and maybe you already think, what the hell have I been doing? And luckily, I come up with a better solution myself. So since I only need two values between 0 and 200, it was perfectly fine to just use 2 bytes, because 1 byte has a range from 0 to 255. So 1 to 200 is perfectly fine in that range. So in the end, I came up with a much smaller solution. And the fun part here is with those low bandwidth connections like BLE, it actually does make a difference whether it's 2 or 20 bytes. So when I finished my car, I also created a little web application, and I will show you the quick demo now on my smartphone. And also over here, I have the stage for my hardware demos. Hope this will all work out. So I have the web application, which is a progressive web app. I can connect to my device using the Web Bluetooth API. And now I basically have 4 arrow keys. So whenever I press an arrow key, it will send the request to the wheels. And whenever I release the press, it will send the stop command to the device. So if I click on the up arrow, it goes forward, backward, it can make turns, and so on, and that works. So the cool thing about the web platform is that we have so many possibilities. For example, I mean, it's still the same characteristic I'm talking to, but I could also use the gyroscope on my smartphone. And that way I have this little ball, and I can't show you that on this on the camera, but if I move my there it is. If I move my smartphone, it will move the little dot in the middle, and that will then call the characteristic. Now, one last example I'd like to show you is, I mean, let's be honest, the web platform is awesome, and it has so many things to use. For example, we also have things like TensorFlow. So we can also use machine learning on the web platform. So if I now connect the desktop application, which is also just the web application, and now take some time to here you go. There it is, SpeedWheels. I can connect that over the desktop web application. And what okay, that's fine. It's just, Okay, I think now it won't work and we are running out of time. But I will point you afterwards to a demo where I was using hand gestures to just move the car. Maybe it will work again. Nope. So that's the fun thing when you are doing live demos on a conference. Now, to sum it all up, we have this very powerful new API to communicate with devices around us. The question I asked myself is how far can we go with that technology? So also in the beginning, I said that we can use multiple devices with one central device, but can we also use multiple devices with one web application? And if so, where is the limit? Turns out there are no limits. I do have multiple little devices. So here I have two LED matrices, which are 17 to 7 little LEDs, also on a Raspberry Pi and on a battery pack. And I also have the light bulb and I have the car, and I really hope I will be able to connect it now. But me and my little friends here, we created a performance for you, which is the Bluetooth party. So one thing first, as you might know, the browser also has a thing called the Web Audio API that allows us to listen to and to analyze audio sources. And that's perfectly fine to use them on the web application and to send then commands. So each of those little Bluetooth devices can do its part in the performance. Let's hope this works out. I can now set up the audio and I have the devices. That's my little stage. That's pretty bad. Well, it did work just minutes before, but of course it does not work right now. Okay, so okay. I will just try it one more time. So the light bulb works fine. Okay, it will not work right now. I'm very, very sorry for that. Yeah, but in the end, I would have had a pretty cool demo where all those devices will play together. And I will also just upload a video right after the talk where we will see everything in action. And I really hope that the organizers will, or you know what, I will just upload it to Twitter. Yeah, but that was it from my side. Except all the things that were failing, it was a pleasure talking to you.
Thank you, Nico. It was a
Chinese.
very inspiring and amazing talk. We were all rooting for you, and we'd be happy to post your video on our channel also. So please feel free to share it with us. I had a quick
I
question though.
will.
I had
Yeah.
one question with regards to when you define the client and server, where your web app is the client and the devices are the servers. I was wondering how does it, how do you have, what do you have to do to, when multiple clients will try to access the server, and how do you take those things into account? Let's say you have your device and your partner or your friend's device, and you're both trying to interact with the same car or whatever.
Yeah. I mean, if one device, let's say the car, is already connected to my smartphone, it won't show up in the picker. So my friend won't see the car in his picker, so he will just see nothing. So it's really once one device is connected, it's just blocked for all the others, and yeah, they won't see anything.
Yeah. And when it comes to like all the different servers or devices having multiple standards, I guess we then need a common standard for communication with these devices in a way.
Yeah, I mean, we have standard services. For example, the battery service is a standard service, and we all know, okay, a battery service has this one UUID, and we expect 1 byte on the characteristic, and we expect it to be notified or expect it to be readable and be notified. So that's already enough for most things. And then we have really a lot of different little devices, and there it's perfectly fine when that each manufacturer just decides themselves which characteristics they will need for their device. So maybe we have a light bulb which has multiple colors. Maybe we have a light bulb that has some completely different process how they calculate colors and stuff. So they will have another. They will have a different characteristic for their colors and so on and so forth. So I think there is no way to standardize all use cases, and that's why we have the standard use cases, which are standard, and the possibility to add custom use cases.
Okay, with that, thank you again. It was a pleasure to have you, and we hope to have you again in the future.
Yeah, that would be great. So, bye.
Okay, so we have our very own fellow GDG organizer as a speaker. We are very happy to have Tanaz speaking for us at Devfest. Without using a lot more time, I'd be happy to have Tanaz take the floor and go ahead with it.
Yeah, thank you for having me. So before we get started, a few words about me. My name is Tanaz. I'm working as a cloud engineer for the University of Oslo, where we are building our own open source cloud solution for research and education sector in Norway. I am also an ambassador for Women Tech Makers and one of the GDG organizers for this event. And another fact about me as a developer is that I like to automate everything. I like to simplify the tasks that I don't need to do them again and again. And I believe that that's a mindset that many developers would have. After all, computers are great at doing the same thing over and over again, while humans get bored and annoyed of repetitive tasks, and the chance of doing something wrong is really high. So in this talk, I would like to give you an introduction on how to automate an infrastructure with the infrastructure as code concept. According to Uptime Institute, and if you are not familiar with that, they are barrier for digital infrastructure performance. They do surveys every year on IT performance outages, and this is a report from last year, where they conclude that the majority of data centers failures are caused by humans. And there isn't, a fault in the infrastructure design. So as programmers, as soon as we realize that a task is repetitive, we should consider looking for an automation way to solve that problem. And it might take just few minutes to do the task manually by hand. And maybe it takes several hours to write a script or feature. But all in all, we save time in the long run. And there are other some good benefits with automation. It increases frequency releases, increases productivity, improves quality, safety, reduces errors, latency, dependency, and also improves reliability and consistency. Talking about automation, we should definitely mention DevOps, as automation is the principal key of DevOps. And when you hear DevOps, you probably think about an infinitive loop with all those stages and tools, something like this. But it is actually much more than that. Here is a definition of DevOps that I like. It says that DevOps is the combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity. So, yeah, DevOps is a strategy that bridges the gap between developers and operators, between the teams in general. So it's basically about people. It's about collaboration. And in order to have automated solutions, we need to have automated teams. And what I mean by that. It took decades before the tech industry realized that people who are working in tech, people who are actually creating technical solutions, are important. So if a company is looking for good results, they should focus on their people first. How people feel. Does anyone feel included? Does anyone feel they belong to their teams? And how teams work. Do they collaborate well? Do they have all the tools they need to communicate? And so on. So once we have that culture, then we can go to the next step, which is automation practices and tools. In other words, we can say that collaboration culture is a vital element of DevOps, and automation is an important part, but it comes after. So how is automation applied in DevOps? Automation starts when a developer pushes the code out, and the team needs to monitor the application and systems and make sure that everything is up and running, and so the system is drifted. So entire DevOps pipeline contains continuous integration, which refers to merging of source code updates from all the developers on the team. And then we have continuous delivery that refers to development practice where the code stages are automatically built, tested, and prepared for the production. After that, we have performance monitoring. And we need to do all those steps to decrease to minimize possible errors, of course, and that's great. So then let's automate everything. As applications can be deployed into the production several times per year, per day, I mean, it's crucial to minimize possible errors. So we can automate many things, but we cannot automate everything. Like when it comes to more complex functionality, or if we want to do visual testing and user experience, these things can't be automated. But those things that can be automated, we should definitely considering doing that. So let's explain by an example. Let's say that we have access to a public cloud and we want to set up our platforms and applications on that. For doing that, for running our application, we decide to set up a virtual machine. Let's call it VM1. And after some times, we decide to set up a new VM, a VM2. So we set up the basic infrastructure and make sure that these two virtual machines can interact. And after a while, we might decide to go to the production. And we know that for the best performance, we want to do all the new things in the test environment and do the exact same thing in the production. But we want a whole new environment that is the exact copy of our test environment. So how can we do that? Should we start from the scratch? Can we go through the documentation and start all over again? I mean, we can do that. But what if we have done a tiny change that we forgot to document it? And what if we decide to add another VM or do some reconfiguration on one of them? Should we do it several times because we have different environments? Here is when we can take advantage of a concept called infrastructure as code, also known as IAC. So it is basically a concept of automating all the tasks end to end. And there are many tools for doing that can help us to automate our infrastructure. There are different tools meant for different tasks, and we can also combine these tools to do different and specific things in our infrastructure. There are tools like Ansible, Puppet, Chef, Terraform, SaltStack, and many more. So let's break it down. Infrastructure, we can divide them in three main categories. We have provisioning, configuration, and deployment. In provisioning, we want to spin up new servers. It's the first time we want to set up the servers. Then we might need to do some network configuration and maybe creating some load balancing. Just make sure that the infrastructure is there and working. And after that, we want to prepare the servers, the infrastructure to deploy our own thing on it, like installing applications, software packages, something like installing databases, installing Java, Python, and so on. So when our servers are up and running, then we can deploy our own applications. And we can actually merge the step 2 and 3 together if we use container-based technology. Then we can build everything on the container and then install the container on our server. There are two phases for setting up infrastructure. An initial setup, when we want to set up the server for the very first time. We want to go from nothing to having a server. And then we have all the other times, something like that. Like the first time, we need to do the initial provision, initial configuration, and installation for software stuff. But all the other times, we can do adjustments. We can do reconfiguration. We can do reinstallation. We can add or remove VMs or install something on one of the VMs and so on. And there are different tools that can help us with that. For example, we can use Terraform to provision and set up the first server, and then we can use Ansible and Puppet to configure, deploy, manage applications, and do some updates. Another thing in infrastructure are two approaches that we can do automation are imperative and declarative. Imperative allows us to define step by step how we want to go to a certain state in our infrastructure. Here we can use CLI or a script like bash script, and then we can say CLI create VM1, CLI create VM2. It gives us more freedom, but is at the same time more complex because now we need to make a specific customized script to do the work. And that might not scale well for every task. We have also declarative approach that allows us to define the final steps. Here we can use like Terraform, and then we say that we want 2 VMs. And we don't care how you set it up. So the provider handle the rest for us. So this approach allows us to manage, configure much easier and faster, but we don't have that freedom either. So it depends actually on the task and the problem we try to solve, which approach suit best. Another thing is immutable and mutable infrastructure. In an immutable, nothing can be changed. So when we want to do something new, if we want to go from version 1 to version 2, we need to make the exact same environments first, along to the old version, do all the things on that new infrastructure, and when everything is working well and we are happy, so we can bring out the oldest version. While in mutable, we do changes in the same environment. So if we run the script for a mutable infrastructure several times, we end up with same environments. So we can say that for the first time, we run it to provision the server and the environment, and the next time we just run it to make sure that everything is the same way as we wanted. While in immutable, if we run the script several times, we end up with several different environments. And it's really useful for some tasks, but it depends again. There are also other tools that can help us when we want to automate our infrastructure. We have master and masterless tools. We have agent and agents tools. Something like Puppet. Puppet is mostly master-based. You can also run it as a masterless-based, but you don't have that support for that. I mean, you need to set up a cron job to make sure that your master actually distributing all the updates to other servers. And then you can have agent or agentless like Ansible and Terraform, where you don't really need to install an extra agent for doing configuration. But again, it depends. So just yesterday I saw this tweet. It's about like how not to use Terraform. So there are so many ways to, automate your infrastructure. And I like the replies. If you're interested in this topic, I suggest to go through the replies, and maybe you find some tools and ideas that may help your solving your infrastructure problem. And I think with that, I'm done, and I hope that you now have more clarity on how you can automate your infrastructure with a concept called infrastructure as code. And if you have any question or want to discuss this topic, you can always follow me on Twitter. Thank you.
Thank you, Tanas, for a wonderful presentation. You mentioned about infrastructure as a code and also the benefits of automation. I was curious about if you could tell a little bit more about testing infrastructure as a code and testing the automation process. If you have some pointers to that.
Yeah, are you looking for? I mean, asking for tools, or what are you interested in? I mean,
perhaps as tools, or perhaps as part of tools like Puppet or any other tools that you use on a everyday basis.
I don't know, but it depends exactly. That's a problem, that you don't have a tool that can solve all your problems. But what is important in DevOps is that you do all the testings part. If you want to automate everything, you have to do it in your test environment before you go to the production, make sure that everything is up and going. So when it comes to testing, so just run your script several times and make sure that they do exactly the same thing that you are asking for, so you don't get surprised, because we know that is not a really good thing to. I mean, it's painful if you want to fix errors in production.
Yeah. Well, thank you again for your presentation, and
Thank you for having me.
Yeah, hope to see you again another time.
Of course.
Bye.
we've already started to see the difference we can make by working together as a community.
Hello, and a warm welcome to Zach.
Hello.
We are very happy to have you, and especially looking forward to hearing about how we can use ML tools to for visual search instead of text. Without taking much longer, I would like to give you the stage, and good luck, Zach.
Perfect. Thank you so much. All right. Welcome, everyone, to my talk about how I've built my own visual search, specifically for art galleries, all using machine learning. So to give you a bit of a background, I have a very good friend called Kimberly, and she is a professional artist. And when I was talking to her about trying to become a professional artist, she was saying how one of the trickiest things is finding galleries to put her pieces of art in. And I was intrigued by this. I was like, oh, I thought surely it would be you just put it in any gallery. She was like, no, you can't do that. It's got to go in a gallery that matches the same kind of style of art that she's creating, because then it fits in with their sort of aesthetic. And then people who want to go for a specific aesthetic kind of art, they can go to one gallery and get like a selection from different artists. So that was the kind of problem. I was like, oh, that's kind of interesting. I was wondering if you could just maybe if you can describe, like, how would you describe your pieces of art with just text and just Google search maps galleries for that. That doesn't work, as you can see. Very interesting art that is kind of tricky to describe. And well, I find it very tricky to describe, me not being an art expert. So I was like, okay, so we can't use text to find these galleries. So what about images? Because we've got Google image search. So I was looking at like, what's the first way we can try to solve this? And we've got Google reverse image search. So some people might be aware that this is something you can do with Google, but you can actually put an image into Google and see what images already match it or what images are similar to it. So we can actually, I can show off what that looks like. So let me try to do that now. So I've got a piece of our art and we can feed it into Google image search, and we do get some things that look similar. Unfortunately, so we can't find like where these images came from. We only see that they exist on the web. So if I click on them, it doesn't really take me anywhere. So we can't really find any galleries, and we can at least see that it works because it at least brings us back to her own website. So yeah, it's not really good for finding other galleries, but it is good for finding, I guess, the original artist of the work. So that Google search doesn't, or Google reverse image search doesn't work, but the Google reverse image search is able to find sort of similar images. And that's interesting because we want to use that kind of technology. How do we build our own version of technology, but instead of it, just showing random images, we want it to specifically show images from galleries. So we're going to use a similar technology that Google uses for this, which is called embeddings and embedding search. So I'm going to go over this all from scratch. So embedding search 101 is going to be a way that we can sort of work out how images are similar to each other just by using AI and ML, so that you don't have to go through every image and judge for yourself, oh, this is similar, this is similar. No, you can just use AI to work out which images are closer to each other. So starting from scratch, how we could sort of do this is we first need to think of maybe some features about our images that we want to compare and to work out like which images contain similar sort of features. So we could think of, if we've got photographs, we could look at, let's see, all the numbers of flowers that are in the photographs and the numbers of people that are in the photographs. And then as we're detecting or analyzing different images, we can look out for those and then group the ones that are similar together. So let's try this. So we've got an image here. There's one person in it, no flowers. So we'll put that just slightly along the number of people axis, but at the very bottom of the number of flower axis. And then we've got a picture of a flower, no people in it. So similar position, but on the flower axis. And then here's one, lots of flowers, but one person. So same sort of area, but all the way up the top of the flower axis. You can kind of see where this is going. And we're just going to plot. Here's lots of people. So we get images plotted here, and we can kind of see that images of flowers might start grouping together as we fill this up with more and more images. I kind of got bored after doing 5, but I've got a bigger image that shows this off a bit later on. But you can kind of see, oh, if we can sort of analyze what's in the image and then group together images based on what's in them, that would be really cool and really powerful. And that does work, except what if the images aren't of flowers? And what if they're not of people? And like Kimberly's art, what if they don't really contain anything in them that's like a normal object? It could be something like a pattern or a texture. How do we then group those together? And that's where we dive a bit deeper into embeddings, because they can actually work for that. So let's look. Here is an example of, this is a standard sort of image classification model. And this is called a convolutional neural network. That's not necessarily important for this, but this is the kind of structure. So you've got the input image that goes into the AI model. We've got convolutional layers is what these sort of things are called. And then right before the end, when it makes its prediction, we have generally it's called a fully connected layer. So that's just loads and loads of neurons, and they each will produce some signal to analyze what's in the image, kind of accumulate what the rest of the network has been working out and analyzing, and then make the final prediction. So this is the standard structure of a neural network for analyzing images. And if we're using this AI model just to tell us what's in the image, this is the classic pattern. So we've got convolutional layers, fully connected one, and at the very end, we've got the final nodes that say, is it a flower, is it a person, is it a car? In this case, it predicts flower, and that's it. If we were to use this to sort of classify all images of flowers, we would have 1 million images that all have just one label that says flower. And then we can't really distinguish between anything in that bucket of flowers. Like there might be flowers that are very similar to each other compared to others. It might be like nice yellow, like daisies and red roses. But to this model, they're all flowers. Flower's a flower. So not very good if we want to find like really similar images, or really like what is similar to a daisy. Let me show me all the flowers that are similar to daisy. This doesn't do that. It just says flower's a flower. So kind of a silly model. But it can be turned into a really cool model by actually just removing one layer. So if we want to turn this into an embedding model, we just chop off the last layer, and now we're left with just that fully connected layer. It doesn't tell us immediately what it is, what we're looking at, because it doesn't have that is flower, is car, is anything. It doesn't have that. But what it will have is some random looking numbers if we feed in, say, an image of a flower. And to us, initially, this doesn't really make any sense. Like we don't know what each of these numbers really means. However, if you start feeding in loads of images, for example, of loads of images of different flowers, and then you take all these numbers, compress them down, and then plot them on, say, like a 2D space, something really cool happens. So here's the really cool thing about embeddings, which is what that last thing was, is that similar images will produce similar vectors that we can plot. And here's an example of one. And let me just look in this, and we can actually zoom into this. So this is a model. We fed in loads of images, or someone else fed in loads of images into this model, and then they plotted them all out. And although this model wasn't specifically designed to, say, predict what a panda is, it can still work out that, oh, there's loads of dogs, pandas are similar to dogs, and then kangaroos are in there. And you might think, oh, they're not that similar. But when you compare it to the rest of the data, over here we've got insects. They're all grouped together. Insects, funny enough, are seem to be grouped together similar to vegetables that are also like green and colorful. And you're like, oh, that kind of makes sense. Now, the machinery model wasn't explicitly told to class them like this or to cluster these sort of like things together, but it's just done it automatically because that's the way it makes sense of the images. When you compare all the images together, it worked out that those are actually kind of close together. Let's put those together. Fruits and vegetables are similar. Those are all together, like spatially. And that's it. That's sort of vector embedding. That's how that kind of works. And we've got this sort of big map, this 2D space now. We can now turn this into a search algorithm by just say, here's a new image, feed it into a model, create those same embeddings that we produced with the previous model that I showed, and then put it back into this space. So for example, if I put back in, so here's a flamingo, let's say I just fed that in, it would put it in this same space. And then we can ask it, okay, what are the pictures that surround the flamingo in this kind of picture wall? And it will find, oh, there's another flamingo, there's this more tropical bird, there's this big white, this kind of like a walking tall swan. Those are all similar ones. And you're like, oh, that kind of does make sense. They're both long, elongated birds. And that's the powerful ML search that we want. And we want to apply that to works of art. Because you can imagine a piece of art that's abstract. We want that grouped with lots of abstract paintings that maybe have lots of people in them, put them to another thing. Sculptures, those would be their own section. And within that, there'd be other sculptures. So let's take this exact same thing and see how we can apply that to art. So we're gonna jump back, and this thing that I just showed, where it was a map, and we're like, okay, let's say we feed in a new image, find me the similar images. That's called nearest neighbors. It's actually like a type of machine learning model where you feed in a data point, and it just immediately tells you what the 5 nearest data points are. It's very powerful when it comes to search, and in fact, we have that. So Google has a tool specifically for doing nearest neighbors. So we call it the Vertex AI matching engine. And it does exactly that. It just does vector similarity, also known as nearest neighbors, at incredible scale and low latency. So you don't need to build a database from scratch or work out how to measure vectors to each other. You just generate vectors. And I'm going to show how you can do that. And then you feed them into this tool, and it will automatically create the database, the search index, and an endpoint that you can just send new vectors to and get, here are the 5 sort of image vectors that are closest to that image vector. And it'll create all that as an API. And there's a link to where you can find out more about the matching engine there. So we've got our nearest neighbor search. We've got that done. But what is going to be the model that's going to create our vector embeddings? Because as a machine learning engineer, the last thing I want to do is to create a new machine learning model. So ideally, I want to use one that's pre-trained. And for that, we have the TensorFlow Hub. So if you're not familiar with TensorFlow Hub, this is a website that stores lots of pre-trained machine learning models that you can just use with only a couple of lines of code. And for our specific use case, I can show you how to find them. So we go into the models, and we can see we've got text embedding. So although I've showed how you're doing this with images, you can apply this to virtually any sort of unstructured data. So text embeddings is a big one. So if you want to create a really powerful book search or something, you can do it there. You can do a similar thing for video and audio. Audio embeddings are kind of hard to, how is audio similar? Well, you can use audio embeddings and use the same technique. But I want image embeddings. And oddly enough, they call it feature vector. Feature vector and image embeddings kind of are synonymous. So we'll look for a feature vector model. And a nice one would be, what was the one? I think I used one here. This is it, MobileNet. Very common one. And they've got a collab, which has got all the code to immediately test it out with images that they've got, but you can also feed in your own image into this code. And this will walk through loading in the model and feeding data into it. I've already done that, so I'm not going to go through this code, but if you are interested, you can see how I got there from the TensorFlow. You just click on Open Collab Notebook. We'll jump back. So that's the model we're going to use. Then the data source. Where are we going to get all these photos of galleries and all that stuff? Well, obviously, we're going to go to the Google Maps API, because built into the Maps API, as you're familiar, if you're searching for if you search for galleries in Google Maps, you'll get the gallery listing with all its information, but you also get photos. You're like, okay, that's interesting. I don't have to go to the gallery's website to get the photos of the art. I can just look at the photos that are already part of the listing in Google Maps, because quite often people are taking photos, even though they probably shouldn't, are taking photos of the works of art and uploading them as in the Google Maps sort of thing. And built into the API, specifically the Places API within Google Maps, you can get the listing as well as the photos. So I'm going to use the Google Maps API to, first of all, get all the galleries that are in the UK, and then also go through those and get all of the photographs listed for those galleries. So then I've got a nice data set of galleries that are real in the UK, along with photographs that are taken within those galleries. So that's going to be my data source. And now, the process of actually building this very specific but powerful ML-driven search engine. So as I stated before, I'm going to use Google Maps to get the data. So I'm using their APIs you can query specifically for galleries, and I added a few other things. I think I looked through all the different counties within the UK, so all the different regions, and said, okay, give me the galleries for this region, the galleries for that region. I just looked through them all the most popular ones. And then for each of those gallery listings, I think I got about 10,000 galleries. For each of those listings, go back and get all the photographs, or I think maybe like the first 10 or 15 photographs of that gallery listing. Then took all that data, because I want to build a nice web app. I threw that all into Firestore. If you're not familiar with Firestore, it's a NoSQL database with lots of cool APIs to connect to web apps. So I put the gallery information into Firestore so I can access it quickly. And then I put all the photos into cloud storage, which I can also still access easily. Then I've taken the pre-trained model that I got from TensorFlow Hub that's going to generate that vector that represents kind of what's in the image. And I've deployed it with Vertex AI. So what Vertex AI is Google's sort of ML ops platform. So anything you want to do with ML in production, Vertex AI probably has a tool for it. So Vertex AI allows me to just deploy a TensorFlow model and have it hosted as a scalable endpoint. So I'm going to throw my TensorFlow-like model up there because I'm going to be needing to use it whenever I want to make new sort of searches. So it's going to be deployed to Vertex AI. And then when it's deployed, I'll actually use that endpoint to generate, for all the photos I've got, I'm going to use that to generate all the vectors for those photographs. So it's going to generate thousands and thousands of these numbers that kind of represent each photograph. And all those vectors are going to be stored in the Vertex AI matching engine. So that's going to do our nearest neighbor search with those vectors. And the matching engine is insanely performant. It makes the prediction as to which are the closest vectors in like a couple of milliseconds. So it's a really, really cool piece of technology. So that's it. That's the whole process, building a unique ML search engine effectively. Now, when we want to make a search request, we will take our image. We will generate its vector using the TensorFlow model that's in Vertex AI. Take that vector, send it to the Vertex AI matching engine to find the similar vectors that are close to that. When it finds those similar vectors, those will have IDs that link back into Firestore to find the galleries that those photographs sort of map to. And that's it. That's the entire pipeline. Now it's time to try it out. So this is a domain name that I'm very proud that I came up with. You can actually go to this now and play with this app. So I'm going to show you what that's like. So it's called findmy.gallery. And here's what it looks like. Quite simple. And also the UI, it works with small images. So I'm going to got a piece of art. Let's upload something cool. So we've got, let's see, pieces of art. I've got, these are all pieces of art. So let's upload something. So what it's going to do, it's going to initially send a request to get this image turned into a vector. I've created a kind of weird visualization of the vector itself. The vector is 1,000 dimensions. So it's 1,000 numbers, give or take, that represent kind of what's in the image or what the ML model understands about the image. And I represent it here as a weird sort of, I think these are called like polar spike diagrams. I don't know. But then it takes the same vector, feeds it through the ML, the matching engine, the Vertex AI matching engine, and that returns back photos. And here they are. So I've uploaded this one. We can kind of see, even though this is a really cool thing, even though I've used an off-the-shelf ML model that's not specifically designed to analyze pieces of art, you can see how it is pretty much working. You can see this shape has weird geometric symmetries. The thing that it says matches it closely is this. Yep. This piece of art would match up with this one. That one, not so much, but still, okay, this one's really weird, but there we go. Let's see. And what I've done in this app, if you click on an image, it will feed it back into it. So you can kind of walk through the art gallery space until you see something you like. So, okay, here's vibrant. So we've got vibrant things. Okay, cool. Okay, let's actually try it with one of Kimberly's pieces. So we've got this. So here's a piece of art. Now, something interesting happens here. We've got uploaded photo. This kind of cool, kind of matches. But something's interesting. It's analyzing the image as a whole. So we're seeing a lot of images of photographs of the canvas. So that got me thinking, what happens if I just crop in on the photo? Do I get different results? So I've taken a screenshot of just what's on the canvas. And if I go to the desktop, there we go. Look at that, you get different results. So it's kind of an interesting sort of quirk about the way I built this, because it hasn't been optimized for detecting the art within the photo. It's just looking at the whole photo. If you upload a photo of a canvas of art, it will return photographs of canvases of art. So if I crop in, I get more. This is very interesting. These kind of results are a bit better. And that got me thinking, how can I fix this? And a quick thing, the last thing I will show is if I wanted to improve this, still without having to train my own model, but I wanted to automatically crop in on the works of art, I could simply use the Google's Vision API, because I didn't think this would work until I just tried it. But if I upload a piece or an image that clearly is of works of art, so let me find, there we go. Clearly of works of art, automatically it will detect all the different pieces of art with a bounding box that says this is a piece of art, this is a piece of art, this is a piece of art. So you can kind of imagine how you could tie this into the system to further refine it by automatically cropping in on the piece of art and then analyzing just the art picture, which would give, as we've seen, better results. So that is it. That is how I built a visual art search. Here are some links that talk about, if you want to find out more about Vertex AI, includes stuff about matching engine, which is the nearest neighbors thing, TensorFlow Hub for all the pre-trained models, and the last bit, the Vision API, which just out of the box, without me having to do anything, automatically detected the pieces of art, which I could have then used to crop in and improve the performance of the system. So thank you all very much, and I'm happy to answer any questions.
Thank you for a wonderful demonstration and presentation, Zach. I was curious if we could extend this by having pictures for landscapes and identifying places where those pictures were taken, or those art forms were actually painted. But I don't see many questions. But yeah, I think it was self-explanatory, and at the same time, it was really cool to see a real-world application of all the different tools from TensorFlow to Firebase.
Cool. Yeah. It's really, because usually this application of image embeddings is kind of seen as like a fun, quirky thing, and like, how would you actually use this? But it turns out really powerful in search. So anytime you want to search unstructured data like videos, images, that's where embeddings are insanely powerful. So yeah, if you're building your own custom domain search, this is where machine learning is insanely powerful.
Yeah, and I'm thinking of eventually going back and seeing if I can apply that to places I've been and putting some of the pictures I've taken to see if it can actually, extend that further.
There you go.
Or pieces of art, maybe.
Yeah.
Okay, with that, I'd like to say thank you, Zach, for the wonderful presentation. And it was great to have you, and we hope to have you again in the future.
Cool, no worries. Thank you very much.
Thanks.
Take it easy.
Bye.
Bye.
Okay, so we've come to the conclusion of our Devfest Norway. We are very happy. We did this at a short notice, but we are happy with all the wonderful speakers and the topics that we had. We'd like to thank Google for supporting us in this process of hosting Devfest Norway. Some of our fellow organizers are not here, but Ivan wants to say something.
Yeah, and that people have kept with the stream for 6.5 hours now, non-stop streaming. That's kind of amazing. So whoever
that shows the quality of our speakers.
Yeah. So
okay,
it's been an interesting Devfest.
Yeah,
to put it like that.
On short notice, but we'll put up the the videos of the speakers eventually. And any last words from you, Leonard?
Nope. Yeah. Hope everyone had a fun time.
We thank all our speakers, all the audience, and also the support from Google and all our fellow organizers. So we say thanks and hope to see you again later this year.
Yep. Bye-bye.
Bye.
Bye.
We've already started to see the difference we can make by working together as a community.